lines of effort that include advanced manufacturing and industrialized biomedicine in space, with a lot of the capital coming not from just the American taxpayer, but capital coming from private industry, improving the lives of humans here on Earth. And that's what the commercial industry is all about, and that's why we need commercial astronauts. So the vehicle that we're in right now is called the Astro Van. Tell me what does that mean? What is that all about?
This is the second generation of Astro Van. This is what we'll use to take the NASA astronauts from crew quarters, which is in sort of the industrial office area, about 7 miles or so out to the launch pad.
Okay.
So it takes about 15 minutes to get there. It's you know, we always used to say it's one of the longest and loneliest rides you'll ever take in an Airstream trailer. But and it was interesting along the way. You drop off various people, and then you realize the only people left on the van when you got to the launch pad was the crew. So we always used to joke that the smart ones got off.
So Tori, we're at Slick 41. Tell us, what is Slick 41 and what do we have behind us?
So Slick 41 is the home of the mighty Atlas rocket. This will be our 81st launch of this rocket. So this giant manifold here is part of our acoustic suppression system. It's going to spray water, unmistakable when you see the launch go off. You'll see all that water. Most people think that's for fire, but really the interesting thing is it's not. It's for sound. Because when the rocket clears that launch pad, the sound coming out of those rocket motors and rocket engine is so loud, if it reflected back off this pad, it would damage the spacecraft. In fact, if you could stand here and somehow survive the fire, the sound alone would kill you.
Oh, wow.
And so all of that water present on the pad absorbs the acoustic energy and protects our payload.
Well, make sure that water works. Can you do that?
I will absolutely double check it. So those big white cylinders you see on the side are solid rocket motors. They give us extra impulse coming up off the pad. That's a lot of propellant, and it's going to generate each one of those almost 400,000 pounds of thrust. In the center, that big tube in the middle, the bronze-colored one, that's our main propellant tank for the center core. We can step up here. So that's the real McCoy, all 109,000 pounds of solid propellant. And that's a heck of a view.
It's pretty awesome.
Yeah, 190 feet straight up.
Mr. Administrator,
Mike.
Welcome to the 12th floor.
Thank you. It's good to be here.
Sir, good to see you.
Good to see you guys. I'll tell you, it looks tall from the ground, but when you're up here, it feels a lot taller than it looks from the ground, especially with these winds. Well, I'll tell you, you can really feel the wind when you're up here, and I can imagine maybe tomorrow the wind won't be so high, but certainly I can imagine when you go across this. You know, I know it's an access arm, but it looks like a very narrow catwalk, if you ask me.
Well, we'll be coming out here in our spacesuits.
Yeah.
And we're going to be, even though we're steely, aviators, we're still going to have a lot of emotions. This is our last moments on planet Earth before we go launch into space.
Yeah.
And the winds are actually a blessing, because in space station, there is no wind, right?
Right.
And so everything's the same all the time. And then here we're getting like a kiss from Mother Earth as we get ready. So we walk across here, we walk down this access arm, we can feel the positive energy from all the people that have worked so hard on this mission, and then we go in and close those doors. We're just feeling proud, we're feeling a little bit scared, a little bit anxious, but we're like totally trusting our training, we're totally trusting Team NASA, Team Boeing, and the United Launch Alliance.
So of course you can see your Starliner sitting there on top, and that's where Spanky and I and Fergie, when we climb in through the crew access arm, right into the side hatch we go to Starliner. On the top of that is the IVA hatch, and that's what's going to dock with the International Space Station. Beneath Starliner, you can see the service module. That's where it has a lot of our life support system, our prop, the engines while we're orbiting and maneuvering in space. And then below that, you can see this amazing Atlas fiber rocket.
Well, I'll tell you, what you guys are doing is going to inspire the nation, but not just our nation, also
people all around the world that are going to be watching this. So thank you so much for what you do.
Thanks for the opportunity.
Thank you.
Thank you, sir. We'll do well.
All right.
Sonny, what are we doing here?
So we're at Spacecraft Launch Complex 41, standing in the shadow of the Atlas V with the Starliner on top, with the crew access arm connected to it, ready actually for people to eventually get on board. We got Rosie, the mannequin inside that is instrumented, and so we're going to get some data to see what our ride's going to be like when Josh and I actually get to fly on this thing, probably at the end of next year.
Great. And Josh, what's your role in this?
To not mess anything up is the goal today. This is the capsule that Sonny and I are going to have a chance to fly in, along with 2 others. And so we're following the whole process from beginning to end. You know, from launch tomorrow morning to docking the next day and to landing a week and a half later. For me, it's just a situation where I find myself pinching myself. It's just, it's incredible to see this happen. We're living science fiction. It's really happening right here.
We've actually done a lot of engineering work with the Boeing team to work on the software, so when the humans are interacting, they've got that situational awareness of all the automation that's processing in the spacecraft and how we would recognize if there was an issue or a problem and how we would interact with it.
We're looking at where our future is. We have a $400 billion space economy. What you're doing is leading the way for that space economy, lowering the cost of space travel and providing more access to more humans on Earth to get to space. It's about expanding the human condition by finding new knowledge. And I'm just so proud to be with you, but that's why we're here. So I thank you for what you're doing.
This is a new era in human spaceflight. And there's a number of reasons why this day is so important. We are on the cusp of launching once again American astronauts on American rockets from American soil for the first time since 2011, the retirement of the space shuttle. So this is a big day.
How many of you have seen a rocket launch before? Can I get a show of hands? Oh man, you got, okay, how many have not? Let me put it that way. This is the group I want to talk to, all right? Anytime a rocket ship leaves planet Earth, it is an experience. I don't care what's on it. And you see it, you feel it, you experience it, it's emotional.
Welcome this morning to NASA's Kennedy Space Center in Florida.
Starliner is nearly ready for our uncrewed orbital flight test. You can see it over our shoulders, lit up on the launch pad. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, and liftoff. The rise of Starliner, a new era in human spaceflight. Good job.
And Atlas V is now traveling at over 5 times the speed of sound. And we have BECO booster engine cutoff, standing by for stage separation. And we have good indication of stage separation.
We had a great launch this morning, and the Starliner is now in orbit around the Earth, and that's because of the great work that you here at Boeing have done with your partners at NASA. That's important, and it needs to be recognized. And I know, I look around, I see a lot of people that are concerned and worried about the fact that the insertion burn did not go according to plan. And it's of course a concern to me as well. It's a concern to all of us. But here's why we test. Because we're going to learn things. And from what we learn, we're going to make changes and we will move forward. That's what we do. And so this is a good day. It's a good day.
We train extensively for this type of contingency. And had we been on board, there could have been actions that we could have taken. This vehicle is a new level of automation that we've never seen before. And so what we're really doing is we're testing that automation, and that's why you have test pilots on board, especially for these early missions. That's our job, that's what we're trained to do. We are looking forward to flying on Starliner. We don't have any safety concerns. Everything on the ascent, all the systems that would keep us safe have functioned properly on the launch and currently on the vehicle. We're looking forward to all the test data, and we're looking forward to a landing at White Sands.
Good morning from Starliner Mission Control in Houston. It's December 22nd, 2019, and we think this will be a day to remember.
We have chosen the longest night of the year to bring Starliner home. Happy winter solstice to everyone. Starliner flight control teams have been working around the clock to get Starliner set up for a safe landing, and today is the day. The entire team here in the room is quietly watching, making sure all the systems continue to look good.
And we see three main chutes. We see the red, white, and blue as Starliner descends. Base heat shield has jettisoned. That is the base heat shield falling away as planned. Airbags are inflating.
And that is the last of the milestones, so now all that's left is for Starliner to float down to the surface of the desert.
And Starliner touches down in the desert in New Mexico. An historic landing in White Sands, New Mexico concludes the first flight test of Boeing's Starliner spacecraft. The first time an American-made, human-rated capsule has landed on land.
Congratulations, Starliner.
Congratulations, indeed.
This is my first spacecraft landing. It was incredible in sea. We're so excited for the Boeing and NASA team, and the recovery forces today did an incredible job.
Yeah, we got a lot of data on the launch, the orbital portion of the flight.
Being able to just watch the entire sequence from the ground on down was just fantastic. Really clean landing.
We had a beautiful, amazing team all out here ready to support. Everybody was pumped. Everybody was cheering. It was spectacular. I mean, she's back. She's home.
We are really, first and foremost, pleased with how this team came together. Flying a different trajectory, different aero shape. You can only test that at scale. That went terrific. Return is something that you can't really test. You got to put your heat shield on and go through the heat regime. Today we just had, it couldn't really have gone any better. The ground crews, Chris, Nicole, Mike, they're telling us there's hardly any charring, perfectly level on our airbags, and that bodes really well for reusability. From an overall perspective, we are just as pleased as we could be with the design.
I would say the team did just a tremendous job. What you find sometimes is when you execute a flight differently than planned and a mission test flight differently than planned, that team comes together in a unique way. And the NASA team, the NASA engineers, the flight control team, the Boeing team working side by side to solve problems in real time, to come up with innovative solutions, to keep decisions ahead of them, and then to end up like today where we had a successful deorbit burn and entry and landing. If I look back at this year from a commercial crew perspective as a program, you know, we've had a tremendous year. With the holidays in front of them, they just did a tremendous job, and so my hat's off to them.
So number one, congratulations. I know the last 48 hours have not been easy. So when you think about a mission like this or a test flight like this, when we think about this, launch, of course, is a big challenge that has to be overcome. That happened. Flying the spacecraft and making sure that the systems work, that happened. Entry, descent, and landing happened. We're going to get a lot of data, we're going to get a lot of information, but a lot of really, really good things happened on this test flight. It is also true that when things go wrong, that's when you learn how the teams work. I'm telling you, that was a thing of beauty. And everything that I've been told from the people that were in the room, decisions were made quickly, things happened that were not planned, and because of that, this test flight was actually very successful in so many ways. So thank you for all of your service to the country and all of your service to NASA. So thank you.
Well, pilot call signs are kind of the nickname that you end up getting with your squadron or the group of flyers that you fly with.
You can have a lot of different ranks flying together. Instead of having to call someone sir or Lieutenant Colonel so-and-so, they can call them their call sign.
How you can get a call sign is one of two ways. It can either be a natural fit to your last name or your first name or combination thereof, or the other way you can get a call sign is by doing something really dumb.
Mine have never necessarily stuck. I've had several throughout the years. One of the reasons I don't really have a call sign that sticks is because I go by my middle name, and it is relatively unique unless you're in Sweden or Norway. So because of that, everybody thinks it's a call sign, but it's really my name.
My call sign's Ringo. It's just basically a play on my last name of Ringelberg. It's easier than saying Ringelberg, so it's kind of one that sort of stuck with me. And it wasn't because I screwed anything up.
I showed up to lead-in fighter training in the Air Force at Holloman Air Force Base, and I walked up to the duty desk to report in, and one of the instructors there took a look at my last name, got on the PA and said, all available pilots report to the duty desk. They came up with Clue, making me clueless.
My call sign is Trasher. When I was a kid, that was a nickname. I got into the military and became an Air Force pilot. That nickname came back as a nickname, but it wasn't ever really earned, and I had a couple of other call signs along the way. But one particular incident, I was flying B-1 bombers up in South Dakota. Now, a B-1 bomber has 4 great big engines that put out a lot of thrust. It's not something you want to stand behind. And as we were taxiing out for a flight one day, I had a problem with the aircraft and had to stop. And while I had stopped, the young airman who had been marshaling me out of my parking spot thought he was finished, and so he began to walk off. He errantly walked behind the airplane, which was okay at the time as I was stopped with the power and idle, but as I got my problem fixed and started to roll forward again, I pushed up the power, literally picked him up off his feet and blew him down the concrete ramp about 100 yards. Fortunately, he was okay and just had some road rash and cuts and bruises and tore up his uniform, so I had to buy him a case of beer and a new uniform, and after that my call sign was cemented in as Trasher and remains that to this day.
My call sign is Gucci. It's not the coolest or the most macho call sign that a guy would look for, so I had no choice in it and I haven't been able to get rid of it. I was flying KC-10 tankers and I applied for the high altitude U-2 program. When I arrived there, the first question that everybody had for me was, why would you leave a nice comfortable job like that, nice big airplane that has perfect air conditioning at 72 degrees, coffee makers, ovens, refrigerators, nice comfortable seat, to come put a spacesuit on and live in a cramped little capsule. So the KC-10 guys were nicknamed the Gucci Boys by the rest of the Air Force because they only went to big airports around the world, 5-star hotels, things like that, because you couldn't put that big airplane just anywhere. And so they said, hey, why would a Gucci boy want to come to this kind of lifestyle? And that's when it kind of stuck. There is, rumors out there that have run around historically that maybe I paid too much attention to my clothes or my hair or the Maserati or stuff like that, but that really has nothing to do with the call sign and the way it was awarded. So unfortunately, you get stuck with it. I'd like to have something more cool like Maverick or Sharpshooter or something, but it doesn't work that way. I got Gucci, so it's all about leather shoes and handbags, and I can't change that.
I'm a brand new combat wingman in the F-15 in Japan, It's my first war exercise, so it's like day one as a brand new wingman. We're gonna take off and go fly a night mission, and right before takeoff we have to get our orders from secure radio to headquarters, and my flight lead checks me in on the secure radio, and I can't figure out how to make it work because I've never seen it before. I'm looking down at this panel that has XYZ, ABC, and I don't know what to do. There's no on-off button, so I do my best and am not on the radio frequency. He gets the orders for us, we take off together, fly our flight, come back in and land. Once again, I have a few moments to look down at this radio. I still can't get it to work, so once again, I'm not on the radio with him, with headquarters. My flight lead saved that story until it was my naming night, and because that radio is called a KY58, they said, KY, Jelly, is your call sign, so I earned it that day for being dumb.
Flying cars, drones delivering pizzas, and a highway in the sky are scenes from science fiction, but they're also visions of our very real future.
Because we also moved this in and then that in.
At NASA Langley Research Center, NASA engineers are laying the foundation for safe autonomous flight in the national airspace through a project called Pathfinder. The goal of Pathfinder is to take separate urban traffic management projects and combine them into a single autonomous vehicle. Then have that vehicle fly and communicate with other autonomous vehicles in the airspace.
Going back a couple years, we did a lot of on-vehicle testing, so we were testing things like Icarus, which is an autonomous sense and avoid, or maybe an autonomous flight management system for UASs, as well as Safe to Ditch, which is an autonomous safe landing or autonomous crash management system for UASs.
Combined, these systems will greatly decrease the risk of unmanned systems flying near manned aircraft, as well as safety risks for people below. To test this, researchers created incursions, where one drone flies too close to another, and then examining 3 different means of separation.
One is just manual, where the UTM operator has to get engaged and see that there's an incursion coming and then issue a command to the ownership vehicle to maneuver out of the way. Another form of air traffic separation we looked at in Pathfinder was called geofencing. And the third level was autonomous sense and avoid, and that engages another area of Icarus.
Icarus, or Independent Configurable Architecture for Reliable Operations of Unmanned Systems, is a major piece to this autonomous flight.
You need to be able to make decisions to avoid other intruders in the airspace, stay clear from no-fly zones, or if you're inside a no-fly zone, the UAV should know how to get out of it, and to reroute itself around obstacles and no-fly areas. So some of these functionalities are essential to operate autonomously without human intervention, and so that's where Icarus comes in, and it provides those capabilities for UAVs.
As researchers conduct flight tests in the field, another piece of the Pathfinder puzzle is taking place in a separate location.
Copters beginning turn to the east.
Similar to an air traffic control tower on a standard runway, NASA Langley's Air Traffic Operations Lab is monitoring and making control decisions of active UAV flights.
These operators are observing their own vehicles, so their own small drone, and they're also observing vehicles that are operating near their vehicle. So the goal is to make sure that they maintain separation from all other vehicles.
Originally, these volunteer operators were going to be monitoring from the field. But after a unique communications link was created to connect the atoll with the vehicles on the range, participants can now monitor the vehicles and traffic from afar.
This was sort of a first step for us. Ideally, in the future, we'd like to expand on this capability because it has a lot of potential. We have a lot of capabilities here in the atoll for human factors research, and out at the certain range, they have a lot of capabilities for live flights. And by creating this link, we're really opening up the door to a lot of future research.
As Project Pathfinder nears completion, the team has moved from flights on the range to cross-center flights, taking off from the roof of a central building and then autonomously flying out to the range.
It's exhilarating, really, to watch a system that you worked on. You've developed the algorithms, and then to see it perform out there. It's really a joyful experience.
It was a great team. Everybody was really putting in a lot of effort to bring this all together. So that was really something I'll remember going forward from this project.
For about 50 amps. 200 meters to waypoint set. 100 meters to copter turns north.
An idea born in unsettled times.
We are going forward. America, the United States, is first in space.
Becomes a feat of engineering excellence. The most complex machine ever built to bring humans to and from space.
Ride your roll, Discovery.
And eventually construct the next stop on the road to space exploration.
We are on a true spaceship now.
As 30 years of flight draw to a close, its legacy is one of unsurpassed achievement, tragedy overcome, and opportunity met. NASA Space Shuttle. Space Shuttle Endeavour is rolling out to Launch Pad 39A at NASA's Kennedy Space Center in Florida. In 24 missions, flown over 20 years, Endeavour has logged more than 103 million miles in space. The last of NASA's shuttles to be built, Endeavour prepares for her final flight, STS-134.
I marvel at when I see the space shuttle up close and personal, behind the panels where we have hardware, plumbing, black boxes, electronic devices, and that sort of thing. The workmanship that I see in this is astounding. And that points right at the people that do this. When you integrate all that together, it results in what I think has been a marvelous program with the space shuttle.
Well before any shuttle reaches the launch pad, however, a staggering amount of work is required. The parts, plans, and people necessary to make each launch span the entire nation. One single goal is the focus: the safety of the orbiter and her crew.
You've got all these people, all these folks that are in their 20s, some of them in their 30s, and they are, no kidding, in charge of some part of the space shuttle, some part of the space station, or some part of the plan. And every one of those people absolutely believes that they are the one that makes the difference on getting those astronauts back down to the ground alive.
At NASA's Mission Assembly Facility in New Orleans, production begins on the shuttle's external fuel tank. The last of 136 produced here since 1973. Each one 154 feet tall and 27.6 feet around, is capable of handling 535,000 gallons of liquid hydrogen and oxygen, enough to fill 13,375 average household bathtubs. 3 versions of the external tank were created during the program in an effort to reduce the tank's overall weight and allow for heavier shuttle payloads. Around the same time, in Clearfield, Utah, technicians at ATK Launch Systems start work on the shuttle system's solid rocket motors, or boosters.
Fire.
Together, these SRBs produce nearly 6 million pounds of thrust, about 83% of the thrust needed to push the orbiter into space. The remaining 17% is furnished by the shuttle's 3 main engines, fueled by the external tank. Unlike the orange external tank that is used only once, the boosters detach themselves. and parachute into the Atlantic Ocean. They are then retrieved, refurbished, and reused on later missions. The shuttle mission's crew is assigned.
Folks on there that are like my brothers and sisters. I mean, we really do get close after a year of training for a flight and having flown in space together. And there's a special bond that comes with that.
Right up until launch, a shuttle crew will train in a variety of critical regimens, some basic, others specific to their mission. Simulators, safety and contingency, science experiments, and underwater in the world's largest indoor pool. STS-134 astronauts floating in actual spacesuits, trained to work during extravehicular activities, or EVAs. The Neutral Buoyancy Lab, or NBL, at NASA's Johnson Space Center in Houston, is the best simulation of microgravity on Earth, and ideal for practicing spacewalks.
One of the most amazing facilities that we work in is the NBL, the Neutral Buoyancy Lab, and the divers and the guys who help us run the robotic arm are all there to ensure that our spacewalks are flawless. Their efforts in that pool have helped us and made us able to have this program.
Every step of a spacewalk, every step of EVA is so critical, and even though we see it every day, that's what that one little safety tether could be life or death.
For every hour that they spend in orbit, they'll spend 5 to 6 hours training for that same task. So we've built up from the suit engineers and suit technicians who help them get into the suit. Now we've got trainers who help them learn how to use the suit and learn how to understand the suit. And then we've got divers who support them while they're in the pool. The closer they get to actually flying in the suit, the team of people who help them tends to grow. Maybe not exponentially, but it's certainly getting bigger.
A 12-person crew has kept a week-long vigil, while the barge, carrying with E.T., made the 900-mile trek from Louisiana to Florida's central east coast. The iconic orange external tank finally arrives at the Kennedy Space Center. 1 month later, the E.T. is mated to the solid rocket boosters to form the backbone of the stack. Now, all that's missing is the spacecraft itself. When an orbiter returns from a mission, processing for the next flight begins almost immediately. It's a task requiring no less than 650,000 hours of labor. This includes the removal of its 3 liquid fuel engines and their replacement by 3 from a previous mission. They've been refurbished, inspected, and tested at the Stennis Space Center. With most of its flight preparations complete, Endeavour is towed in what is called the rollover, a short roll over a quarter-mile distance on a 36-wheeled vehicle from the Orbiter Processing Facility, the OPF, to the VAB. Here it undergoes its flight configuration. The rollout. Looking now much like it will at liftoff, the space shuttle is carried to the launch pad atop the 6 million-pound crawler transporter at a blazing pace of less than a mile an hour. Not exactly warp speed.
At our peak carrying full load, we get right around 38 feet per gallon.
Not too bad for an original 1965 hybrid vehicle with low miles. The 3.4-mile journey takes up to 6 hours. Just enough time to appreciate the route's picturesque surroundings. Kennedy Space Center is situated on a national wildlife refuge. Bald eagles, osprey, and vultures are just a few of the scores of bird species regularly spotted in local skies. Both land and sea are home to a wide variety of creatures, including manatees, dolphins, and of course, the ever-present alligator. Visitors are always urged to watch their step. Now on the launch pad, the orbiter is ready to take on its main payload. Testing assures that the multi-ton cargo is secured and safely stowed in the payload bay before the technicians certify the orbiter is ready for launch. Flying T-38 aircraft from Ellington Field in Houston, the crew members arrive at Kennedy's shuttle landing facility.
But finally the day comes when you're there and you're getting ready to launch. And you go into launch countdown and it's like going up the hill on that roller coaster. It's full of expectation and you're both thrilled and terrified at the same time because anything could go wrong, but when it goes right, it's a thing of beauty.
If there are no issues or concerns, technicians begin fueling the external tank with volatile liquid hydrogen and oxygen.
The predominant emotion is pride. There's a tremendous sense of pride in all that not only that you do, but that your teammates do, that people in this very firing room do, and folks all across the country.
This is shuttle launch control, T-minus 9 minutes.
At the T-minus 9 minute hold, the launch director leads one final poll.
We finally come out of the hold at T-minus 9 minutes. I sit back and I watch my data, but I know that there are souls on board that ship whose lives are depending on the launch team to make the right decisions. It's, I don't think about that consciously, the decision-making, authority and responsibility. I know it's there, but I do think consciously about the crews and the people we're about to put on top of a controlled explosion and get to orbit.
This is the NTD conducting the launch status check. All stations verify ready to resume count and go for launch. OTC, OTC go. TVC, TVC go. ETC, ETC's go. LPS, LPS is go. Houston flight. Houston flight is go.
After nearly 3 years, hundreds of thousands of hours logged by engineers, technicians, scientists, seamstresses, electricians, and other program workers across the globe.
We have main engine start. 2, 1. Booster ignition.
The shuttle makes its way skyward. At liftoff, 6.6 million pounds of thrust begin hurtling the vehicle and crew at speeds that'll reach 17,500 miles per hour. The shuttle is like no other machine ever built. For its launch to succeed, more than 1 million parts must move together perfectly. How this engineering marvel came to be is an amazing story that begins in the early 1970s. The Vietnam War is divisive and costly. The economy is sliding into recession. And with the race to the moon already won, the Apollo program is canceled. A new mission is sought for NASA to send humans into space. But Mars, for many the next logical step on the path of exploration, is dismissed as too costly, a destination for a country preoccupied with events back on Earth. Instead, on January 5th, 1972, another destination is selected, low Earth orbit. As early as the mid-1960s, NASA had concluded that the technology was available to build and fly a reusable spacecraft.
President Nixon really liked the idea and told the NASA administrator, go do it. And the NASA administrator got a call from OMB the next morning, someone there, and said, hey, what the president really meant to say was, you're going to get this much money, and so do as best you can with the space transportation system. And our choice, logically, was, well, you have to have a vehicle first, and so that was the birth of the space shuttle as the first in the 3-part space transportation system.
Many designs were considered. Often, they combined the best features of different concepts.
At that time, they were looking at having jet engines on the shuttle for landing and for transporting it across the country.
The idea of the lifting bodies
was to bring astronauts home to conventional runway landing. Previously, all of our spacecraft, which were capsules, came down in the ocean. Someone came up with the idea of a vehicle that could land like an airplane.
The key thing was to understand aerodynamic stability across the hypersonic, supersonic, subsonic, and landing speed type of environments that a single vehicle has to fly safely. That was the key thing that was learned from those, and you'll see it reflected in the shape of the space shuttle.
One was the use of a lifting body, an aircraft with no conventional wings. Only its fuselage would keep the aircraft airborne and guide it safely back to Earth.
They were known as the flying bathtubs. For the first test, the M2F1 was towed behind a car, a souped-up Pontiac. Whitey Whitesides drove that Pontiac across the lake bed at about 120 miles per hour, dragging this flying bathtub behind it.
As well as groundbreaking, their tests could also prove ground shaking. The X-24B, a lifting body with wings, was the first such craft to land on an actual runway, as all shuttles would eventually do.
Early on, the space shuttle was going to have jet engines to return for a horizontal landing, much like an airliner. The X-15 had proven fairly specifically that they can make horizontal landings very accurately, unpowered, flying a steep glide slope, that they could do a horizontal unpowered landing with the shuttle.
As they tried to narrow its size, shape, and weight, engineers also considered how this new orbiter would be propelled safely out of the reach of Earth's gravity. At the Marshall Space Flight Center in Huntsville, home of the rockets that had sent every Mercury, Gemini, and Apollo astronaut into space,
All engine running. Liftoff. We have a liftoff.
design teams would devise the partially reusable propulsion system that would finally be adopted.
The main engines were always something we paid very close attention to. Lots of moving parts, lots of high energy in very tight places, and very cold liquid on one side of a very small wall and very hot on the other side. When that thing finally lit off, for me, it just showed the power of a space shuttle main engine, and then there's 3 on the back of an orbiter, and then there's the 2 solid rocket motors. That was probably the spark that got me so interested in the space shuttle program in general, and what it took to actually get 1 engine to light, much less 3 and 2 boosters to take the shuttle to orbit.
As for the orbiter, spiraling costs forced NASA to abandon equipping it with its own jet engines and escape pod.
Originally, it was going to be an air-breathing airplane that would fly to space as a rocket and then come back to Earth. The orbital maneuvering system pods that sit on the back now were to be where deployable air-breathing engines would come out, and it would be able to fly from its intended point of landing to another place if the weather were bad or something like that.
NASA's new shuttle would essentially glide its way back to Earth. Producing the components of this new space transportation system fell to familiar names in the space industry. Prime contractor Rockwell North American, now Boeing, had built the Apollo Command Service Module. Morton Thiokol, now ATK, would build the solid rocket boosters, and Martin Marietta, now Lockheed Martin, would construct the ET. Responsibility for producing the space shuttle's main engines went to Rocketdyne, now Pratt Whitney.
There was a lot of teamwork that was going on. It was bringing people from all across the country, from Kennedy, from Johnson, from Marshall. So many people involved that had to work together. Now, at the beginning, there was a lot of anxiety that we weren't going to work together. But when people got to know each other and could trust each other, that's when the work began.
It was an amazing vehicle, in a lot of ways way ahead of its time. To have a reusable spacecraft that could carry such tremendous amounts of cargo to space was unprecedented.
September 1976, more than 4.5 years after President Nixon signed off on its development, America's new spacecraft, Constitution, gets its first close-up before the cameras. The orbiter itself was well received by the public, but impassioned fans of a particular long-canceled television series called Star Trek, wanted it called something else. They staged a successful write-in campaign, and the orbiter was renamed for the Starship featured on the show. Thus, NASA's new shuttle would be the Enterprise, boldly going as no spacecraft had ever gone before. Whatever its name, this bird still needed to prove it could fly. In an age before computer simulations, balsa wood models and wind tunnel testing was the only means to test the airliner-sized glider.
We put together a very aggressive flight test profile that consisted of data points continuously all the way down. There was not a matter of 10 seconds went by without another either pitch doublet or a rudder kick or an angle of attack sweep. The things that really turn on a test pilot to fly them as accurately as possible.
August 12, 1977. On a crystal clear California morning, high above the Mojave Desert, 2 NASA test pilots ready for Enterprise's first flight. The plan was for Fred Hayes, Jr. and Gordon Fullerton to lift the orbiter off a modified 747, then land on a dry lake bed 15,000 feet below.
The thing that we were most concerned about was if we were going to be able to get to a launch speed, if Fitz Fulton was going to be able to put the 747 into a slight dive so that we would have enough lift on the Enterprise to, when we did push the separation button, blow the bolts, to lift away from the airplane without hitting Fitz's tail. And of course, both of us were interested in that happening.
The pilots on the 747, Fitz Fulton and Tom McMurtry, sit and wait for the command to release and steer their massive aircraft out from under Enterprise.
There were still questions about was it going to actually happen as we expected from those simulations and the analysis and everything. There's a very loud thump when the shuttle separates. There was always a question, was the shuttle going to slide back and hit the tail of the 747? But we couldn't see that, but we could, after a few seconds, we could tell it didn't hit us. And so the chase called clear.
Once we reached the 240 knots and Fitz called on speed, I think he really pushed some of the sensors he was looking at in order to let us get to there, and we appreciated that. But once we heard Fitz say on speed, I pushed the separation button and we just broke free. We had about 1.5 G's of lift.
Honestly, that was probably the most exciting moment in the approach and landing test, to feel and be there when the shuttle separated from the 747.
By all accounts, this first freefall test is a success. 5 weeks later, Enterprise is brought to 22,000 feet for her second freefall test. Pilots Joe Engel and Dick Truly have only 2 minutes to capture flight and maneuvering data before landing the aircraft again without any engines.
It was a real team effort, and the challenge was for Dick Truly and I to fly that profile and fly those data points, those maneuvers, as precisely as possible to give them the best data possible. It was a test pilot's dream.
A total of 16 taxi, captive, and drop tests confirmed the soundness of the craft's design and green-lighted production of the first space-worthy orbiter. Columbia, NASA's first orbiter, is fittingly named after the first American vessel to circumnavigate the globe. However, Columbia quickly becomes a daunting challenge for NASA. Its complex makeup had engineers struggling constantly to reduce Columbia's weight and simplify construction. Especially frustrating was keeping the orbiter's ceramic tiles attached to its fuselage. More than 25,000 of them fit together to protect Columbia from the searing 3,000-degree heat of re-entry.
we were having a lot of problems with the thermal protection system of the tiles. The way we were trying to glue them on, they wouldn't stay on. And we had to come up with a way of making sure that they'd stay on. And we had some really great people that worked that, and that's why it took such a long time. I had hoped it was not going to take that long, since John and I were named as a crew, so we had a lot more time to train than what we'd both initially planned.
The requirement was to be able to handle temperatures like 2,500 degrees F that occur on the surface of the TPS, and that's 5 times what your oven is at home that you bake cookies under at max. The other problem is weight, because after all, this is an airplane, so you can't have a metallic system on it that weighs tons. It has to be extremely lightweight. And in fact, the shuttle tiles are about 90% air, and that gives the combination of being able to be temperature resistant and yet at the same time light.
Each orbiter has a unique number of protective tiles. Challenger was built with the most, 31,088, while Atlantis has the fewest, a mere 24,177.
Over in Palmdale, they had put on their first effort of putting the tiles on to protect the aluminum from the heating they were going to get on reentry. And some of those tiles, when they put them on in the daytime, next morning the tiles were on the hangar floor. And so that was real scary, that they could lose some tiles while they were on orbit and really have a problem with the heat coming back on reentry.
Columbia had a lot of tiles missing yet, needed quite a bit of work before we could deliver it to the Cape, and we scrounged throughout the city of Lancaster for RTV, which was the material we used to glue the tiles on with.
More glue did keep the tiles in place. However, water was literally ripping them apart.
It turns out, in the instant we hit rain, the tiles almost exploded.
The tiles fabrication process was modified and the problem overcome. Other shuttle design features proved less problematic and more groundbreaking. A computerized digital flight control system, now common in commercial and military aircraft, was developed for the orbiter.
In flying the space shuttle, you were so aware that you weren't necessarily talking to the shuttle, you were talking to a computer who in turn was going to talk to the shuttle.
Barriers of race and gender were falling everywhere, and America's corps of shuttle astronauts would become more reflective of the nation it served.
There's been a lot that the shuttle era has done to bring space flight into the domain of the average person. We know it's not just crew-cut white test pilots anymore. It's essentially the United Nations that flies on the space shuttles. It's people of every description that look very much like the rest of us.
The astronaut selection process reflected a changing nation and a changing NASA.
At the time, all the astronauts were military test pilots and there were no females, so it was kind of like one of those dreams that you hope will happen someday, but you didn't really think would.
The NASA astronaut class of 1978, the largest in the agency's history, came from all walks of American life: physicists, meteorologists, fighter pilots, scientists, and for the first time, women and African Americans.
When I came into the astronaut program in '78, there were 3 African Americans that came in at the same time, and it was the first time that NASA had hired African Americans. We had Fred Gregory, who was a test pilot, and then Ron McNair, who was a mission specialist, and I came in as a mission specialist. So all 3 of us were excited about flying in space, and we all 3 of us recognized that we were really going to open up the envelope for other African Americans to fly in space.
While the new class of NASA astronauts trained for subsequent shuttle flights, Columbia was undergoing preparations for the program's maiden voyage, STS-1. Veteran astronaut John Young, one of the 12 men to set foot on the moon, is in command. His pilot is first-time flyer Bob Crippen.
To be sitting on board up there with my buddy John Young and get to experience the whole thing from ascent and being on orbit to flying re-entry, it was one of the high points of my career.
Together they would travel over 1 million miles and circle the Earth 36 times.
The launch finally occurred. We'd been waiting and postponing, and when it finally lifted off and we knew it was going and achieved orbit, we were all in anxious anticipation for what was going to happen next.
Launched like a rocket 2 days earlier, Columbia lands as a glider on the dry lake bed of Edwards Air Force Base in California.
Watching out the window, watching the sea and the clouds rush by, it actually gave a sense of speed, more so than when we were up in orbit, being much higher. I think they were all very relieved because there had been some concern because we had lost some time on the bottom or not. Flew down over the San Joaquin Valley. We do a big turnaround to land on the lake bed for that first flight. And I remember when John went into a bank, a big left bank, I looked down at the lake bed, and there's thousands of people out there on the lake bed. John, look at all those folks, which had come out to see us land.
Joe Engle was chased, and hear his voice coming in on final, talking to John Young and Cripp in the airplane that they were right on glide slope, coming in for a landing. And then have that landing, and then have John Young do his Young dance. He was just so elated. It was such a magnificent flying machine to him at that time.
The first time I really saw a real shuttle was Columbia, when it was out on a lake bed after the landing, and I'm walking around it. I couldn't believe they sent that big a mass up in the air.
People really thought this was all impossible. So what we have done and shown and demonstrated through the shuttle program is we've shown that we can take the impossible and make it possible.
Thousands of spectators line up along the landing strip to greet the shuttle and its two-man crew.
Anyone who was associated with the program or there just to see the shuttle return, I think felt a lot of pride in our country and our space program. And so those emotions were, finally released, and you said, wow, the flight was done safely. They're back home. The shuttle really does work. It's a great program. It's got a great future ahead of it.
Hey, this thing works, and we got it back all in one piece, which is what we wanted to do.
While Columbia's return was spectacular, it would renew NASA engineers' worries about the shuttle's thermal protection system. During the post-landing inspection, 148 of the orbiter's tiles were found shattered, and 16 more were missing due to the effects of an overpressure wave. While that and other issues were addressed, the 50-ton Columbia would be placed atop the specially configured 747 and ferried back to Florida and processing for its next mission.
It's a massive enterprise. It's over 8 stories tall, sitting on the ground, and you never get over that site. It's really awesome.
After the shuttle lands, there's a processing procedure for the shuttle. Post-flighting it, checking the tires, checking the struts, get the correct measurements. And then when the shuttle is ready to mate with the 747, we would tow underneath, and then they would lower the space shuttle down on the supports on top of the aircraft. We would take off.
On takeoffs from the extra-long runways of Edwards Air Force Base, the shuttle carrier aircraft's crew of 4 would soon grow accustomed to the smell of burning rubber. That's the intense heat generated by their plane's spinning tires as they carried 2 massive aircraft at more than 100 miles an hour. The average range of a 747 is about 5,000 miles, but due to its weight, configuration, and special flight requirements, the SCA can travel only 1,000 miles at a time. A full turn in the jet can take several zip codes.
32.5. Switching now, thank you.
Cruising at more than 250 miles per hour, the jumbo jet burns 40,000 pounds of fuel per hour. That's 130 pounds per mile, or the length of a football field per gallon. No wonder it has to make several stops before reaching Florida's east coast.
We would get a spacecraft back, go over it again, be sure that we could reuse it,
repair it where we had to do. It had never been done before. And so I think that's one of the marvelous things about the space shuttle was we found a way to turn this spacecraft around and use it again.
Before the end of 1982, Columbia would fly 4 more missions.
Liftoff of America's space shuttle,
including STS-5, the first with a crew of more than 2 astronauts. Challenger, the second orbiter in the shuttle fleet, made her maiden flight on April 4th, 1983.
And liftoff of the orbiter Challenger and the 6th flight of the space shuttle.
STS-6 deployed a communications satellite and featured the first spacewalk of the shuttle era. Just 2 months later, Shuttle Challenger was back in orbit, this time with the first American woman in space. Physicist Dr. Sally Ride was a member of Commander Bob Crippen's STS-7 crew that deployed Canadian and Indonesian satellites during the 6-day mission. Challenger was ready for flight in less than 2 months, another massive first. Shuttling the first African American to space, and Air Force combat pilot Guy Bluford.
For me, it was an exciting moment because it was something that I had been training for 15 to 16 months, and so I was looking forward to the experience of flying in space.
We are in an era of brotherhood.
We have liftoff of mission 41D, the first flight of the orbiter Discovery.
In 1984 to 86, the newest orbiter Discovery would fly a record 6 missions.
And liftoff of mission 51D and the 7-member crew of Discovery.
Carrying into space satellites, international astronauts, even a U.S. senator and a congressman. 1 year after Discovery's debut, Atlantis flew her first mission.
Liftoff of Atlantis. A new orbiter joins the shuttle fleet and it has cleared the tower.
STS-51J. It was also one of 7 classified missions the space shuttle would fly for the Department of Defense. By the end of 1985, the space shuttle program had completed 23 missions, including 9 that year alone. Each successful flight had the unintended consequence of convincing some that spaceflight, once considered among humankind's most inherently dangerous endeavors, had become routine. That notion would soon be tragically dispelled.
Well, I am so excited to be here.
Amid much fanfare, Krista McAuliffe, an elementary school instructor from Concord, New Hampshire, had been chosen from among 11,000 applicants to be NASA's first teacher in space.
I would like to humanize the space age by giving a perspective from a non-astronaut, because I think the students will look at that and say, this is an ordinary person. This ordinary person is contributing to history, and if they can make that connection, then they're going to get excited about history, they're going to get excited about the future, they're going to get excited about space.
The American public's interest in its space program was renewed by her participation and was eager to see her off. Commanding the flight was Dick Scobie. His pilot was Michael Smith. Serving as Challenger's mission specialists are Judy Resnick, Ellison Onizuka, and Ron McNair. Joining McAuliffe as a payload specialist was Greg Jarvis. From the start, STS-51L was plagued by delays, mostly due to unseasonably cold temperatures in Florida. Rather than give pause for thought, the delays only tried the nation's patience. Everyone, it seemed, was itching to go. January 28th, the ground temperature at Launch Pad 39B was a frigid 36 degrees. Ice could be seen on the launch vehicle. Despite concerns voiced by some, shuttle managers reluctantly decided to press ahead for a late morning liftoff.
6, we have main engine start, 4, 3, 2, 1, and liftoff. Liftoff of the 25th Space Shuttle mission, and it has cleared the tower.
Challenger, go with throttle up.
At 11:39 Eastern, twice the speed of sound, the Challenger's fuselage breaks apart from the inside out. America's space program suffers its first fatalities in flight.
God, no.
All 7 Challenger crew members perish.
Okay, everybody, stay off the telephones. Make sure you maintain all your data. Start pulling it together.
We come together today to mourn the loss of 7 brave Americans, to share the grief that we all feel, and perhaps in that sharing to find the strength to bear our sorrow and the courage to look for the seeds of hope.
The investigation, headed by former Secretary of State William Rogers, would fault a solid rocket booster O-ring, rendered defective by the bitter cold. But the Commission's findings also addressed the human factor, the role played by shuttle program managers in sending Challenger aloft that day. The shuttle program came to a halt. It took more than 2.5 years of arduous engineering analysis and painful soul searching before a retooled and reborn shuttle would return to flight.
Challenger was tough because it not only represented a breakdown in communications, but it represented everything that's wrong or wrong about an agency like we are, where segments of the agency weren't talking to each other and didn't know everything that we should know.
We thought we knew where all the risks were and had them pretty well contained. The solid rocket boosters that caused the accident, obviously there was something that had slipped through. So we went back throughout the complete vehicle, all the systems, and did a complete review and trying to find any other things that we may have missed that may be lurking there.
When things are really starting to look smooth and you're starting to get maybe overconfident in a way, then it's time for you to step back, think about what you're doing, go back and look, do some additional testing, and see if there's something that you really hadn't anticipated that is going on with your system.
During a lot of that time, we got a lot of criticism that maybe the agency had lost its edge. There were folks inside the agency that started losing their confidence, thinking maybe we can't do this anymore. 2.5 years later, when we flew and then landed that flight, it showed that no, we really can overcome really, really large problems, really tough technical problems today, just like we could 10 years ago, 20 years ago, or 50 years ago. That was an important milestone.
Liftoff. Americans return to space as Discovery clears the tower.
On September 29, 1988, 975 days after the loss of Challenger and her crew, the orbiter Discovery returned 6 veteran astronauts to space to deploy a tracking and data relay satellite important to a number of NASA missions. STS-26 proved a comeback milestone for the space shuttle and initiated a tradition that survives with the program today.
During the flight, we had roses show up in the Mission Control Center. 6 roses, 5 red, 1 white. And there was a card attached to it, and it simply said, "Congratulations, return to flight, we wish you well." And it was signed Mark, Terry, and Mackenzie Shelton. Didn't know who they were, but after the flight, we through the Foro company, we tracked them down so we could send them some pictures and something to thank them for sending the roses to Mission Control. So the next flight, roses show up again. And again, it's 5 roses for the members of the crew and 1 rose for those who have lost their lives in this endeavor. And so this family, they have become part of our family, and they haven't missed a flight since. Every flight since that time and to date, and I suspect they're going to go right with us to the end of the shuttle program.
STS-26 ended on October 3rd, 1988, at Edwards Air Force Base, California.
Standing by for nose gear and touchdown.
With Discovery's safe landing on runway 17, the triumphant crew was greeted warmly by Vice President George Bush on behalf of a proud and grateful nation.
There's something special about a return to flight that makes you have some trepidation because it's still fresh in your mind that you're frail and you can make mistakes and you're human.
In the spring of 1990, the $1.5 billion Hubble Space Telescope was loaded into Space Shuttle Discovery's payload bay, and on April 24th was sent aloft to be deployed to Earth orbit on STS-31.
Capcom, we have a go for release. Discovery, go for Hubble release. Okay, we have a go for release.
As envisioned, Hubble would return never-before-seen images detailing our universe as it was millions upon millions of years before. Soon it would become clear that Hubble pictures were not.
Several days later, if not a couple of weeks, we found out, after we were back on Earth, that it had a problem with its vision. And most of us were just devastated, that here we had this marvelous instrument that we had put on orbit and it was going to be useless. It turned out that it wasn't useless at all, because even with its flaw, it was still a much better telescope than anything that we had, on Earth.
A shuttle mission dedicated to the telescope's repair was planned. In essence, Hubble's nearsightedness would be corrected with a new pair of glasses.
Liftoff of the Space Shuttle Endeavour on an ambitious mission to service the Hubble Space Telescope.
We finally flew STS-61, which was the first Hubble servicing mission. Absolutely incredible mission.
Clearly we have a dynamic situation.
You cannot take the 84-inch mirror out of the telescope. It's part of structure, too big, it's there. So by putting in one box called CoStar, we're able to correct the aberrating light for 5 other instruments.
Of all the space shuttle missions we've flown, it was without a doubt the most ambitious flight, but the one that I think demonstrated NASA's can-do attitude, its technological skill, its technical capability, and the spirit of its people.
2 teams of astronauts made a record 5 back-to-back spacewalks to refurbish Hubble and realize her potential to awe and astound. While Hubble servicing missions were very important, the true gift of a maneuverable shuttle was soon realized in a very different rescue mission.
Booster ignition and liftoff of the maiden voyage of Endeavour on a satellite rescue mission.
Months earlier, in May of 1992, the 7 astronauts of STS-49 overcame initial setbacks to pluck the $180 million Intelsat 6 communications satellite from an unusable orbit.
It was going to be a very simple rendezvous, get close, bring the satellite down close and grapple it with the remote manipulator system. Everything that could go wrong went wrong.
We got up there to capture it. The bar, we tapped the satellite with the bar, and the satellite started moving out of control.
Get me in. Pitch me over. Into the arm. Watch the end of the arm.
That's the singularity again.
You're going to have to get out of there.
It can be very difficult catching something like a tumbling satellite in space. The slightest touch or mistouch by the astronaut with the equipment, and you can send that satellite tumbling.
Here, make sure that when you want me to yaw right, you say yaw right. Okay. Any other time right, it's just right. Yeah, that's what I'm doing. Better move. We're moving.
And so it was very touch and go on that mission, actually.
Commander Dan Brandenstein and pilot Kevin Chilton are preparing for the upcoming terminal initiate burn.
After several days of failed attempts with Endeavour's remote arm, Commander Dan Brandenstein literally tries a new approach.
Yeah, real easy, guys, real easy. Don't bring us any closer, Dan. Okay, I'm stopping it.
At Endeavour's helm, Brandenstein delicately maneuvers the orbiter up to the 4.5-ton Intelsat 6.
The satellite is rolling out of control in 3 different axes at once, and you could actually fly the shuttle and fly this maneuver around and keep it aligned with it.
It's got to be the neutral point right here. 3 people grabbed 18,000 pounds.
Aware that any miscue could endanger not only the satellite but also the ride home, spacewalkers Pierre Thuot, Tom Akers, and Rick Heeb reach out and secure the satellite by hand.
Okay, wait. Let's do it. Got it. Get time. All got a good grip? Yes, sir. Houston, I think we got a satellite.
Yeah, nice job, guys.
Intelsat 6 is released from the cargo bay with a new mini-rocket motor for a gentle push to its proper orbit, where it remains today, fully functional. And as the shuttle program matured, so it seemed did relationships between the world's spacefaring nations. On STS-47, the 50th Space Shuttle mission saw the orbiter Endeavour back in space on September 12, 1992. The mission was a cooperative space lab venture between Japan and the United States that brought the first Japanese astronaut into orbit as a member of the 7-person shuttle crew.
The space shuttle has launched people from different nations around this world that used to feel they could never, ever work together. And it has ushered us from the Cold War to this really cooperative space program that we have with our international partners, including the former Soviet Union.
Regardless of what language you speak and love space. And that's pretty cool. We have a lot in common with engineers and scientists around the world, and that's kind of fun to work in a program like this.
On February 3, 1995, Eileen Collins, the first woman to pilot a shuttle, was at the helm as Discovery gave the U.S. its first up-close look at the Mir space station. Collins flew the shuttle through a series of intricate maneuvers, approaching within 37 feet of the Russian spacecraft, and later performing a fly-around by hand.
And liftoff of the Space Shuttle Atlantis on a mission that will herald a new day of international cooperation in space.
4 months later, on June 27, 1995, Shuttle Atlantis would lift off from the Kennedy Space Center to begin STS-71, the U.S. space program's 100th human space mission. It would take 2 more days before Atlantis caught up with and performed the first shuttle docking with the Mir space station.
Houston, Atlantis, we have captured.
Orbiting 220 miles above the Earth, a most unique and historic celebration took place. As the Mir space station welcomed its first American guests, cosmonauts and astronauts together broke figurative bread, tortillas and fruit to be exact, in a renewed spirit of cooperation. Together, Shuttle and Mir formed the largest flying spacecraft the world had yet to see. It tipped the scales at 250 metric tons, more than 500,000 pounds. Between 1994 and 98, the Shuttle Mir program would involve 11 shuttle missions, including in 1996 STS-76, which began a continuous U.S. presence aboard the Russian space station with a visit by Atlantis. Barely fluent in Russian, astronaut Shannon Lucid, a biochemist, embarked upon a mission that would dramatically enhance our understanding of life in space. When she finally landed at Edwards Air Force Base on Shuttle Atlantis, she held the female space endurance record for spending 188 days in orbit. A hero's welcome was in store.
I'm here to say welcome home to Shannon Lucid.
By the time Shuttle Mir ended with STS-91, 7 American astronauts had completed extended stays aboard the Russian space station.
Tatiana Mativa, who I became very good friends with, and I remember us sitting in Red Square having dinner together with a full moon, and remembering when I was a child all those parades, those May Day parades with the tanks going by, and here we were sitting there having a nice dinner under the full moon and with a lot of friendship. So it just goes to show how space can unite people, and that's I think one of the biggest benefits.
8 cosmonauts had flown to Mir on the U.S. shuttle, and NASA astronaut Norm Thagard had become the first American to fly there or anywhere aboard a Soyuz spacecraft. In 2001, 15 years after its commissioning, Mir would be abandoned to break up and burn in Earth's atmosphere. By then, the process of building upon Mir's legacy of international cooperation in space had already begun. Whereas STS-61 had helped establish the Hubble Space Telescope as an icon of American ingenuity, STS-95 would update the hero's credentials of one John Glenn. On October 29th, 1998, almost 37 years after becoming the first American to orbit the Earth as an original Mercury 7 astronaut, Glenn, now a 77-year-old former U.S. Senator, made his return to space. In contrast to his first flight, a 3-orbit, 4.5-hour foray inside the snug Friendship 7 capsule,
Liftoff of Discovery with a crew of 6 astronaut heroes and 1 American legend.
STS-95 would take 8 days and circle the Earth 134 times.
My main reason for being on that shuttle flight was to do research on aging. I was 77, we went up, and you know, NASA has charted some 52 different changes that occur in the human body when you go into space for a period of time. And several of those are very similar to what happens to the natural process of aging right here on Earth. Body's immune system changes. You get less resistant to disease and infection. Body's ability to absorb protein back into the muscles changes for the young people up there and for elderly here on Earth. The objective was to take those things that are the same and see if we couldn't find any differences between my experience up there and the younger people I would fly with the idea of finding in the human body what turns these different systems on and off. If we could do that, we might be able to make it possible for people to stay in space longer without harmful effects, and maybe cut out some of the frailties of old age right here on Earth. I really was happy to be assigned to that flight.
In an interesting twist of fate, astronaut Glenn not only inspired both the young and old around the globe, but also a fresh political science and economics graduate, Lori Garver, the 18th Deputy Administrator of NASA.
Having the ability at NASA to fly him again in space after his first flight was something we, I think, gave the nation, and it really helped explain what we were doing on the space shuttle. John Glenn was very, very focused on doing those experiments for both, I think, the older generation, but he was also an inspiration to people growing up.
Discovery carried a variety of payloads and research experiments. Arguably, the one most valuable was Glenn himself. Not only did he provide first-time data on what spaceflight might do to the body of a septuagenarian, Glenn also renewed the interest of the nation and the world in America's space shuttle program. While the program had and continued to successfully deploy and service science probes and satellites, as well as conduct on-orbit research, the space shuttle undertook a new long-range task perfectly suited to her specialized capabilities.
You've got a spacecraft that can carry at least 7 people into orbit, and with those 7 people, you can do a huge amount of work. One mission, you can do multiple EVAs, you've got multiple crew members, you've got a huge payload, just all kinds of capabilities to be able to construct and build bigger things in orbit.
Less than 2 weeks after Glenn's return to Earth, a Russian Proton rocket departs the Baikonur Cosmodrome in Kazakhstan, carrying the Zarya module, the first component of the new International Space Station.
Liftoff of the Proton rocket and the Zarya control module. The International Space Station is underway.
2 weeks after that, Space Shuttle Endeavour follows up with delivery of America's Unity module, the second piece of this largest space station puzzle ever to be constructed.
Houston Endeavour, we have capture of Zarya.
Not until July 2000 will the Russian Zvezda module be added, finally allowing for 2 Russian cosmonauts and their American Expedition 1 commander, Bill Shepard, to journey aboard a Soyuz spacecraft to the International Space Station and begin humankind's continuous extraterrestrial presence.
Across the world, people are very, very interested in and delighted by the International Space Station and the science that has taken place there.
Since only an orbiter's payload bay could hold the station's largest components, the multi-year, multi-mission building, outfitting, and servicing of the ISS with cargo and crew would become primarily a job for the shuttle. Amid these dynamic station building missions, one seemingly simple and relatively uncomplicated flight would prove problematic and threaten the very future of America's human spaceflight program. Since 1988, the Space Shuttle had completed 15 years of successful missions. Each was unique. Each had its own specific goals and tasks, and each had its own dedicated crew of astronauts who'd trained exhaustively to meet and carry them out. Yet each of those 87 flights did have two things in common: a safe launch,
Liftoff of the Space Shuttle Discovery,
and a safe landing.
Nose gear touchdown.
From the start, STS-107 seemed to be a mission out of sorts. By the time Columbia was finally ready to fly on January 16, 2003, its planned 16-day mission had been delayed no fewer than 18 times. All those delays had ultimately positioned the STS-107 as a sort of black sheep on the Space Shuttle program's launch schedule. Columbia's crew commander Rick Husband, pilot Willie McCool, and mission specialists Michael Anderson, Kalpna Chawla, Dave Brown, Laurel Clark, and Israeli astronaut Ilan Ramon would not go to the International Space Station. Their flight would require nothing more risky than orbiting the Earth.
Booster ignition and liftoff of Space Shuttle Columbia with a multitude of national and international space research experiments.
82 seconds after launch, what was later described as a suitcase-sized chunk of frozen foam insulation breaks off Columbia's external tank and strikes the leading edge of the orbiter's left wing.
Roger, roll, Columbia.
A routine same-day video review of the launch would reveal nothing unusual. However, higher resolution tracking camera film processed overnight and reviewed on flight day 2 by the mission's ascent team showed otherwise.
You saw this little thing float toward the leading edge of the wing and like, it was like a snowball hitting something and then just being pulverized. But when you saw it hit, we just winced, because we knew, the vehicle's going 500 miles an hour or better. It was inconceivable in hindsight that you could have that kind of impact at the speed that the vehicle was going and assume that there was no damage. And that's what we allowed ourselves to feel comfortable that we were right and we were dead wrong.
Due to limitations in the visual clarity, the exact point of impact and extent of any damage could not be determined. If the foam strike had compromised Columbia's integrity, little, if anything, could be done to repair the orbiter in space. 1 week after launch, Mission Control emails the crew informing them of the debris strike. Save for a relatively minor problem with a leaky refrigeration unit, STS-107 had been without further incident. As scheduled, the order is given on the morning of February 1st for the Columbia crew to begin the landing procedure and come home to Florida. Traveling in excess of 12,000 miles per hour, the orbiter's belly begins to glow red as it descends into Earth's atmosphere.
FYI, I've just lost 4 separate temperature transducers on the left side of the vehicle, hydraulic return temperatures.
As reentry started and as the ground track went across the states, the ground track, of course, changes color. You can tell where the shuttle is over what part of the country it is.
No onboard.
Well, that display stopped updating. In other words, that display froze in a certain position. Well, sometimes you have loss of data, you have some problem with the system on the ground where you'll have those kind of outages temporarily. Well, this lasted a bit longer. Then the call went up to the crew. A call went up and no response. Well, I don't know, I just began to feel uneasy.
Columbia, Houston, UHF comm check.
At speeds above Mach 20, the stress becomes too much for the orbiter.
We do not have any valid data at this time.
The suitcase-sized chunk of foam had indeed punched a bowling ball-sized hole in the leading edge of Columbia's left wing. Within seconds, internal temperatures spike, signaling the cascade of structural disintegration. Only 16 minutes from home, Space Shuttle Columbia breaks apart in the skies over East Texas. All 7 crew members are lost.
GC flight. Flight GC, lock the doors. Copy.
And at that moment, I knew we lost him.
The grief is heavy. Our nation shares in your sorrow and in your pride. And today we remember not only one moment of tragedy, but 7 lives of great purpose and achievement.
Within days, hundreds of professionals from federal and state agencies across the country arrive in East Texas. They are joined by local volunteers to help NASA recover and catalog debris from Columbia in the hopes of, literally, piecing together an answer to the accident's cause.
This is one of the many obstacles investigators are up against.
It was really heartwarming and very emotional for me to see all of these people from around the country come in to the piney woods of East Texas and spend days and weeks there marching out through the woods looking for bits and pieces of the orbiter and so forth. If anybody ever wonders about the strength of the backbone of this country, then they ought to have the privilege, like I do, to meet these people who have come here to do this. It shows you the fabric of what this country is made of.
Determined to return to flight, stronger and safer, the grounded shuttle program had taken a fresh look at itself.
During my watch, we lost the Columbia crew, and clearly as a flight director back in Challenger, we lost that crew. I think about those every day. Every day I come to work. I need to be very vigilant. I need to pay attention, and I need the people that work for us in this business to pay attention to what they're doing, because this is hard stuff that we do. It's very dangerous. We have not figured out a way to do a beam me up Scotty. Right now it takes a lot of hydrocarbons moving at very high speeds through fuel pumps at very high temperatures, high pressures to get into space, and it takes a tremendous amount of effort to get out of space back in the atmosphere and get home.
I was sent out to David Brown's parents' home. I'll never forget this moment when Judge Brown looked at me and said, "Leland, my son is gone. There is nothing you can do to bring him back. But the biggest tragedy would be if you don't continue to fly and carry on his legacy."
Each of the remaining 3 orbiters was pulled apart and refurbished. New capabilities were devised for the crew and mission controllers to assess and repair damage while on orbit. Processes and procedures were also re-examined and reinvigorated. Crew safety would never again be taken for granted. Nearly 2.5 years would pass before the nation would see another orbiter poised for launch from the Kennedy Space Center.
By the time that we fly the flight, it's something that it feels like we have flown many times. So if things don't go well, it becomes very, very natural for us to know at certain points during the mission, if this doesn't go well or if this significant system breaks or we have this type of emergency, what's the most important thing we need to do now, because we've been rehearsing it. And it makes it look really easy. You don't really get the full effect of how much real preparation, how much real studying went into making it look that easy.
Of all the changes accompanying the shuttle's return to flight, none was more significant than the one announced in early 2004 at NASA headquarters by President Bush.
Our first goal is to complete the International Space Station by 2010. We will finish what we have started. We will meet our obligations to our 15 international partners on this project. The shuttle's chief purpose over the next several years will be to help finish assembly of the International Space Station. In 2010, the Space Shuttle, after nearly 30 years of duty, will be retired from service.
Even though each shuttle was designed to fly 100 missions, the Columbia Accident Investigation Board called the shuttle an aging spacecraft, with the odds of losing another orbiter and crew increasing with each subsequent flight. NASA's human spaceflight program was faced with several basic challenges, including coming up with a successor to the shuttle fleet. However, with an impending cancellation of the shuttle program looming, shuttle managers recommitted themselves to the paramount task of safely completing the International Space Station. It would become the program's mantra, to be repeated over and over again, not only to the media, but also for every worker in the shuttle program. No launch schedule was too tight, and no mission too important to be rushed.
We ought to treat every flight, in a sense, as a return to flight. This is truly a test program. We go back, we make sure everything is right, we double check, and then we go commit in a flight readiness review that we're actually ready to go fly.
On July 26, 2005, Discovery gets the shuttle program flying again.
This is shuttle launch control at T-minus 3 hours as our pilot, flight engineer. We're now into the suit-up room.
LRD is go. SRO. SRO is go. So on behalf of the many millions of people who believe so deeply in what we do, good luck, Godspeed, and have a little fun up there.
Thanks to you, to the launch team, and to everybody in the shuttle program. The crew is go for launch.
T-minus 10 seconds. Go for main engine start. 7, 6, 5. 3 engines up and burning. 3, 2, 1. And liftoff of Space Shuttle Discovery, beginning America's new journey, and the vehicle has cleared the tower.
Among the many changes instituted, the new R-bar pitch maneuver or backflip.
Station Discovery initiating RPM in 3, 2, 1, march.
Will be used by each mission to the International Space Station. At arrival, the end-over-end flip allows the station crew to visually document the condition of the shuttle's belly and nose. Discovery and the STS-114 crew safely began the final phase of the shuttle program's historic journey with a smooth pre-dawn landing on August 9th, 2005 at the Edwards Air Force Base, California.
Stevie Ray, Soichi, Andy, Vegas, Charlie, Wendy, and Eileen, welcome home, friends.
With this practically rebuilt space transportation system, each remaining shuttle mission would be safer than the one before, and its final flight, the safest.
It's almost like we've had kind of 3 different space shuttle programs. First 10 years, we're off learning how to fly the thing, deploying satellites and flying laboratories in the back. Next 10 years, we're doing more of that, and we're going out on more and more spacewalks, and we fly up to the Mir space station. And in the last 10 years, we use it to build about a 1 million-pound space station in orbit, which wouldn't have been possible without shuttle. It's a heck of a machine.
When you look at the Hubble Space Telescope, that would not have been possible without shuttle, and you look at the International Space Station, which certainly would not have been possible without shuttle. Every launch is an emotional experience. Watching what this nation has done, what NASA has done with the NASA contractor team, it's awesome. It's wonderful.
We didn't spend a dime in space. Not one single penny has been spent in space. Every single penny that went into the space shuttle program over its 30-plus years was spent right here on Earth. One, creating jobs, growing our economy, creating technological development of which we never dreamed, advancing science, and technology, even advancing the field of aeronautics.
It just impresses me what people can do. What people can do. It's a big machine, it's a nice machine, it's a fantastic engineering marvel in my opinion, the whole space shuttle. But what's the real marvel is the people behind it that make it go.
Having a space shuttle enabled us to be able to complete our science and do some really great things to advance the area of metallurgy.
Without the space shuttle, an experiment like this one could not have been conducted.
The shuttle is very important for us to learn and be able to conduct long-period experiments.
Out of the 50 states, 48 of them have vendors that provide parts or equipment to the space shuttle program. So it's a vast cross-section of America that makes the American space program what it is.
Change is inevitable. As much as people don't like change, it's the only thing that's constant in our lives. And we have to change, we have to transition from shuttle to a new future, which we're going to define, which can be even better. A future that allows us to explore beyond our home planet, to seek our destiny, to learn what we couldn't possibly learn if we were stuck in low Earth orbit.
And since its return to flight, the shuttle program has been almost singularly focused on completing construction of the space station.
I think back of all the challenges and all the things that had to work right. You know, a lot of these interfaces never came together before. All the shuttle flights, the 20-plus shuttle flights that went into assembly, all the Soyuz flights, the Progress flights. To see this station come together in assembly is a true testimony to the international partnership. This is probably the most amazing research facility ever constructed in space, and it's constructed internationally, and it operates every day, 24 hours a day, doing world-class research internationally, and there is no more amazing facility than what we have in orbit.
Through and possibly beyond 2020, the ISS will serve as the world's first full-time research laboratory in microgravity. Among zero-G experiments already conducted aboard the station, several have led to promising breakthroughs in the research and treatment of cancer. Many other on-orbit science findings have the potential to significantly improve the quality of life back on Earth. In May 2009, Atlantis and its STS-125 crew took to space not to visit the ISS, but to return to the Hubble Space Telescope for its final servicing mission. On 5 spacewalks, Atlantis astronauts repaired and upgraded the Hubble telescope to significantly improve its capacity to explore the depths of the universe until at least 2014.
I think of all the fingerprints that are all over this thing.
It's a phenomenal piece of machinery. It's a phenomenal airplane.
And it really is an engineering marvel.
The space shuttle will go down in history as one of the great flying machines that America has produced.
The space shuttle, you know, at this time was a vehicle for bringing people together from all around the planet and having us work in harmony for the betterment of humankind.
We may not have understood when we first built it what all we'd be able to accomplish with it. And after many years, we've realized just how useful it has been.
It's been a learning experience on how to operate and live in space.
What can you say about the space shuttle? It has changed everything.
Well, the shuttle, from my perspective, is one of the great things that this nation has done.
It was a lot of pride.
Like I said, it's inspiring to come to work every single day to work on this program.
I'd go tomorrow if I had the opportunity.
Liftoff of the Challenger from Columbia. Discovery, the shuttle has been landed.
For more than 30 years, the fleet and thousands of Americans dedicated to its safety and success have toiled in exhilarating triumph, heartbreaking tragedy, and most often, quiet obscurity. Their contributions have extended beyond the bounds of space. Among others, shuttle-derived technologies have been used in developing an artificial heart and limbs, three-dimensional biotechnology, a light for treating tumors in children, and improving crime prevention and wildfire detection. From crawler driver to payload specialist, from scuba diver to pilot, from scientist to engineer, they and many like them throughout the nation share a commitment to sending humankind safely into space. That dedication, as much as any other acclaim, will be the legacy of America's space shuttle.
I think we'll be remembered in thousands of years, you know, as perhaps the most incredible technological feat of humans of our time.
As is the order of life, an ending for the space shuttle becomes a beginning for a space-bound successor. Soon, America will again send astronauts into orbit and beyond to do what NASA does best: explore.
Experience. Innovation. Safety. The Aeronautics Test Program at Dryden Flight Research Center. Flight Loads Laboratory. Research Aircraft Integration Facility. Western Aeronautical Test Range. Support Aircraft. The Aeronautics Test Program at Dryden Flight Research Center. NASA Dryden's Aeronautics Test Program, Flight Operations and Test Infrastructure Project offers government agencies, corporations, and institutions an extensive range of state-of-the-art support aircraft, communication and telemetry, simulation, and structures research capabilities. NASA's Aeronautics Test Program assets located at Dryden Flight Research Center. Advancing technology and science through flight. Flight Loads Laboratory. Given its vast physical resources and highly experienced technical staff, the Flight Loads Laboratory is a unique national resource constructed to support flight research and tests of aircraft structures dating back to the X-15 hypersonic research program. At NASA Dryden's Flight Loads Laboratory, a comprehensive set of structural test capabilities can be achieved, including thermal, mechanical, structural dynamic, and mass properties testing of large-scale structures performed independently or simultaneously. To support testing capabilities, the Flight Loads Laboratory utilizes both conventional and advanced instrumentation technology. The Flight Loads Laboratory utilizes a wide array of test systems, including radiant heating, hydraulic load control, a soft support system, and a variety of measurement systems to support ground and flight research. Tests conducted in the Flight Loads Laboratory utilize the most advanced structural instrumentation capabilities available, including state-of-the-art sensors and measurement systems, advanced sensor integration techniques, and systems for sensor characterization and validation. With its expert staff, distinctive capabilities, and flight line access, the Flight Loads Laboratory provides unique test solutions, all under one roof, that meet customer requirements, from subsonic through hypersonic flight. Research Aircraft Integration Facility. Another one-of-a-kind resource offered by Dryden Flight Research Center's Aeronautics Test Program is the flight simulation capability, located in the Research Aircraft Integration Facility, known as the RAIF. Designed to house project and facility management, vehicle maintenance, and engineering personnel, the RAIF can support a wide variety of advanced, highly integrated research aircraft through all phases of a research program, from concept to flight.
Okay, we'll drive all the way to hold and get some gas. Copy.
Among its more rare capabilities, the RAIF offers high-fidelity, real-time and batch flight simulation, closed-loop, hardware-in-the-loop, pilot-in-the-loop, and vehicle-in-the-loop verification and validation testing. The RAIF offers 11 different simulation labs with the ability to customize for specific research aircraft and unmanned vehicles. The co-location of project and facility management, vehicle maintenance, and engineering personnel allows the RAIF to support advanced aeronautical and space-based research throughout all phases of the research program within a single facility. Western Aeronautical Test Range. Located at Dryden Flight Research Center and part of the Edwards Air Force Base Complex, the ATP's Western Aeronautical Test Range, or WATR, supports flight research operations and low Earth orbiting missions, supplying a comprehensive set of resources for the control and monitoring of flight activities and utilizing the most advanced tracking and data acquisition technology available. The WATR's ability to acquire and communicate information to flight and ground crews in real time is incomparable. Fixed and mobile telemetry antennas receive real-time data and video signals from research vehicles and relay the data to engineers in the mission control. The WATR even has mobile capabilities to allow for rapid deployment and remote testing for support outside of local airspace boundaries, like a rendezvous at the International Space Station, in which the WATR plays a critical role in emergency situations. The WATR is also the primary communication support when the Space Shuttle lands at Edwards Air Force Base. Support aircraft. Dryden Flight Research Center's fleet of support aircraft play a number of vital roles in successful aeronautics research, flight, and ground operations. The aircraft provide safety chase support for research flights, mission video, and photography support, and can be utilized as adaptable research platforms if needed during modification and maintenance of research aircraft. While performing safety chase support, pilots maintain constant visual and radio contact with research test vehicles. Chase pilots monitor external flight-critical safety items, clear other aircraft operations, and can provide additional real-time feedback to the test pilot and control room personnel. Another vital component in the ATP's support aircraft program is the utilization of photography and video. Live video is captured plane to plane and transmitted to control rooms, allowing project engineers to watch the mission from the most optimal point of view in real time. Each of these support aircraft has unique performance capabilities, allowing the fleet to meet support requirements across the entire envelope of flight research operation speed, duration, and altitude ranges. This diversity also allows the aircraft to be utilized to meet pilot proficiency requirements on multiple platforms, ensuring Dryden maintains the most highly qualified, versatile, and experienced research test pilots possible. These pilots also support the unique flight operation activities of various Earth science research and deployment campaigns stretching around the world. The Aeronautics Test Program at Dryden Flight Research Center, advancing aeronautics research through flight. With NASA's Aeronautics Test Program Flight Operations and Test Infrastructure Project, you not only get access to Dryden's world-class facilities and infrastructure, you become part of NASA's tradition of success and innovation. Dryden Flight Research Center. To fly what others only imagine.
Station, this is Houston. Are you ready for the event?
Houston, this is Station. We are ready for the event.
Centers for Disease Control, this is Mission Control Houston. Please call station for a voice check.
Station, this is Dr. Inger Damon with the CDC. How do you hear me?
Inger, this is Kate. I've got you loud and clear.
Hey, Kate, how are you? So, Kate and Shannon, it's great to meet you, and greetings from Earth. So I guess to start, to open this conversation a little bit about the three of us. And so Shannon, this is my first time meeting you, but Dr. Shannon Walker is a physicist who never lost sight of her life goal. After watching the Apollo 11 moon landing on television as a child, she started her professional career as a robotics flight controller for Johnson Space Center before being selected by NASA to be an astronaut in 2004. Dr. Kate Rubins spent a significant amount of her life in a spacesuit, whether in a BSL-4 lab suit, and now in space. Before becoming an astronaut in 2009, she was a scientist studying viral diseases and immunology, was a guest researcher here at CDC early in the 21st century, and I'm Inger Damon, Director of the Division of High Consequence Pathogens and Pathology at CDC, and it is so very 21st century to be chatting with you who are on the International Space Station. So welcome. So I guess the first question, Kate, since I know you the best, and you and I both worked in the BSL-4 labs here at CDC on aspects of the smallpox research agenda, a lot of people may not see the parallels between the work that happens at CDC and becoming an astronaut, but you made that transition from the lab bench to the space station. And can you tell us about the route that you took, which has certainly been a complex one, working in microbiology at CDC, starting your own lab at the Whitehead, joining NASA, and now here at the space station.
Hey, Inger, thanks. First of all, I want to say welcome to the International Space Station. You're up here along with the CDC, and it's wonderful to have you join us. So, yeah, it doesn't seem at first like there's a lot of parallels between lab work and being an astronaut and being in space. But, you know, we could probably grab you from the CDC and fly you tomorrow. The work that you guys do is actually pretty similar to a lot of the training that we do. So we call them spacesuits, right, when we're working in the Biosafety Level 4 laboratory. And then we actually do wear spacesuits up here. They're pretty big. They're white. The ones up here have a little bit more mass. They're about 300 pounds, but there's a lot of parallels. So working on things that are high consequence, working in situations where you have to take care of yourself and your teammates. There's consequences to your action, and also working in an environment where lives depend on you. I think everybody at CDC is really, really, really familiar with that feeling that their work has lives dependent on them.
Well, that's, I think, a great lead-in to, I think, current events of where we are now. And I think everybody knows the past year has been unprecedented with the COVID-19 pandemic. And so, Shannon, can you tell us about the precautions that you both had to take before launching during the middle of this pandemic?
Yeah, it got very complicated very fast when the pandemic hit and we were in the middle of training. And so first we had to figure out how to accomplish training amidst the pandemic. And so we all took a step back. We figured out what training we could do remotely and what training absolutely had to be done in person. When we did training in person, everybody, of course, was wearing masks. We kept our distance to the extent possible. But, of course, when you're training for a space flight, you and your crew have to be in the spacecraft together training. So we always wore masks when we were inside our spacecraft. Closer to flight, we all went into quarantine. In fact, our families went into quarantine with us. So we spent about 3 weeks in quarantine before we headed off to Florida in quarantine there as well. So we made sure that everybody was healthy before we launched because we do not want to bring anything up to the space station with us.
Most of your time on the space station involves conducting research. And some of the work that you've done during your first mission aboard the International Space Station has involved engineering heart tissues, sequencing DNA. So, Kate, you're the first person to sequence DNA in space, and exploring the mechanisms of bone density and muscle mass loss. Can you guys tell us what kinds of research that you're working on now?
Yeah, we're continuing a lot of the biological research. So I happened to be lucky this mission to get the next flight of the cardiovascular experiment. And this was a more complex tissue mix. So we're actually looking at three-dimensional tissue engineering up here. And in addition to the cardiomyocytes, we added in fibroblasts and endothelial cells. So we're able to model the heart tissue better. We're continuing the sequencing. We're multiplexing now. We just started multiplexing about 8 different swab samples that we've taken around the space station, and I've already told them we need to get this into 96 well plates and scale this up to high throughput. So I'd like to do 100, 1,000 samples. It is more complex up here to do things like molecular biology, and so some of the time we are just inventing how to do lab work. We recently found that you can use a Sharps container as a disposal for pipette tips, and this works great on Earth. Of course, the pipette tips go to the bottom of the Sharps container. Up here, we actually have this kind of static cling that will keep them in the Sharps container instead of floating out. So sometimes we're engineering some very basic and rudimentary things. Sometimes we're studying complex particle physics with the Cold Atom Lab, which Shannon can probably explain a lot better than I could. There's an amazing amount of other kinds of research, not biological, things like combustion research, fluid behavior up here is just completely changed. So there's about 200 experiments on any given mission, and it's pretty fun to be able to do them all.
Well, I imagine that fluid behavior must make sequencing a real challenge, especially when you're getting to 96 well plates. So are there new aspects of research that you're embarking on because of the COVID-19 pandemic? I know you mentioned some of the higher throughput sequencing that you're thinking about doing.
Yeah, so we're not specifically studying any pathogens of consequence up here above BSL-2. That's all that we're rated for. We have had some impacts because of COVID. For example, in our research teams on the ground, like everybody else, they've had to move to mostly remote work, and then when they have to be in person, doing masks and distancing. And so there were some delays for a while, but it's actually been incredible to watch the teams at NASA still be on a launch schedule. So it wasn't just the Soyuz launch. They then launched Crew 1 was the first operational flight of the SpaceX vehicle. And we've had cargo vehicles come up with literally tons of supplies and experiments, and those are packed and manifested by ground teams that are having to figure out how to do all this. So there's been some impacts to research in terms of operations, but overall everybody's really done an incredible job of keeping this space station supplied and running.
So how long will you both be on the space station this time?
Both of us are up here for about a 6-month stint. We actually, I guess Kate knows her landing date. I'm not quite sure about mine. She's been up here about a month longer than my crew has been from the SpaceX Dragon vehicle, so I figure 6 months-ish.
So I think, here on terra firma, I think and I think with COVID, we certainly are beginning to see new things about the SARS coronavirus 2 pathogen. But I think, for the most part, as we begin to understand pathogens, they behave in a typical way. What have you been learning up there about how microbes act in space? And is there information that you're beginning to get from some of the sequencing?
Yeah, that's a great question, and actually it's one of the experiments that I've been working on this week. So we're working on a comprehensive map, sequence-based map of the space station. We're taking about 1,000 samples total, and so I'm very carefully swabbing all of the modules. Everybody floats by and says, "Kate, are you still swabbing?" And I'm like, "Yep." 1,000 samples is a lot. We're really trying. We've done some early microbiome studies where we do a smaller number of samples, but with this one, we're interested in a really comprehensive three-dimensional map. We do know some information about the way that microbes change in space, and there's not just the behavior of the microbes in terms of their gene expression, what products they're producing, but also who's up here. So if you think of the microbial community as a census, we're trying to take a census of which microbes are on space station, which maybe we carry up here and find it a favorable environment, which we don't even bring up here because we don't have a lot of things like soil coming up here. So we want to know who's up here, and we want to know how they're changing. In terms of viruses, we actually have done very few studies. We do know that astronauts are a little bit immunosuppressed, and we can get things like VZV reactivations. This is a virus that causes chickenpox and shingles later in adults. We've seen that before in astronauts. But we don't have a lot of information about basic virology up here, and I think this would be pretty fascinating to study.
Well, I'm sure there's a lot of folks at CDC who'd be interested in trying to go up and help out with some of that work. But so I guess to go back to bacteria, so my division at CDC works on a number of rare bacteria, one of which is called Elizabethingia, and it's named after the CDC scientist who first identified it, whose name was Elizabeth King. Folks may be interested to know that one species of Elizabethingia was first identified in space, actually, in the condensation water on the space station Mir, which Russia had in orbit from 1986 and 2001. Does it surprise you? I mean, again, you sort of alluded to this in thinking about the microbiome and what it looks like there and how it's influenced by who's on the space station, but does it surprise you that we might find the same or different bacteria in space?
Yeah, I think it's incredibly interesting to see what it's like in a completely artificial environment, and so you can probably see a little bit in the background here. We're surrounded by 4 walls of pretty technological things. So we don't have, for example, houses that we're going to. We have no dirt that we're interacting with. We don't have anything that you would see in the natural world. And so this is a completely man-made artificial environment. And so it's pretty interesting to try to understand which pathogens would survive up here, which surfaces they would colonize, who would grow well. For the most part, we don't have a lot of pathogenic bacteria up here. We do culture-based methods for a long time, and we're really starting to get into the sequencing now. But it is interesting to understand how microbes might adapt to this new environmental niche in space. And I think a lot of the sequence-based technology will uncover things that we just haven't picked up. We've been here for 20 years on the International Space Station, but culture-based methods may not be picking up kinds of interesting things that we see up here. And so doing these comprehensive surveys is probably going to discover a lot of new things. If you have folks that need to isolate and grow up some cultures, we sure could use the help.
So there's been now some promising research collaborations between CDC and NASA, and the technologies that you guys are working on are helping to enhance data on environmental hazards that we're beginning to accumulate. And there's real interest in the sampling of the interior of the living spaces for antimicrobial resistant organisms. What other sorts of collaborations between CDC and NASA do you think can benefit from both of our current work, other than culturing viruses in space?
Yeah, so a lot of what CDC does is really a huge strength is the epidemiology work, and it'll interest you to know that we actually do quite a bit of that at NASA. And so we've got a very particular subset. We're looking at astronaut health, and we're looking at long-term effects of space travel. But I think that the expertise at CDC with the epidemiology aspect and this very kind of unique cohort could definitely benefit from a collaboration. And then I think also things like the wet lab work in terms of understanding how to process samples, how to identify samples, how we could increase the efficiency and the throughput on the International Space Station. I know at CDC you guys process thousands, hundreds of thousands, millions of samples, and so you understand how to do that kind of work, and we understand how to adapt that to the space environment. And then also computationally, so we're very interested here in trying to figure out eventually when we go to Mars, and then also for the lunar surface, how are we going to be identifying organisms? Does that database reside on Earth? Does that reside up here? Understanding the flow of information and how we can take a look at these things computationally, and that's also really a CDC area of expertise that is done very well.
Yeah, and a big area of recent focus as well, just thinking about that computational work. So Shannon, you look like you have something to add. No, okay. So I guess I'm going to move on to some questions submitted from people across the agency, so our rapid fire questions. So the first one is, can you see the Milky Way from space?
Absolutely you can, and it is even more spectacular in space since you don't have an atmosphere to get in the way. The number of stars you can see is stunning.
Oh, amazing. So question to both of you. Who inspired each of you to go to space?
Well, I think you already told my story. It was the early moon landing that inspired me.
I'm not sure where I got the inspiration to go to space. I just always wanted to be an astronaut. My parents definitely encouraged that, and they let me go to space camp, but I did have to work for it. So I had to mow the lawn, and I earned $3 an hour. So I'm going to credit them with a lot of inspiration for hard work, and it's sometimes good when you have to put some skin in the game for your dreams.
So, well, when growing up, I had to clean the bathrooms. So, and I think I got about $3 an hour. So the next question, what was the first thing that you ate in space? And Shannon, I understand that you like to cook. So have you experimented with cooking in space? Any success stories to share?
Yeah, we do have some experimenting that goes on up here. I think at Thanksgiving, we didn't get our expected food supplies for Thanksgiving, so we had to improvise. But we did have some what is it? Some cornbread dressing. We had a can of crab meat, and we had some sauce that I made, or that we had. So I sort of put together some deconstructed crab cakes for our Thanksgiving dinner. So that was fun. And then the other day, we actually got to harvest some of the plants that we're growing, and so we made some improvised salads that were pretty good.
So what's the condition of how loud is it in the working environment aboard the space station?
Yeah, acoustically, it's actually it's an incredibly loud environment. We have a lot of folks that monitor our hearing protection up here, and we actually evaluate each payload for what it's contributing to the acoustic spectrum. And I think it's about 50 decibels in our crew quarters, which is the quietest place on Space Station. It can get up to like 85 when somebody's running on the treadmill. We limit that noise protection. We do have hearing protection up here. But it's actually, I think that's a really interesting area of research research because we're surrounded by pumps and fans. So we live in the middle of our life support equipment. So those kind of maintenance floors on all of your buildings, and we eat and we do our work here. And so monitoring that acoustic level, understanding if it's a hazard to human health, it's a really big deal in space because we're in this environment for so long.
So do you wear like the little earplugs like what we wore in the BSL-4 lab?
We do wear those to sleep if we can, but then on the other hand, we also have to be able to hear any alarms if we get a caution or a warning alarm that goes off in the middle of the night that signals a space station problem. So you want to block the noise, but you also want to be able to hear the speakers and the caution and alarm. So if CDC's got any interesting technology for acoustic monitoring and or noise prevention in the background, we'll take that too.
Okay. Yeah, maybe you need some more strobe lights like we have in the BSL-4 lab. So I think we are being asked to wrap this question. So I'm going to ask you one more question, which is also from folks in the agency. The world has been dealing with social distancing measures over the past year due to COVID-19, and certainly you have an interesting perspective on that being on the space station. And what has the experience living on the space station taught you about maintaining mental health under isolating environments?
Yeah, we actually get that question a lot, and I know some of our crewmates have given talks to address this. I mean, the important thing is to try and stay connected somehow to your friends and family, and we do that similarly to the way people are doing it on the ground. We have phone calls that we can make from the station down to our family, and we are able to do video conferences every once in a while. So that's how we contact the people on the ground, and then we realize that the people we're with, of course, are our space family. So we get to spend time together, which is really nice.
So hopefully you don't have too many arguments with your space family. But no, we really appreciate your spending the time talking to us. I see some head shaking there. And it's been just a great pleasure to have the opportunity to talk with you guys on the space station. So thanks so much for the opportunity. Good luck with everything that you're doing, and we really appreciate the time you spent with us.
Thank you, Inger. Thank you so much to all the Centers for Disease Control. You guys are doing an incredible job to keep our United States safe. And from the International Space Station, we really appreciate it. Thank you.
Station, this is Houston ACR. That concludes the event. Thank you.
Thank you to all participants from the CDC station. We are now resuming operational audio communications.
I have a feather. In my right hand, a hammer. And I guess one of the reasons we got here today was because of a gentleman named Galileo a long time ago who made a rather significant discovery about falling objects in gravity fields. And we thought that where would be a better place to confirm his findings than on the moon. And so we thought we'd try it here for you. The feather happens to be appropriately a falcon feather.
Welcome back to Earth from Space. In this week's edition, Copernicus Sentinel-1 takes us over the Falkland Islands in the South Atlantic Ocean. The Falkland Islands lie around 500 kilometers northeast of the southern tip of South America and comprise two main islands, West Falkland and East Falkland, as well as hundreds of other smaller islands and islets, which form a total land area approximately 5 times the size of Luxembourg. The two main islands are separated by the Falkland Sound, a channel that averages 20 kilometers in width. This multi-temporal image combines two radar acquisitions from Copernicus Sentinel-1 taken 1 month apart to show changes over time. The first image was captured in December 2019, while the second was taken in January 2020. Here, the main changes between acquisitions occurred in the open ocean, with the bright red colors showing wavy waters in December 2019. The landscape of the Falkland Islands comprises mountain ranges, flat plains, rugged coastline, and cliffs. Hills run across the northern parts of the two main islands, with the highest point being Mount Osborne on East Falkland. Two inlets, Berkeley Sound and Port William, visible in the far right, run far into the land and provide anchorage for shipping. The majority of the population of the islands live in Stanley, on East Falkland. The islands are covered with grasslands, which are widely used as pasture land for sheep and cattle, and are also an important habitat and breeding grounds for birds, seals, and penguins. Copernicus Sentinel-1 provides a continuous sampling of the seas, offering information on wind and waves. This is useful for understanding interactions between waves and currents and to improve efficiency for shipping and wave energy applications, potentially producing economic benefits.
Welcome back to Earth from Space. In this week's episode, the many colourful curves and folds of the Flinders Ranges in South Australia are featured in this false colour image captured by the Copernicus Sentinel-2 mission. The Flinders are the largest mountain range in South Australia. They stretch for over 400 kilometres across the Australian outback, from Port Pirie to Lake Callabonna. The first humans to inhabit the ranges were the Adnya Mithina people, who have inhabited the area for tens of thousands of years. The Flinders Mountains are a classic example of a folded mountain range, which are formed when two or more of Earth's tectonic plates collide, folding and pushing layers of land into mountain ranges. The formation of the Flinders Range began around 800 million years ago, when an ancient sea deposited sediments into the Adelaide geosyncline basin. Millions of years later, the sediments were folded into mountains, which have since eroded. However, the folded rocks remained and were uplifted to create the landscape as we see it today. The area pictured here shows the Volcothonagamon Ranges National Park in the northern Flinders Ranges. The rugged park's main attractions include deep gorges, chasms, and an impressive wilderness. Numerous creeks appear like veins across the entire image, while the straight, white lines visible in the bottom right are dirt roads. The flora of the Flinders Ranges are largely species who have adapted to a semi-arid environment, including sugar gum trees, cypress pine, and mallee. Since the eradication of dingoes in the area, the number of red kangaroos, western grey kangaroos, and wallaroos in the mountains has increased. This image was captured by the Copernicus Sentinel-2 mission, a 2-satellite mission to supply the coverage and data delivery needed for Europe's Copernicus program. The image was processed by selecting spectral bands that could be used for classifying geological features. Welcome back to Earth from Space. Utah's Great Salt Lake and its surroundings are featured in this false color image captured by the Copernicus Sentinel-2 mission. The Great Salt Lake is the largest saltwater lake in the Western Hemisphere and one of the most saline inland bodies of water in the world. It is also the largest of the lake remnants of the prehistoric freshwater Lake Bonneville that once covered much of western Utah. The lake is fed by the Bear, Weber, and Jordan rivers, which together deposit around 1 million tons of minerals in the lake each year. As it is endorheic, meaning without an outlet, the water evaporates, which leads to a very high salt concentration. It greatly fluctuates in size depending on the rates of evaporation and the flow of the waters that feed it. The distinct color differences in the lake are caused by the Lucin Cutoff, an east-west causeway built to create a shorter route. The railroad line is visible as a sharp line cutting across the top part of the lake. This acts as a dam, preventing the waters to mix, leading to the North Basin having a much higher salinity than the southern, freshwater side of the lake. As the lake's main tributaries enter from the south, the water level of the southern section is slightly higher than that of the northern part. Several small islands, the largest of which are Antelope and Fremont, lie in the southern part of the lake. The lake's varying shoreline consists of beaches, marshes, and mudflats. The bright turquoise colors are evaporation ponds, from which various salts are collected in commercial operations. Although it is commonly referred to as America's Dead Sea, the lake is nevertheless an important habitat for millions of native and migratory birds. The lake's basin is defined by the foothills of the snow-capped Wasatch Range to the east, and by the Great Salt Lake Desert, a remnant of the bed of Lake Bonneville to the west. This part of the desert is known as the Bonneville Salt Flats and is used as an automobile raceway, as the flat and smooth salt beds make the area ideally suited for speed trials. Utah's capital, Salt Lake City, is visible in the bottom right of the image. This image was processed in a way that included the near-infrared channel, which makes vegetation appear in red, while rocks and bare soil appear in brown. Copernicus Sentinel-2 was a 2-satellite mission. The mission's frequent revisits over the same area and high spatial resolution allowed changes in inland water bodies to be closely monitored.
In this week's edition of Earth from Space, Copernicus Sentinel-1 takes us over the busy maritime traffic in the Bay of Naples, in southern Italy. The two identical Copernicus Sentinel-1 satellites carry radar instruments to provide an all-weather, day and night supply of imagery of Earth's surface. Here, 3 years of Sentinel-1 data over the same area, equal to hundreds of images, have been compressed into a single image. The sea surface reflects the radar signal away from the satellite and makes water appear dark. This contrasts with metal objects, in this case the ships in the bay, which appear as bright dots in the dark waters of the Tyrrhenian Sea. Boats crossing the bay in 2017 appear in blue, those from 2018 in green, and those from 2019 can be seen in red. Many large vessels depart from the port of Naples, one of the largest Italian seaports. From here, and the smaller port of Pozzuoli in the left, small leisure boats and ferries set sail to the nearby islands. Ischia, renowned for its thermal springs, and Procida are visible in the left, in front of Pozzuoli, while the beautiful island of Capri is visible further south. Numerous boats are anchored off the island of Capri. The island lies opposite the Sorrento Peninsula, to which it was joined in prehistoric times. Two indentations can be seen in its cliff-lined coast, the Marina Grande on the north shore and the Marina Piccola on the south shore. Other vessels are docked off the coast of Sorrento, as well as off the Amalfi coast in the right. The Bay of Naples is famous for its scenic beauty, including the steep volcanic hills surrounding it. The still active Mount Vesuvius can be seen just inland from the bay as a circular shape. Cities such as Naples, as well as the other surrounding towns, are visible in white owing to the strong reflection of the radar signal. Welcome back to Earth from Space. This week, Copernicus Sentinel-2 takes us over part of the Andes Mountains in southern Peru. The Andes are considered the longest continental mountain range in the world. They extend around 7,000 kilometers through 7 South American countries, from Venezuela in the north all the way to Chile in the south. The mountain range is the result of the Nazca and Antarctic tectonic plates moving under the South American plate in a geological process called subduction. Wind and water erosion are also a major factor for the shaping of the landscape. In this image, parts of the Ica, Ayacucho and Arequipa regions in Peru are featured. This false color image was processed in a way that makes vegetation appear blue, while irrigated vegetation and agriculture is visible in bright blue. Streams of water flowing from the high altitudes and through the valleys provide water for irrigation to the nearby agricultural fields. The small town of Puquio, with an elevation of over 3,000 meters, can be seen in the top right of the image, surrounded by vegetation. Directly to the left of Puquio lies the Pampa Galeras National Reserve. This reserve protects the habitat of the threatened vicuña, a wild camelid that lives in the high alpine areas of the Andes. The clouds in the bottom left of the image are an example of marine stratocumulus. These low-lying clouds are caused by cooler waters in the Pacific Ocean being pulled up to the surface, cooling the air above it and causing water vapor to condense into water droplets and eventually clouds. Marine stratocumulus clouds often develop off of Peru, with prevailing winds pushing the clouds inland. As the clouds are low, they are easily blocked by coastal mountains and hills, such as the Andes, and many other shapes, and extend over an area of around 500 square kilometers. Copernicus Sentinel-2 is a 2-satellite mission. Each satellite carries a high-resolution camera that images Earth's surface in 13 spectral bands. The mission is mostly used to track changes in the way land is being used and to monitor the health of vegetation.
Welcome back to Earth from Space. In this week's edition, the Copernicus Sentinel-2 mission takes us over part of the Great Rift Valley in Kenya. The valley is part of the Gregory Rift, an eastern branch of the East African Rift, which is being caused by the separation of the Somali Plate from the Nubian Plate. Major tectonic and volcanic activity have shaped the distinctive landscape of the Great Rift Valley, which runs through Kenya from north to south. The dramatic landscape contains the Cherangani Hills and forests to the west, a chain of volcanoes, of which some are still active, escarpments, and jewel-like lakes. Lake Baringo, one of the most northern of the Kenyan Rift Valley lakes, is visible at the top. With a surface area of around 130 square kilometers and an elevation of around 970 meters, the lake has an average depth of around 5 meters and is one of the 2 freshwater lakes in the Rift Valley. The lake has no visible outlet. Its waters are thought to seep into lavas at its northern end. where the rocky shore contrasts with the alluvial flat on its southern border. Baringo is dotted with several small islands. Its largest is visible in the center of the lake and is called Olcocque, also known as the meeting place. It is an extinct volcano with several hot springs. A great variety of birds inhabit Lake Baringo, which is also home to hippopotamuses and crocodiles. South of Lake Baringo lies Lake Bogoria, a saline alkaline lake. The long and narrow lake has an area of around 30 square kilometers and is around 10 meters deep. Lake Bogoria provides refuge for the lesser flamingo, with a population of around 1 to 1.5 million, and also supports more than 300 waterbird species. The lake is famous for geysers and hot springs along the banks of the lake, some of which can erupt up to 5 meters high. The lake's stable water level makes it highly important during times of drought. Copernicus Sentinel-2 was a 2-satellite mission to supply the coverage and data delivery needed for Europe's Copernicus program. The mission's frequent revisits over the same area and high spatial resolution allow changes in inland water bodies to be closely monitored.
In this week's edition of Earth from Space, Copernicus Sentinel-2 takes us over Barcelona, the second largest city in Spain. On the northeast coast of the Iberian Peninsula, Barcelona occupies a low plateau along the Mediterranean coastal plain. The city and its red roofs contrast with the forested hills and the sea that surround it. The famous Avinguda Diagonal is one of Barcelona's broadest avenues and cuts the city diagonally in two, hence its name. The circular Plaza de les Glores Catalanes was meant to be the city center in the original urban plan, but nowadays is used largely as a roundabout. The Garraf Massif Mountains are visible on the left side of the image, with their cliffs reaching the Mediterranean coast. The highest point on the coastal side is La Morella, almost 600 meters above sea level. The Llobregat River can be seen entering the image in the top left. The river rises in the eastern Pyrenees and flows southeast before emptying into the Mediterranean Sea. Before reaching the sea, the river forms a small delta, which used to provide a large extension of fertile land, but is now largely urbanized. Barcelona El Prat Airport can be seen to the left of the river. Along the coast, the port of Barcelona is visible, one of Europe's top 10 largest container ports. Barcelona is home to the Universitat Politècnica de Catalunya, the largest engineering university in Catalonia. In 2017, the university won ESA's Small Satellite Challenge and the top prize at the Copernicus Masters competition with its Federated Satellite Systems project. The FSS-CAT mission consists of 2 small satellites, CubeSats, each about the size of a shoebox, and will use state-of-the-art dual microwave and multispectral optical sensors. FISAT-1, an enhancement of the mission, carried on one of the 2 CubeSats, is set to launch soon from Europe's spaceport in Kourou. FISAT-1 will be the first experiment to demonstrate how artificial intelligence can be used for Earth observation. It will filter out less than perfect images so that only usable data are returned to Earth. This will allow for the efficient handling of data so that users will have access to timely information, ultimately benefiting society at large.
Welcome back to Earth from Space. This week, the Copernicus Sentinel-2 mission takes us over part of Channel Country, a pastoral region located mostly in southwest Queensland, Australia. The name derives from the many intertwined rivers and channels that cut across the 155,000 square kilometre region during times of high water. The landscape is mostly arid and includes flat alluvial terrain that is drained by the Georgina, Thompson, Diamantina,
and Barcoo rivers. This desert region usually becomes lush with greenery after periods of flooding, and the land is used for cattle grazing. In late March 2019, Tropical Cyclone Trevor hit northwest Queensland and produced heavy rain as it moved inland. Major flood levels were recorded across the Channel Country catchments. This false colour image, captured shortly after the cyclone hit on the 5th of April 2019, was processed in a way that included the near-infrared channel, which makes vegetation appear bright red. Mud and sediments in the waters of the Georgina and Diamantina rivers and the other smaller channels can be seen in cyan. Desert, bare soil, and rocks are visible in shades of green. Flooded waters then usually empty into the Lake Eyre Basin, one of the driest areas in Australia. In the bottom left of the image, the Lake Macadie area is visible. Covering an area of around 900 square kilometres, the area comprises 3 freshwater lakes, Lake Macadie, Lake Mipia, and Lake Coolaboo, and the nearby floodplains. The region is a designated important bird and biodiversity area by BirdLife International, as it has supported over 300,000 waterbirds. Copernicus Sentinel-2 is a 2-satellite mission to supply the coverage and data delivery needed for Europe's Copernicus program. The mission's frequent revisits over the same area and high spatial resolution allow changes in inland water bodies to be closely monitored.
Welcome back to ESA's Earth from Space program. This week, the Copernicus Sentinel-2 mission takes us over part of Abu Dhabi, one of the 7 Emirates that constitute the United Arab Emirates. Covering an area of approximately 67,000 square kilometers, the Emirate of Abu Dhabi is the largest emirate in the United Arab Emirates, accounting for around 87% of the total land area of the Federation. Abu Dhabi has around 200 islands lying along its 700-kilometer-long coastline. The city of Abu Dhabi, after which the emirate is named, is located on an island in the Persian Gulf and is the capital and the second most populous city of the United Arab Emirates, after Dubai. The city is directly connected to the mainland by 3 bridges: Makta, Musafa, and Sheikh Zayed. Just east of the city lies the Mangrove National Park, visible as a dark green patch of land. The protected area is around 20 square kilometers and includes mangrove forests, salt marshes, mudflats, and is home to more than 60 bird species. The waters surrounding Abu Dhabi are said to hold the world's largest population of Indo-Pacific humpback dolphins. The lighter aqua colors are shallow waters, which contrast with the dark-colored waters of the Gulf. The iconic red roof of Ferrari World can be seen in the center right of the image. The Ferrari-themed park is located on Yas Island and is said to be the world's largest indoor theme park. Abu Dhabi International Airport is visible southeast of the park. Sentinel-2 is a 2-satellite mission to supply the coverage and data delivery needed for Europe's Copernicus program. The mission's frequent revisits over the same area and high spatial resolution allow changes in water bodies to be closely monitored.
Welcome back to Earth from Space. This week, the Copernicus Sentinel-2 mission takes us over part of Chile's Atacama Desert. Bound on the west by the Pacific and on the east by the Andes, the Atacama is considered one of the driest places on Earth. There are some parts of the desert where rainfall has never been recorded. In this image, a specific area in the Tarapacá region in northern Chile is featured, where some of the largest caliche deposits can be found.
It is here where nitrates, lithium, potassium, and iodine are mined. Iodine, for example, is extracted in a process called heap leaching, which is widely used in modern large-scale mining operations. Leach piles are visible as rectangular shapes dotted around the image, although the exact reason for the different shades of color is uncertain. Some leach piles could appear lighter or darker owing to the varying water content or soil type concentration. The geometric shapes on the right are large evaporation ponds. Brine is pumped to the surface through a network of wells into the shallow ponds. The dry and windy climate enhances the evaporation of the water and leaves concentrated salts behind for the extraction of lithium, which is used in the manufacturing of batteries. The bright turquoise colors of the evaporation ponds are in stark contrast with the surrounding desert landscape, making them easily identifiable from space. Distinctive black lines visible in the image are roads that connect to the various construction sites. Copernicus Sentinel-2 is a 2-satellite mission to supply the coverage and data delivery needed for Europe's Copernicus program. This false color image was processed by selecting several spectral bands that can be used for classifying geological features.
Welcome back to Earth from Space. This week, Copernicus Sentinel-2 takes us over San Francisco Bay in the US state of California. San Francisco Bay, almost 100 kilometers in length, is a shallow estuary surrounded by the San Francisco Bay Area, an extensive metropolitan region that is dominated by large cities such as San Francisco, Oakland, and San Jose. The densely populated urban areas around the bay contrast strongly with the surrounding green forest and park areas. In the upper right, we can see the delta of the Sacramento and San Joaquin rivers, with the brown, sediment-filled water flowing down into San Pablo Bay. Here, the murky waters mix before flowing into the larger bay area, which is connected to the Pacific Ocean via the Golden Gate Strait. A large sediment plume can be seen traveling westward into the Pacific in the left of the image. The Golden Gate Bridge, around 2.7 kilometers long, is visible crossing the opening of the bay into the Pacific Ocean between Marin County and the city of San Francisco. Treasure, Angel, and Alcatraz Islands can be seen sticking out of the waters of the bay, with several bridges connecting its east and west shores. Several boats are also visible. The bright green and yellow colors in the bottom right are salt ponds and are part of the Don Edwards National Wildlife Refuge. Covering an area of around 120 square kilometers, the refuge contains salt marsh, mudflat, and vernal pool habitats for millions of migratory birds and endangered species. Sentinel-2 is a 2-satellite mission to supply the coverage and data delivery needed for Europe's Copernicus program. The mission's frequent revisits over the same area and high spatial resolution allow changes in water bodies to be closely monitored.
When did the exploration of space begin? At what time did man first conceive the journey to the moon? For thousands of years, the astrologers, the philosophers, the writers of fiction have dreamed of such a journey, a long, impossible dream. But soon, the dream will come true. In this 6th decade of the 20th century, the first men will land and walk upon the surface of the moon. The journey to the moon is not an isolated event. It is the result of a decade of research and discovery in space exploration. At NASA research centers, scientists, engineers, and technicians developed and tested new families of scientific satellites, unmanned spacecraft, which would extend man's senses where he could not yet see, or hear, or touch. Spacecraft which took scientific equipment and experiments into the unknown darkness and sent back the light of new knowledge. From these satellites, man has learned the nature of microscopic particles in space. He has measured air density at great altitudes, discovered how electrons deflect radio waves in the ionosphere, and where radiation belts encircle our planet. He has determined the true shape of the Earth and mapped it more precisely, made new measurements of solar energy, and sent telescopes into the night for a first clear look at the stars. Some were joint efforts to add to man's knowledge, the combined scientific quest of other nations and the launch technology of our own. The early scientific satellites carried only instruments into space. Later, they would carry life, plants and animals, ranging from microorganisms to primates. These biosatellites told us how weightlessness, radiation, velocity, and pressure affected life in the new environment called space. As man learned more about the Earth and near space, he sought to know about his neighbors in the solar system. Probes were hurled through interplanetary space to the neighborhood of Venus and Mars. Nearing Venus, our spacecraft reported the atmosphere to be very dense, the surface hot enough to melt lead. These investigations told scientists that on Venus there is little likelihood of life as we know it. NASA also sent deep space probes sailing across uncharted seas, more than 360 million miles, to look for a brief but wondrous moment at our nearest planetary neighbor, Mars. We learned that Mars is probably more like the moon than Earth, pockmarked with craters, with little or no magnetic field or gravity. As important as the return of scientific information was the new confidence gained in our technological maturity, that man could design and control such complex operations across millions of miles of interplanetary space. Over the past decade, scientists also developed complex new instruments to probe the intimate secrets of the long, mysterious moon. Television cameras took us live and close up to the lunar surface. Our spacecraft landed softly in the lunar seas. They examined the moon's color and sampled its chemical composition. Man witnessed a sunset on the surface of the moon, saw the sun eclipsed by the Earth, and looked back at his own planet 250,000 miles away. Other spacecraft circled the moon, photographing its yawning craters and soaring peaks, mapping more than 95% of its entire surface. These studies proved that man could land and walk upon the lunar soil. In this first decade of the space age, the science and technology which was used to explore outer space was also applied to practical benefits here on Earth. Down-to-Earth satellites provide a constant watch on the world's weather, serve as beacons for navigation by ship or plane, send voice and picture from any point on Earth to any other. In 10 years, we have come from a few experimental weather satellites to an operational system capable of night and day observations around the world. Today, satellites take portraits of storms that span half a continent and transmit them to meteorologists in many nations. They have detected hurricanes and typhoons and given valuable hours of warning to those who live and work in their pathways. Man has also learned to communicate by satellite, first with a great balloon that served as a reflector in the sky for earthbound transmitters. For most of the past decade, it provided millions around the world with their first glimpse of a man-made star zooming across the sky. Other satellites followed that could perform increasingly complicated communication tasks. Today, the technology proved out by these first families of satellites has been put to commercial use in an operational system which is available not only to television networks and businesses, but to people everywhere. All the world has been united to witness historic moments. Communication satellites have provided a valuable bridge to scientists working at distant points in the world. But space research was not the only mission of NASA. The first A in the name of this new organization stands for aeronautics. An airplane without wings, the lifting body. Someday, such a vehicle may be used to bring man back from space through the fiery re-entry of the Earth's atmosphere to a landing on the runway of tomorrow's airport. In 10 years, the field of aeronautics has kept pace with man's desire to fly ever higher, faster, and farther. Research has gone forward in jet noise, sonic boom, and aircraft safety. Hypersonic aircraft have been designed and built to fly to the dark edges of space. But the journey to the edge of space was not far enough. Man needed bigger rockets with greater power, the ability to cross the threshold of space for himself. In the 1960s, manned space travel became a reality. Many men here on Earth helped ready the systems which would take a few men across that frontier. The astronauts, star sailors on a formidable sea, conditioned themselves for the new phenomena of space. Then came the day when the first man was ready. Astronaut Alan Shepard became the first American to enter space.
5, 4, 3, 2, 1, ignition.
Many astronauts would follow on longer voyages into space. John Glenn, first American to orbit the Earth. The experience of each added more knowledge to the textbook for all of those who would come after them.
AMR telemetry. Telemetry quality. Mercury cap 3, 2.
From these first flights came important information about the men, their spacecraft, and the facilities and personnel who supported them. Man could withstand the force of gravity many times his own weight. Man could live for extended periods, weightless in the vacuum of space. Man could maneuver his own spacecraft in orbit, make scientific measurements, take photographs of the space around him and the Earth below.
76, Houston is standing by. Roger, understand. Station keeping at 120 feet.
Man could locate other spacecraft hundreds of miles across the ocean of space.
79, Hawaii. How are you? We've got a weird-looking machine here. What does it look like? The jaws are, it's like an alligator's jaw that's open, and it looks like they're fully extended. Roger. Okay, we have a rigid light. Okay, Gemini 8, it looks good here from the ground. We're showing cone rigid. Everything looks good from the docking. Gina was very stable. At the present time, we're having no...
Man could rendezvous and dock with spacecraft sent into orbit ahead of him.
Gina very stable and no noticeable oscillation. Okay, we're going to cycle our stop-on switch now. Roger. With light, we are down.
Man could perform complex scientific and technological experiments in space. Man could walk and work outside his spacecraft. first steps into space had taken man hundreds of miles above Earth. Yet he dreamed of more distant and demanding voyages, expeditions which would require bigger rockets and more sophisticated spacecraft, larger crews and longer times. And so, man began his preparations for the moon, and the nation was ready to meet the challenge. Behind the spaceman have stood thousands of engineers, scientists, and technicians, all part of the team dedicated to building and testing the many components which contributed to the dream. America called upon its industry and its institutions, placed new demands and offered new challenges to the establishments of our time. Education contributed ideas and experiments, scientific expertise, and manpower. Industry solved thousands of insoluble problems, found new methods and new materials when they were needed, achieved new heights in quality control and rates of performance. Sometimes there were failures and accidents that claimed men's lives. The astronaut pilot of this research vehicle landed safely. But we corrected the faults and continued the work to be done. Youth witnesses the culmination of a dream. Here in this building at the Kennedy Space Center, the mighty Saturn V rocket is ready. This is the vehicle which will thrust 3 Americans toward the moon in the greatest voyage of this century. The great adventure begins here at 1 mile per hour. A giant slowly and ponderously inching its way toward the pad, carrying with it the plans and performances of multitudes of people. A series of test flights with the Saturn V rocket was essential to man's landing on the moon.
18, 17, 16, 15, 14, 13, 12, 11, 10, 9. Ignition sequence start. 5, 4, we have ignition.
the rehearsal began with Apollo 8. 3 days and 238,000 miles away from Earth, the pioneers of Apollo 8 came face to face with the lunar landscape.
In the beginning, God created the heaven and the earth. And the earth was without form and void, and darkness was upon the face of the deep. And the Spirit of God moved upon the face of the waters. And God said, "Let there be light." And there was light.
These men were the first to orbit the moon, to go where man had never gone before, to see sights which man had never beheld.
The white day, and the darkness he called night, and the evening and the morning was the first day. And God said, "Let there be a firmament in the midst of the waters, and let it divide the waters from the waters." And God made the firmament, and divided the waters.
It was Christmas back on Earth, but this was the time when both the Earth and the moon were in the right places, and this was the opportune moment.
And the evening and the morning were the second day. And God said, "Let the waters under the heaven be gathered together into one place, and let the dry land appear." And it was so. And God called the dry land earth, and the gathering together of the waters called he seas. And God saw that it was good. And from the crew of Apollo 8, we close with good night, good luck, a Merry Christmas, and God bless all of you on the good earth.
Three months later came the second manned mission in the Saturn V rocket, the Earth orbital flight of Apollo 9, to test further the men and the new machine called the Lunar Module. Despite illness and anxious moments, the mission was successful. The command and lunar modules could separate across the vastness of space and could come safely together again. The next act in the prologue to lunar landing was Apollo 10. Two of the astronauts entered the lunar module and took it down to within 50,000 feet of the lunar surface. The final and most critical tests were completed successfully. The Sea of Tranquility now awaits the arrival of the first men from Earth.
Monitor descent.
Descent.
Helium monitor select switch to supercritical position.
Supercritical.
Three men will make the journey. Astronauts Neil Armstrong, Edwin Aldrin, and Michael Collins. They will share some of the experiences of those who preceded them. The launching, Earth orbit, rendezvous and docking, lunar orbit, separation of the command and lunar modules. Astronaut Collins will remain aboard the command module in lunar orbit. Astronauts Armstrong and Aldrin will land on the moon. Here on Earth, they have rehearsed the activities they will perform. The men are ready. The machines are ready. Now we know the dream will be achieved. The challenge will be met. In 10 short years, we have come a long way. But man's journey into space has just begun.
I believe that this nation should commit itself to achieving the goal before this decade is out of landing a man on the moon and returning him safely to the Earth. No single space project in this period will be more impressive to mankind or more important for the long-range exploration of space, and none will be so difficult or expensive to accomplish. But in a very real sense, it will not be one man going to the moon. We make this judgment affirmatively, it will be an entire nation.
We all want to go back to the moon. Getting us back to the moon in this generation sparks a whole new generation of explorers. Hi, my name is Dr. Kay Renee Horton, and I am boots on the ground for SLS. We actually weld our liquid hydrogen tanks and our liquid oxygen tanks on this. It is the largest weld tool in the world. It's the only one of its kind. It stands 170 feet tall and it has a diameter of about 27.6 feet. So as a quality engineer, we make sure that they're actually meeting the requirements they're supposed to meet. They do a phased array ultrasound, which goes in and checks to make sure we don't have any defects in the weld. To get up and to pull up the news article and they're talking about what you do at work is amazing for me. I really love detective novels, and so I'm an avid reader, and I actually write children's books in my spare time. My children's books are about Dr. H exploring the universe. Each day I walk into the factory, I know that I'm putting my footprints in history, and that's a pretty big deal for me.
The little red light is on. All right.
Number one.
You know, most kids, you start thinking at an early age, as soon as you look in the sky at night and you see stars, and you think, what would it be like to be up there?
No matter where we grow up, everybody looks up at the sky and says, what else is out there?
I started saying I wanted to be an astronaut when I was 5 years old, according to my mom.
It was the beginning of our astronauts making their way up to the moon. I remember coming back like, what is this? You know, how do I go do this? This looks like fun.
I looked at what NASA was doing. I was like, I want to be an astronaut. So in a nutshell, that's kind of what happened.
I got into the Navy test pilot school and then started to apply to NASA.
There's like 6,000 people that applied for, 15 slots. And I interviewed 4 times over 12 years.
I applied multiple times over 13 years and interviewed 5 times before I was selected.
Well, I did submit 7 applications along the way, but I got rejected by NASA 7 times, but the 8th time.
And the fourth time, I got a phone call that said, if you're still interested in being an astronaut, we'd like you to come to Houston.
Finally, it's launch day.
Launching to space, of course, was a momentous experience.
You see that this rocket is a living, breathing beast. The thing is alive, and it wants to go.
It suddenly feels like it's real.
First thing, you know, you're strapped into the space shuttle on the launch pad,
and I can say sitting in the rocket, getting ready for launch, you're anxious and you're excited.
And waiting for countdown, focusing on doing your checklist, focusing on your procedure.
10, 9, 8. At the moment of launch, you're quite prepared. 3, 2, 1, and 0, and lift off. Space shuttle lands. America has launched.
It lights off, and you feel the rumble, and then you start to move, and that constant, smooth acceleration pulling you back in the seat.
And you feel like you're just in a car wreck because the solid rocket boosters light off and they give you a kick in the backside like you were just rear-ended at a stop sign, literally.
There's just nothing subtle or nice about it.
There was the vibration, the pressure, the acceleration, the pressure in your seat.
I distinctly remember the point when I stopped and thought, I did it. I'm here. My goal was to be an astronaut, and now I'm in space.
As a kid, you maybe fantasize about spreading your arms and flying among the clouds and that kind of stuff. That's what we're doing. Floating is very cool.
It's fun to watch new astronauts show up in space too, because they creep around. We would joke like space mice, very timid, very controlled.
Being weightless the first few days is horrible. I mean, it's really neat to see something floating in front of you. It's really horrible to feel like you're gonna throw up all the time. And then as you start to get into it, you start to realize that the human's an incredibly adaptive machine, and weightlessness is really, really well suited for us.
You know, pretty soon you're going into a hatchway and you come through and you kind of push off on both sides and you go zipping down the middle and you're turning right at the end. So you reach out, grab a handrail.
But it also brings out your inner 5-year-old, or I say that it is the source of all stupid astronaut tricks.
It's as fun as you think it would be, only better. I think I told my wife that I thought it was a burrito of awesomeness smothered in awesome sauce, because I don't have a very big vocabulary, so I tried to use the biggest, most impactful words I could.
Everybody's a superhero. You're not floating, you're flying.
So the International Space Station, being only 250 miles above Earth, we call it the kind of the proving ground for a lot of science. It is a national orbiting laboratory for the United States, and we do have hundreds of science experiments going on at any time.
We're doing this amazing science up there. It is also absolutely the most wonderful observatory. And certainly for an Earth-facing observatory, the cupola module, this big bay window, you know, that we have facing Earth, is the place to be.
I got visited by 3 space shuttles. Several of the crew members never looked outside the cupola before. I would bring them one at a time to the cupola. Tell them to close their eyes, open up all the windows, the shutters on the windows, and then tell them to open up their eyes.
Cerebrally, I knew that this was going to be a life-changing experience. I knew that the view was going to be amazing.
And I will never forget that sight. The thin blue line of the atmosphere, the curve of the horizon, And that's when it became real, really at a gut level. I'm actually in space. We are on orbit. This is not a sim.
This is my eyes looking through glass at Earth from space. It was almost overwhelming.
And so I think it's kind of overload for your brain and processing all of that at once because it just isn't used to that.
You know, it's really hard to describe something like that because it's not just cerebral, it's emotional, it's kind of all-encompassing. My heart was racing. You couldn't wipe the smile off of my face. It was really amazing.
I just was, you know, feeling something as I was staring at this view of the whole thing. And it moved me to tears unknowingly, so.
In that instant, when you're overwhelmed with that vista, when your eyes see nothing but the beauty of the Earth, every single crew member that I brought in there for that exposure cried. It is heart-stopping. It is soul-pounding. It is breathtaking.
I mean, it was ridiculous. I'd never imagined in my entire life getting to see something that beautiful. It was so foreign for the human mind to look at that, to see the Earth highlighted that way.
Well, I don't think anything prepares you for how crystal clear it is. You know, I knew the colors, but they just seemed different to me. They seemed more vibrant, more translucent.
I've never seen those colors here on Earth. These pearlescent yellows and peaches that form when you're looking at a body of water with the sun angle. It's just amazing.
I just took a pencil and I drew like 15 curved lines and I just wrote light blue, darker blue, pink, purple, dark purple, all the way down to the surface of the Earth at sunset, because the scale of looking at a sun refracting through the atmosphere, it blew me away, okay? And no picture captures that. There's no high enough dynamic range of a photo to capture what the human can see.
How in the world am I gonna describe this? There's no words. There's no picture I could take to do it justice. There's no watercolors that I could put on paper to come close to the vividness, the ever-changing picture that I see staring at this planet.
And I think that's the challenge of really trying to express just what ran through my mind when I'd look out there, because my mind would just race.
It's like a work of art out the window there, and it surprises you every time you look at it. One of the most impressive things was watching thunderstorms, you know, storm activity moving around the planet.
You can see its path propagating around, and you have these big flashes all over the place.
You know, this one storm covering all the U.S. and lightning flashing off all over, nonstop.
It's like watching neurons firing in a brain. You know, these tentacles of light that are just connecting and traveling. Yeah, it might be starting over Florida, but it's like moving across the ocean to Africa as far as you can see. And that was, I mean, I remember floating there just thinking about, oh my gosh, everything is connected.
We got to see some interesting things up there. You know, one was Hurricane Dorian, a Category 5 hurricane with you know, such a well-formed eye. When you look down at it, flying over in the station, it doesn't even look like it's moving, but you know the power that's at the center of that storm and what havoc that storm is wreaking on everybody on the ground.
You look at it in terror, really, because you know all the people that are endangered underneath, but just the immensity of power that Mother Nature brings.
A hurricane, a thunderstorm, everywhere you look, there is the environment doing something crazy. So we're coming up over Brazil, about to go across into the Atlantic Ocean, and looking out on the horizon, I saw like, looked kind of brown. I'd never seen that really from the space station, and I instantly, what did I think? Human interaction pollution, for sure. It's just awful looking, it's terrible. But as we went over the Atlantic, it kind of got thicker and thicker and thicker. It was a sandstorm in the Sahara Desert, blowing this huge plume of sand up into the atmosphere, crossing the Atlantic Ocean and coming down in Brazil. I mean, that is crazy. If that doesn't change the way you think about the planet, absolutely nothing will.
What struck me was when we looked at natural disasters, you see a flood, and you really can't pick out where they are on Earth. But when you see it from space, you realize that the effects of these natural disasters really hit everybody equally. And it really gives you this perspective that, you know, first of all, we're all in this together, and that the world is very small.
What has always struck me every time I went there is how beautiful the Earth is, how fragile it looks, how alive it obviously is with the clouds, the water. It's like it's breathing.
When you first look at Earth, you may say, wow, that's a continent. And then you look at it again the next day and you say, wow, there are mountain ranges. And then you look at it again the next day and it's like, oh, I can see synclines and anticlines in the geologic structure.
You could see the Nile River and the Nile Delta so clearly, the Red Sea. And for me, that was just amazing to look down. You could see the Jordan River, the Sea of Galilee, the Dead Sea. And I was just thinking, this is where all this took place.
The color palette is hard to compare. I mean, all these reds and oranges, and so the dunes all over in Central Africa and in Saudi Arabia, you have these so many different textures.
And you can almost pick out where you are over the Earth because Australia's tans are different than African tans.
Every piece of the Earth has its own tone, if you want. So you become very acquainted with the Earth from a big picture point of view.
And you saw just the beauty of the landscape and the mountains and the deserts, and you start to think of how they were formed. You realize just how special the place we are is, and you feel that connection.
So when you look at the Earth from that vantage point, I know others have said this, you don't see the borders. You don't see political borders, you hardly see geographical borders.
You know, we're so used to looking at maps or globes. In low Earth orbit, you don't see a globe. And from no distance do you see the different colors for countries so that it makes them easy to distinguish.
I was looking for all the little pink and green countries when I was looking at Earth. Where's Uganda? It's supposed to be pink on the atlas.
You know, you don't see those geopolitical boundaries, all of the man-made boundaries that we've imposed upon ourselves as humans. You don't see any of that from space.
It's just you and your team, and you're trying to make an impact on us evolving into something more. You forget about the politics. You forget about daily life that plagues us here on the ground, that colors our perceptions because you're insulated from it.
And you just feel this sense of commonality more, and something that unites us all, and just that we're all human.
Flying over Africa in the daytime with intense sunlight so much of the time, you don't really see much detail. It's so bright. But at night, when it's illuminated by starlight or moonlight, you really see a lot, and it's just fascinating.
And you don't quite see the same texture, but you see mankind's influence on the planet.
You get these beautiful, twinkly city lights.
And they represent human sprawl, which isn't necessarily bad, but it is incredibly beautiful from space.
I love looking at the atmosphere at night when you have that air glow, and sometimes it was a bit green, and then you have the aurora dancing around.
And we were flying into this astonishing aurora, this rippling, pulsing river of green that's down below us, and the red that is stretching up to our altitude. It's like, it was just breathtaking.
Auroras, the presence of humans at night, it's obvious with the lights. But it's the death around the Earth that's startling. How this beautiful, shining oasis of life is there naked in the middle of pitch black death. the vacuum of space.
Definitely look up and see the stars like you have never seen them before. I mean, the Milky Way is just stunning.
There's many things in the cosmos to gaze at it. For example, the Magellanic Clouds. Those show up really bright and vivid because you don't have atmospheric scattering. You can see Andromeda, the spiral galaxy of Andromeda.
Of course, the lights don't flicker. They're steady because they're not coming through the dust and coming through the atmosphere. And then as you really adjust, you start to sense the very subtle colors that are in the stars. A little bit of reddish, a little bit of bluish, blue-white.
Just all the colors and the light come out, you know, in that depth of space as well.
I could all of a sudden detect depth. Now, I couldn't tell you how much, but it's light years, right? And it's like, whoa, I can somehow tell that that star is closer than that star. And that was something that knocked my socks off. And I thought, nobody told me about this.
I don't think I had thought before going up there about how many stars you see, you know, the density of stars.
You see so many stars, it becomes hard to pick out constellations. People ask if there's aliens, and I'm like, of course there are aliens. Look at all those stars. There's got to be.
It's just so vast and infinite. I don't know what else to say about that.
I remember using like the 800mm lens and just really zooming into places. And you know, you still can't see people walking around or anything, but you see impacts of things. And you realize that a lot of times we have to pull way back. You know, you have to pull way back and see the big picture of it.
You realize just how small you are, because you at times struggle to find evidence of human activity down there. You can go over massive swaths of the Earth and not see a trace of any human impact. Or you can go over other swaths and you can see dramatic impact.
Frequently in the summertime, there's a lot of fires in Africa. You see all of those plumes of smoke heading west across the Atlantic.
You fly over South America and you see, you know, widespread deforestation, and you know the impact that that has. You can almost get a sense of the balance of, you know, how nature is trying to balance all the inputs and the outputs and have a stable system. And you can see our effect on it.
To me, it started to make me understand that everything is connected. What is happening in the ocean over here can affect what is happening on land over here. It's just all one being, thing, and it's all interconnected.
You can see combat. I mean, we were two countries were at war, and you could very easily see missiles being shot. They just look like little tiny traces of light. You can see all that stuff. So to me, I didn't see one unified human civilization. You certainly see one unified planet cruising around the sun, and that is a unique perspective.
But during my time on space station, I had the chance to do a spacewalk, put on a spacesuit and go outside. And that's a very special experience for any astronaut.
You're inside the space station or the shuttle, and now you put on a suit and go outside. It's like there is an elevation and risk when you do that, but it is a bit thrilling.
Spacewalks always seem to be very busy and task-focused events where I got to do this and I got to move over here and do this. And
then you just have to not think about where you are. Just concentrate on getting the job done. What's the big picture?
Rarely did you have a minute where you could just say, just take a minute and enjoy the view. But, you know, there were those minutes every once in a while. And the view from outside the spacecraft, you know, with that full panoramic vision through your helmet visor was just incredible.
It's a very disturbing view, looking down about 240 miles at the Earth going by at, 17,000 miles an hour. It's like, oh boy.
I just watched the Earth going by below me, and I only had this, thin visor separating me from a very unsurvivable atmosphere. And my feet were dangling. I remember, not just through my visor, but looking down and you just see feet and then Earth, and you're holding on to the space station. And it was just incredible. Everything looked so large.
The colors are even more vibrant. And I think also just mentally, psychologically realizing that, there's nothing between the vacuum of space except for this spacesuit and your visor.
I remember thinking that coming out, like that the world would just open up around me. And the view, for some reason, seems bigger than what you have when you're looking through the windows of a spacecraft.
It wasn't like Earth is over there. It wasn't small. It was like it took up your entire, visor and all as far as you could see, and just watching it come over Earth and just how large Earth was from our perspective.
But oh my gosh, you see Earth and you see your glowing station around you, and you realize, okay, I gotta stop looking at this stuff because it becomes a distraction to the work that you're doing out there.
So I always kid those astronauts that don't do the spacewalks. I said, the view from inside here through this flat window is pretty good, The view from outside is just amazing.
And the great thing about living on space station, I loved every minute of it. I had a countdown going, but it was, oh no, I only have 2 months left.
All right, one last look at the Earth. This is some good news. The Earth is still beautiful. An Earth in crisis is still an Earth worth returning to.
Life seems extremely busy, and the days start flying by, and before you know it, it's over.
As it drew to a close, I think I was more feeling as though, did you do enough to capture this so that you can share it when you get home? And so that you can light those fires in people as you go around and talk about this and try to, ignite the passion in kids just like I had ignited for me as a kid.
And you're back on the ground, and somebody else is doing the job up there now. It makes you feel like, this is a really big thing that we're a part of, and I'm fortunate to play my part.
It is the fact that going to space and seeing the Earth from that vantage point has a life-changing effect on most of us.
It takes a lot of energy to describe what it's like up there, because there's so much of your emotion built into it.
I think the best way to describe it is that your viewpoint changes, that you can look at the same thing, but it changes the lens through which you see it.
And that acute concrete realization that we belong to Earth and not vice versa, it's kind of a mental shift to see that we just nowhere else we could go.
I think if you're not a conservationist before you go to space, you're at least partly a conservationist when you come back, because when you see how thin that atmosphere is, that protective layer that we have here, you think, wow, we really have to take care of this because it does look so fragile from space.
I think I felt that need to protect it even before leaving it, but it definitely does resonate even more loudly now, having seen it myself, and how stunning and beautiful it is. All of those unique ecosystems, everything's connected, the land masses and the ocean masses and the atmosphere, and we are all in it together. We are all down there. And so I think that's the most important thing that I would encourage people to think about, that perspective.
I think you get a sense of preservation of I don't want this to go away, and I don't want to be the only one to see this. And there are so many people that need to see it, but only a handful will in this lifetime.
You know, I remember coming back from all my missions with that sense that, you know, we're all connected, we're all people. And I thought about, why is it that we do have conflicts? What is that separates us from one another?
If you could get 7 billion people to go up there and look down for just even 30 seconds, you would change them, all of them, forever. They wouldn't all come back and be friends. They wouldn't all come back and tear down border walls and things like that. But you would change all of them, and you would change them all for the better, and they would have a different view of the planet.
I think if people that can lift their eyes up and see the bigger picture, whether it's from orbit or even just understanding the different sides, maybe spending more time listening, you know, rather than shouting.
And that's what I want people to find. I absolutely found that in the experience I had in space, in the simple facts of us living on a planet and all being Earthlings, and the only border that matters is that thin blue line.
One of the reasons we got here today was because of a gentleman named Galileo a long time ago, who made a rather significant discovery about falling objects in gravity fields. And we thought that where would be a better place to confirm his findings than on the moon. And so we thought we'd try it here for you. The feather happens to be appropriately a falcon feather.
Throughout history, humans have been described as many different things. But one of the most intriguing and apt definitions came from Aristotle, when he defined humans as a rational animal. According to this definition, human rationality and problem solving is what separates us from all other animals. Of course, we can look back at history and see notable examples of human problem solving, from the construction of the Great Pyramids, the precise engineering of Roman aqueducts, the Industrial Revolution, and millions of other examples. It is clear to see that when faced with new problems, we can overcome the status quo and develop new and exciting paths forward. That problem-solving spirit can also clearly be seen today in our modern world. New technology and ideas are changing our planet daily, but with each new change, generally new problems arise that need to be solved as well. Although there are many different organizations that solve modern problems, one that has stood out for decades and continues to be a leader is NASA. Since its first day of existence in 1958 through today, the brilliant men and women of NASA have time and time again solved some of the world's most difficult challenges. One of the key areas NASA continues to shine is in development and testing in the field of aeronautics. Although NASA rightly gets credit for expanding our horizons in space, the reality for the public is that relatively few people are directly affected by space travel. Ironically, the work in the aeronautics field that NASA has pioneered for decades and that affects millions of people daily is less well known. From the beginning, NASA engineers and researchers have led the way in virtually every aeronautic development. From advanced wing designs through the hypersonic frontier and onward into the era of composite structures, electronic flight controls, and energy-efficient flight. And since 2011, NASA researchers from around the country have been working on NASA's Unmanned Aircraft Systems Integration in the National Airspace System, or UAS in the NAS project. This project was a new type of undertaking that worked to identify, develop, and test the technologies and procedures that will make it possible for unmanned aircraft systems to have routine access to airspace occupied by human-piloted aircraft. NASA's innovative work in this field has led to many of the breakthrough technologies that will undoubtedly change the way aircraft currently move through our skies. But after years of study, team members are closing the books on the UAS and the NAS project that has provided so much new information about how future aircraft will fly. Today on NASA X, we will explore the work performed by the UAS and the NAS team. We will look back at some of the complex systems and procedures that have been developed for the UAS and the NAS project, and see how NASA and industry have successfully worked together to improve manned and unmanned flight as we know it. Finally, we will bid farewell to the team that is changing the way we all fly and look to the future to see what's next on the horizon for the UAS community. NASA is clearly one of the world leaders when it comes to science, engineering, and research. But surprisingly, many people in the public really can't tell you much about the agency. If asked to describe where NASA is located, for example, many would be hard-pressed to say anything more than in Houston or Florida. Many also just see it as a giant nebulous government agency that works on engineering and research projects. But other than astronauts, no particular person or place is necessarily strongly associated with NASA today. The fact is that NASA is comprised of a consortium of research centers, test and assembly facilities located around the country, all working diligently to solve complex technological problems. Each center specializes in different areas such as spaceflight or aeronautics. But within the UAS and the NAS project, centers across the country have been utilized to contribute to this groundbreaking research. In particular, 4 aeronautics-focused NASA centers supported the UAS and the NAS project: Ames Research Center and Armstrong Flight Research Center, both in California, Langley Research Center in Virginia, and Glenn Research Center in Ohio. Lastly, the entire project was managed by NASA's Aeronautics Research Mission Directorate at NASA headquarters in Washington, D.C. Since the start, the goal of this unified team was to provide vital research findings through simulations and flight tests to support the development and validation of detect and avoid and command and control technologies necessary for integrating UAS into the NAS.
When we got involved in this, we knew that some of the key areas that you need to focus on is how to stay well clear from other aircraft, particularly when you're in uncontrolled airspace. So low altitude, classy airspace where there's a lot of general aviation traffic, so you're not under direct control of an air traffic controller. Everything just came together. communications and the wonderful work that we've done at Glenn Research Center relative to space communications. So we had terrific technology there that could apply to this arena as well. So those two long poles were detect and avoid. How do you, when there's not somebody sitting in that aircraft, how do you see other aircraft that maybe their transponder's not working or they don't have ADS-B? And then how do you communicate and communicate effectively with air traffic control on your intent or maybe changes to your flight plan that you have to get cleared? So how do you do that? And how do you not put an additional burden on the NAS, on air traffic control and how we're operating the NAS? So you're just another vehicle. So we have the technology to do that. We have a research kind of culture that we know how to do that research and not just provide them opinions, but hard factual data on what different types of technologies and how they work, what that would mean in different kinds of scenarios. And we had a cadre of incredibly smart women and men researchers who know how to do this work. And everybody that could possibly think about delivering some service or some product to a household or between businesses now has an interest in the work that we've been doing.
That interest moved into full-scale testing and evaluation to determine how to best integrate unmanned vehicles into the national airspace and how to come up with standards moving forward.
So the overall goal of the project is to enable or assist the enabling of the safe integration of unmanned aircraft into the national airspace. To this end, we're assisting industry and the UAS community in developing standards. We're performing simulations, analysis, and flight tests that inform the development of these standards, primarily in the areas of detect and avoid and command and control.
When NASA first undertook this challenge, they realized they would have to bring an A-team of engineers from the aforementioned NASA field centers, along with highly skilled teams from industry and academia, in an effort to unlock the keys for UAS integration into the national airspace. Normally, more than 44,000 flights safely take off and land here in the U.S., totaling more than 16 million flights per year. With the inclusion of millions of new types of unmanned aircraft, this integration needs to be seamless, keeping the flying public safe while also allowing these new vehicles to perform their assigned tasks. Looking at the challenges from the start, researchers knew that some elements would need to be considered from the ground and the sky. First was to improve the electronics on board the UASs and the electronics on the ground. Much of that command and control work began here at NASA Glenn Research Center.
UAS and the NAS C2 sub-project is really investigating the communications links between the pilot on the ground and an unmanned aircraft. There's quite a bit of information that needs to go back and forth. We often call it a pipeline. When you bring the pilot to the ground, all the information that he would normally see in the aircraft has to now be digitized and sent down through this secure link. What we've done here at NASA Glenn is to investigate the comm link. We have a long history in radio communications here, and so we started from scratch essentially to develop a radio. One of my tasks is to test those radios, both in the laboratory, and then we put them into real aircraft, piloted aircraft, and run them through a series of tests.
Although this project is all about unmanned aircraft, as Kurt mentioned, the tests here at NASA Glenn were conducted with piloted aircraft. The workhorse of the testing was this Cold War-era S-3 Viking. This aircraft was chosen due to its resiliency to carry extra weight. to fly on one engine in the event of an emergency, and because of its robust electronics capabilities. But in today's modern world, one would think that the researchers at NASA would simply create computer simulations and not fly an aircraft.
With this project, we're actually investigating multipath with our communication systems. Basically, the signal bouncing off other entities. So we flew this aircraft over areas of rising terrain, over mountainous areas, over land to sea interface, if you will. And that's one of the ones that our model wasn't matching. We didn't realize the impact of sailboat masts and some of the other things on the water and what it would do to the signal. And so we were able to validate those simulations and show, hey, our model's not quite that accurate. We'd have never picked that up until this technology had been implemented, had we not flown it.
These test flights are precise and technical in order to obtain the best results possible.
You'll see a series of waypoints that are listed as LP 1 through 16, and those are at different ranges from the ground station. They're all at a fixed altitude, and what we're doing is gradually moving the aircraft away from the transmitter so that we can see how many, when we start to pick up these signal errors. So he'll fly this test. It'll take a couple of hours. We will then collect the data, process that, and then come up with a test flight plan, perhaps a revised one or a different one for the following day. What that's doing is the signal is leaving our tower, which is about our antenna is about 50 feet off the ground on a tower. Down in this situation, this is in southern Ohio, where it's fairly rolling hills, and we want those rolling hills because those help to reflect our signal. So by going to different altitudes, our signal will clear the mountains and the terrain that's below. Once we get up high enough, it'll be a straight shot, no terrain obstructions, and we know that that's a safe altitude for this aircraft to fly.
Back at the other three centers, teams were working hand in hand to better understand how these UASs would travel in the national airspace by using NASA-developed software in combination with flight tests. Much of this work is centered squarely on technology called detect and avoid.
When you are a pilot in an aircraft, a human pilot in an aircraft flying, there are certain aviation regulations that you have to comply with. And those regulations require that the pilot be able to see and remain clear and avoid other aircraft so that there are no collisions. Makes sense, right? So what detect and avoid is since the pilot for an unmanned aircraft is either remote off the aircraft or not there at all in the case of an autonomous aircraft, there is no human eyeball to go see other aircraft. So the technology needs to be developed to use other means such as radars or cameras to be able to detect where other aircraft are flying in the proximity of your aircraft, your unmanned aircraft, and then be able to somehow, like a pilot would, avoid those other aircraft. And the way that's done is through developing some mathematical algorithms to be able to direct the aircraft to a location that would be safe. And so that's the kind of research that NASA wanted to focus on, because that was the most critical aspect of how to safely integrate unmanned aircraft into the national airspace that industry writ large could not really understand. They didn't know how to do that. They knew what it was like to be a pilot, but they didn't know how to turn that into some sort of certifiable technology. And so NASA spent the time UAS and the NAS project was in existence to be able to develop the technologies by which to address the challenge of detect and avoid.
Detect and avoid has three major components, technical areas. One is guidance and control, which develops the algorithms that we use to tell us what our options are to avoid other aircraft once they're detected using airborne radar or ground-based radar. We have modeling and simulation where we run fast time simulations. We can run millions of trials, and to be able to really pare down what we bring into the human-in-the-loop simulations, which are really the purview of the Human Systems Integration Group, and that's the lab that we're in here. So when we run subjects here, we have already pared down a lot of the solutions, and we're looking at how real pilots interact with a fairly realistic airspace and some of the solution spaces that we have developed in the other technical areas.
One of the primary safety concerns with integrating these new systems is the inability of remote operators to see and avoid other aircraft. On all flights with pilots on board, the FAA requires the crew to be aware of all other surrounding aircraft, either visually or using onboard instrumentation. In addition to instruments, the pilot physically looks out of the window in order to avoid other aircraft. Because unmanned aircraft literally do not have a pilot on board, NASA and its partners have developed concepts and designs allowing safe operation within the national airspace. In order to better understand how all the systems work together, the NASA team flew a series of tests out of NASA Armstrong in California. The objectives of these flights included data collection to inform the development of minimum operational performance standards, or MOPS, for detect and avoid alerting guidance.
The third phase was what we called full mission. And so what this involved was a naive UAS pilot coming into our research ground control station and flying a simulated mission with everything that you could expect to have on a real UAS mission, except in this case some of the aircraft were virtual. We had a live intruder, and we had real pilots talking over the radio and an air traffic controller talking over the radio. It seemed like it was a real mission, and we were actually able to gather a lot of metrics that you would normally gather in a lab, but in this case, a real atmospheric flight. And that's what we call live, virtual, and constructive. So we had the live component, which is the live UAS and the live intruder, the constructive, which were traffic simulated aircraft that were moving in the airspace, and then virtual, which were actually people who were flying simulated aircraft and talking over the radio. And all those things combined to create a really immersive test environment.
So there's a significant amount of research going on across government and industry in the area of unmanned aircraft, everything from small drones to large unmanned aircraft. Detect and avoid capability is critical to all types of unmanned aircraft. And another natural extension of the work that we've done is to move towards automation of the operation of UA, especially when lost link occurs.
NASA is also doing flight demonstrations called the Systems Integration and Operationalization Demonstration Activity, or SIO. The SIO flight demonstrations partners will use various sized unmanned aircraft for these tests.
NASA's partnered with the FAA under SIO. We're also partnered with 3 different companies: Bell, General Atomics, and American Aerospace. And each of these companies has a different concept of operations and different unmanned aircraft that they are attempting to certify for operations in the National Airspace System.
It's clear that automation and new breakthroughs will continue to push this research forward. Over the course of this testing, NASA and the FAA have gathered an enormous amount of data, allowing safe integration for unmanned aircraft into the national airspace. As unmanned aircraft are becoming much more ubiquitous in our world, safety, reliability, and proven research must coexist to continue this unique integration. NASA and its partners have thoroughly evaluated every aspect of this proven technology, laying the groundwork for companies to develop exciting new vehicles based on the data that has been generated.
For me personally, this is just a really exciting area, realizing that this is a really fast-growing area. Aviation has had kind of a slow and steady evolution. It's been good, it's been relevant. It's been introduced in a very methodical and safe way. And suddenly you have this introduction of UAS into the mix where you've got a lot of, my words would be non-aviation type entities that are wanting to come into this market. So to create some standards around which they can develop their aircraft, around which they can develop their use cases so that they really can seamlessly integrate in the national airspace, it's a pretty exciting area to be involved in. And it's a fun area because a lot of these companies have really great ideas. You know, they're not traditional from the standpoint of being an established airframer or established engine company, but they have great ideas, and realizing that we'll be able to enable that kind of next wave of emerging companies and ultimately emerging products that come from that, it's pretty exciting. So it makes me want to get up in the morning and come to work.
I've been on all sides of the research, and it's very rewarding to be a part of the team. They work long hours, and overall, we're all striving for the same goal, which is to get these large unmanned aircraft safely and smoothly integrated into the national airspace. And it's been a lot of work, but I don't think anybody on the team would say it hasn't been worth it. It's been a pleasure to be a part of the team, and you really can't say enough great things about the project.
The last thing I would mention is that this was just the results of a project with a specific goal that we had within NASA Aeronautics, but it's certainly not the end. I mean, integrating UAS into the national airspace is an evolving thing. There are many more challenges. There are many more use cases that the industry is going to come up with. And so we're sensitive to that, and we're keeping an eye on that so that we can really align our research with those areas that are emerging, and hopefully so that we can enable those to come into fruition for the benefit of the American public. And so as we stand up new projects, you know, we'll leverage our experience with UAS and the NAS project, but we'll do it into new areas, whether it's autonomy or other areas of research that will really enable a lot of these use cases and bring about some pretty exciting new markets for the country.
Every day, new use case scenarios and research opportunities arise based around the hard work accomplished by this incredible workforce. Only time will tell how these new technologies and innovations will shape our world. But however the outcome, this team can be proud. Their hard work and efforts have opened doors to radical changes in aircraft design and efficiency for future generations.
Our Perseverance rover takes up residence on Mars, the space station's next commercial resupply mission, and a new date for a commercial crew test flight. A few of the stories to tell you about this week at NASA.
The navigation has confirmed that the parachute has deployed, and we are seeing significant deceleration.
On February 18th, our Mars 2020 Perseverance rover mission safely touched down on Mars.
Touchdown confirmed. Perseverance safely on the surface of Mars, ready to begin seeking the sands of past life.
The rover landed in Jezero Crater, a region targeted for the excellent opportunity it presents to accomplish the rover's primary goal of finding signs of past microbial life. Within minutes, the rover's first images from Mars reached Earth, confirming Perseverance was A-OK. And even more images followed, including amazing views of the rover's descent captured by our Mars Reconnaissance Orbiter, and stunning views from onboard the lander showing how descent appeared from the rover's point of view.
You have to somehow believe that you can do it, or else you'd never try to put a car on the surface of Mars, right? It's crazy. But there really is no good way to describe that moment when it's over and you hear those words, touchdown confirmed.
This is the most advanced NASA rover to make the nearly 300 million mile trip to Mars. It's loaded with groundbreaking technology to help pave the way for future human exploration of the red planet. This includes the ability to collect and leave cached samples of Martian rock and regolith that a future mission being planned by NASA and the European Space Agency could retrieve and bring back to Earth for study.
This mission is amazing on its own. Science, technology, and caching samples to bring back to Earth. But it's also part of our bigger exploration plans, right? Which involve preparing for eventual human missions to Mars.
While Perseverance works to characterize the region's geology and past climate, there are also plans for the Ingenuity experimental helicopter to make the first controlled flight on another planet. Having a flying robotic explorer could be a huge benefit for a human mission on Mars.
Being able to fly will enable us to get to places that we cannot get to with rovers and astronauts, like sites of steep cliffs, deep inside crevices, areas of high scientific interest. It will be game-changing.
Perseverance will undergo several weeks of testing before it begins its 2-year science investigation of Mars.
And we have liftoff.
The February 20th liftoff of Northrop Grumman's Antares rocket and Cygnus spacecraft from our Wallops flight facility marked the start of the company's 15th resupply mission to the International Space Station for NASA. The Cygnus, named after late NASA mathematician Katherine Johnson, is loaded with about 8,000 pounds of scientific research, crew supplies, and hardware for the station crew. An uncrewed Russian Progress supply ship arrived at the space station early Wednesday after launching from Kazakhstan on February 14th with just over a ton of nitrogen, water, and propellant. The Progress will be used to detach a Russian docking module later this year to prepare for the arrival of a new multi-purpose laboratory module. NASA and Boeing are now targeting no earlier than Friday, April 2nd for the launch of Orbital Flight Test 2, or OFT-2, the company's second uncrewed flight test of the CST-100 Starliner spacecraft to the International Space Station. OFT-2 is an end-to-end test to prove the Starliner system is ready to begin flying astronauts to and from the space station as part of NASA's Commercial Crew program. A lightweight robotic crane first designed, built, and tested at our Langley Research Center more than a decade ago is being upgraded with a suite of quick interchange tools, giving it Swiss Army knife-like capabilities that could prove quite useful on future missions to the moon. It can be used as a hoist or forklift to lift payloads weighing as much as an elephant, or for jobs requiring a bit more dexterity, such as scooping regolith or welding. The technology is also scalable to fit any size lander, vehicle, or surface application. That's what's up this week at NASA. For more on these and other stories, follow us on the web at nasa.gov/TWAN.
Ernie Cato with this week's #1 #1 song, not necessarily my #1 relative. With that comment, I guess I better be packing my bags. Here's Ricky with a song that's quickly taken over the #1 spot. He must have insulted his mother-in-law, too.
I'm a traveling man, made a lot of stops all over the world.
Before a joint session of Congress today, President Kennedy gave this country a remarkable challenge.
I believe that this nation should commit itself to achieving the goal before this decade is out of landing a man on the moon and returning him safely to the earth.
Did you hear that?
Are we going to the moon? That's what the president said.
That message by President John F. Kennedy, May 25th, 1961, brings back many memories, but it really hit home for the people of South Mississippi when the government announced 5 months later to the day that it would build a test facility along the banks of the East Pearl River to test those rockets that were going to the moon.
The newspapers throughout the area carried the announcement of the location of the test site. Generally, quiet, settled community. It was a lovely place. I was somewhat familiar with the fact that Honey Island Swamp between the two Pearl Rivers was sort of a no man's land. Also, Devil's Swamp over to the east of the site here was just in low timberlands. The original policy for acquisition of the test site was the operational area where all of the facilities are constructed contained 13,500 acres. That was bought outright, including the mineral interest. The buffer zone, which was approximately another 120,000+ acres, the original policy was to acquire only a perpetual restrictive easement.
One of the reasons this area was selected, of course, it was a number of reasons. The physical reason for one thing, this marvelous river we had here, and then low population. Where could you find that much acreage and move that smaller amount of people?
The project was under overall management of the Marshall Space Flight Center in Huntsville, Alabama. And the people up there were really excited about the selection of this Pearl River area for the test site. After all, it was just a short distance down the Pearl River and across the inland waterways over to the Michoud Assembly Facility in New Orleans, and out the mouth of the Pearl and around the tip of Florida to Cape Canaveral, where you would launch the rockets. But even though the area was sparsely populated, NASA did have to move 5 communities to make way for the construction of the facility. They were Westonia, Santa Rosa, Napoleon, Gainesville, and Logtown.
The Gainesville community was a unique community. The Lovelace grocery store, Mrs. Louise Lovelace, who operated the store with her husband, was sort of a focal point in the community. Around the corner from the grocery store, there was a lady, and I don't remember her first name, but she was referred to as Aunt Blue. Her name was Aunt Blue Davis. When we acquired her home, as a lot of the others did, she didn't have it demolished, but she reserved the right to remove it. And she had a house mover. As I recall, his name was Daley Dronette from the Gulfport area, who loaded that house and took it up around the Nicholson area. Aunt Blue Davis never left it. She sat on the back porch in a rocking chair and went down the highway with that house. And I can still see that lady today, and I think she had maybe a niece, I believe Mrs. Freeman Davis, that rode with her as that house went down the highway up Old 43 to the Nicholson area.
A lot of us look on Senator Stennis as more of a statesman than a politician. He told us that if any of you have any trouble dealing with the Corps of Engineers on doing the eminent domain, you call me and I'll see what I can do. And he did help people who called him. It was a daytime meeting, and the way they handled the questions and answers, they had couriers, and I was one of them. People, if they had a question they wanted to ask, they had to write out the question, and then we would take it up to the podium. I don't know who the lady was. I took her question up, and her question was, why do we have to go to the moon? Senator Stennis answered that question in this way. He said, we have to go to the moon for international prestige.
Senator Stennis had another quote that day that became rather famous. He said, "There's always the thorn before the rose." The thorn being eminent domain, the rose being the opportunity that those people had to play a major role in America's prestigious space program.
I was highly elated, very proud of America. I felt that, I'll tell you why I felt that way. I felt that we were part of it. Since we had given up our land and moved and everything, that we were actually part of going to the moon.
We had the challenge of building a very large rocket test facility. It was a swamp here. There wasn't anything here except the Rushan house, which is behind us. The challenge was significant. In today's dollars, that would amount to $1 billion facility. We had to build it from scratch, and when it was completed, it was going to test the awesome Saturn V rockets that were going to take men to the moon.
Jerry has been associated with Stennis Space Center for almost his entire existence. In the Apollo days, we used to see Jerry once a week as he flew down from Washington, where he was responsible for overseeing the construction of the Mississippi Test Facility in those days.
There were schedule problems. The S2 stand was a critical facility, was determined to be the most critical facility in achieving the Apollo mission. And therefore, there were lots of pressure to complete the construction on schedule.
We did not know at the time what all it took and what all it was going to take to really construct and to put together the type of facility that's required to support the space program. But as time passed and as we continued to work and continued to lay out the boundaries and the foundations for construction, the roads began to appear, power lines began to appear, buildings began to appear, then it started coming together.
We had to clear an awful lot of land. We had to put in an awful lot of facilities, many of which were very highly technical facilities, very high pressure systems and liquid oxygen and hydrogen that was going to be required, and the test stands over to a little further to the east of it. Our responsibilities for us in the early days was to construct the facilities, get it to a point to where it could be operable. And all during those days, it took about 3 years for us to finish and finalize all the facilities that's now known as the Stennis Space Center.
The construction activation phase brought out the very best of everyone. It was characterized by superb leadership. Dr. Werner von Braun, director of the Marshall Center, appointed a Navy captain, Bill Fortune, as first project manager. Captain Fortune was highly respected by his employees and especially popular in the communities. The first American flag to fly over this site, symbolizing NASA's presence here, was raised by Captain Fortune and Dr. von Braun. That event brought on a reminder of Dr. von Braun's early involvement with this facility. He was not merely an overseer or a visitor, he was a participant. In fact, he often referred to this South Mississippi site as his baby.
You know, he was a fine gentleman and a true professional and really knew how to get everybody's consensus to his ideas and how to move them forward. And Carl Heimberg and Bernie Tessman, his deputy, were in charge of his test laboratory up there in Huntsville. And we worked very closely with them developing the requirements for this facility. Carl was a hard driver, but a very, very tough and fair man, very focused on where he wanted things to go. Tessman had a good personality, had a good sense of humor, and he filled in some of the people gaps, but both of them were fun to work with. And of course we had Henry Order, and a gentleman named Gordon Artley was significant in bringing together the focus to get this place activated with 3,000 or 4,000 new employees coming on, plus 3,000 contractors, and get things done. Ken Riggs was outstanding in bringing together the test experience and requirement to our planning team.
Some people think I'm kidding when I tell them that during the month of July we had to wear a jacket, a denim jacket or some other form of jacket that was thick enough to prevent the mosquitoes from penetrating your clothing.
Rainy season, there was a lot of mud, and so that slowed things down. When we excavated for the test foundations, there were holes 40 feet deep, and so you got down to where water wanted to just bubble in the bottom, and we had to put in more deeper and deeper wells so that we could pull the water table down. Congestion, I mean, there was work going on everywhere here, and just lots of activities happening simultaneously. We had that snow, about a 10-inch snow down here in Mississippi.
We did have some unusual problems during construction, and sometimes resorted to resourceful methods to solve them, even to the point of using mules to do what modern machines couldn't accomplish. One of the photographs taken of that activity became world famous.
That picture was real famous. That picture went around from coast to coast, they told me. My boss asked me, say, "Do you know how to plow a mule?" I told him, "Yes, I do." It was kind of wet, soggy. Mule was kind of boggy, but we made it.
In the spring of 1965, Jackson Balch was appointed manager of what was soon to be officially named the Mississippi Test Facility, and with him he brought other leadership from Huntsville to fulfill the mission.
Jack Balch asked me if I would come down and be a project manager on the S2 program, and it just looked like an opportunity I couldn't turn down. Working for Jack was a real learning experience too.
Jack Balch was a unique character, a lovable man in many ways, a tough taskmaster in many ways. He certainly would be an understatement on my part to say that he left an indelible mark here.
Again, he was a hard-nosed individual, but you like Jack automatically if you like competence, because he was a very competent individual.
It was just the people more than anything. People tend to remember the hardware, but it's really the people that made the hardware work.
There was considerable excitement in the air in those days with the anticipation of building and testing the vehicles that would get us to the moon. People were being trained. We were learning how to handle large volumes of hydrogen. It was an exciting time for sure.
Everything was out of the ground facility-wise. We were putting in cables, terminating cables. S2 was getting ready to finish out at CO Beach and be shipped in here, and it was just a real beehive of activity getting ready for the first test. And as you remember, the S2 was probably the most controversial of the Saturn V stages, in that it was liquid hydrogen, it had a common bulkhead, and expected a lot of problems.
Well, it was pretty difficult because we were running round the clock, no days off. You know, it wasn't anything like a weekend. You just kept right on going. Coming up to the test, everybody was pretty tired. but I can remember the feeling that they certainly wanted to get it off, and there wasn't any question about we were going to do it.
It took some 25 hours after the blockhouse was sealed to get that test off. Lots of bugs in the system, things that had to be worked out, but ultimately we weren't successful, and the test was a major accomplishment, a major milestone.
And at that time they had the countdown of the test firings on the operational intercom site-wide, and everybody would listen to the countdown, and as it got to the last few seconds, you would, if you could, go outside so that you can see the smoke and hear it.
The rocket testing started in 1966, and every rocket that was tested here performed its mission flawlessly in flight in taking our men to the moon.
Like all Americans, I remember it well. Being at home with my family, keeping my kids up all night so that they could see this historical moment, and then finally seeing Neil Armstrong step on the moon and having a sense of pride that I had some little small part of that. All the people here at MTF in those days, as we call it, the Mississippi Test Facility, felt an enormous amount of pride in the fact that we had a major role in making that happen.
The people at MTF and their neighbors didn't have long to enjoy the laurels of that fantastic mission. Even as the nation was celebrating that first lunar landing, an ill wind was brewing in the Gulf of Mexico that would change the destinies of thousands of people and the directions of the Mississippi Test Facility.
Camille came along, devastated the coast, killed several of our employees, damaged our facilities, and it was a time when our people came together. Hurricane Camille focused the attention of the country on this area, and NASA bowed its back and said, we want to help in this area, and NASA provided substantial help to the area, not only by continuing the operations here, but in many other ways in the local community.
The MTF management team, under the leadership of Jackson Balch, was engaged in a diligent search for new roles and missions even before the tragedy of Camille.
When we started hearing about the Mississippi Test Facility and the fact that the rocket testing was phasing down here, we were asked to think of things that could be done here. Assistant Center Director at Johnson Space Center, Bob Powlin, was asked to define an activity to be implemented here. And he defined this laboratory.
NASA established the Earth Resources Laboratory at MTF, and a number of federal and state agencies were also invited to utilize the facilities.
A plan was set out to convert the Mississippi Test Facility from a single agency NASA, single mission propulsion testing to a multi-agency, multi-mission federal laboratory. A great shot in the arm, however, was in the 1970 time frame. The committee met in early '71. NASA decided to put the testing for the Space Shuttle main engine here.
During his first term as administrator of NASA, Dr. Jim Fletcher decided that the installation should be renamed and its reporting changed. In June of 1974, MTF became the National Space Technology Laboratories.
That was in recognition of some of the application and technology type projects that this facility became involved in after the Apollo era. I was asked if I was interested in coming down. There was a vacancy. Jack Balch has retired, and Henry Otter, his deputy, was acting in his capacity, and NASA asked me if I'd come down and lead this facility, and I said yes.
And he served a distinguished period of time, 12 years. And really, his major contribution, in my view, was that he took this installation from the fringes of involvement with NASA programs to the center line. And during Jerry's tenure, we had major improvements in our involvement with NASA, our relationships with other centers, our involvements in the programs. New programs were assigned to Stennis, new facilities were built. Jerry's knowledge of NASA, his leadership ability, and his knowledge of how NASA headquarters and the Congress work sure did pay off for all of us here at Stennis Space Center.
That was a great day. It was a recognition by NASA that this installation is part of the family of NASA. It was a day that we honored a great Mississippian and a great American. He had a great deal to do with this place. He was like the father of this installation. He worried and worked for its advancement and its progress ever since it was established. And he, in addition, had not only supported the programs that were here in Mississippi, but he supported the entire National Space Program. He felt it is the right program for the agency. He supported Kennedy when he announced his intention to go to the moon. And therefore, it was a great, good feeling, not only for me, but all the employees of this installation.
We feel that Senator John Stennis got the test site for us, and I think we owe him a great debt of gratitude for his effort in that.
John C. Stennis, I call Uncle John, because this was his second home. He just loved to be out here.
I felt like that when they changed it to Stennis Space Center, it was a long time coming for John Stennis, because he deserved everything. Every recognition has been given him.
Through the efforts of technology and through everybody working together as a team, Stennis, has grown even more, and the shuttle program seems to be moving forward or moving ahead with tremendous strides.
The whole thing comes to Roy Estes. Ever since I met Roy Estes, he has always been the guy who could exude confidence and everything's going to be all right, hang in there.
Well, the team at Stennis Space Center have made substantial successes in the last few years. And largely, I think because of the foundations that were laid by those who came before us, and we have been successful in carrying through those with tremendous amount of support from NASA headquarters, starting with Admiral Truly, J.R. Thompson, Dr. Lenore. All have been very strong supporters of the emerging Stennis Space Center. Everybody, from the people who gave up their land to the technicians, engineers, business people, everybody who's had a part of this has made, in my view, a major contribution to the country's success in space. And the people of South Mississippi, South Louisiana that work here have been the secret to that success.
Carol Scott, and I help astronauts get to the International Space Station. And this is Ask NASA.
Liftoff of the Falcon 9 and Crew Dragon. Go NASA, go SpaceX, Godspeed, Spot and Doug.
So Launch America is all about utilizing our commercial companies to be able to launch astronauts to the International Space Station from America's soil on American-made rockets. So this is a unique partnership that the government has formed with the commercial partners. We are leading and guiding them. We have provided SpaceX and Boeing, we've given them some requirements, and including where they've got to meet design and construction standards. Oh, there's tons and tons and tons of innovation going on. And the way that we're doing this allows the partners to be able to innovate even more. They're able to get that performance from some new technologies that they have on board. All those degrees of freedom are part of this commercial partnership, and it's awesome. So this is a historic launch because this is the first time that we've ever launched utilizing the commercial partners. We're buying a seat for astronauts. And so this is new. Just like if you were trying to buy a seat on an airline, this is going to allow for a lot more access to space from other commercial partners, from other maybe potential tourism, and then in future generations, it'll be available to a lot more folks, just like you and I.
My name is Benjamin, and I am going to be a 5th grader next year. So what can my generation expect for Launch America?
So Ben, back in the 1920s and 1930s, the government transferred how we move mail. And that's how we got the airline industry started. And so this will be a very similar path with commercial space. You're going to see a huge economic boom by NASA being able to transfer all this information to the commercial partners and letting them innovate to meet their business needs. And eventually they're going to take additional passengers, just like the airlines did back then, additional passengers, and you will be able to go to space. You are going to see human launches happening quite a bit here on the Space Coast. We want to rotate every 6 months, having astronauts crews go up to the International Space Station. NASA still has a team of astronauts, but we have the capability to have commercial astronauts on board. So if, for instance, if you looked at Boeing, Boeing has Chris Ferguson, who was the last shuttle commander. He is one of their astronauts who will be taking a crew up in their CST-100 to the space station. So we can accommodate both NASA astronauts and commercial astronauts. And I believe you'll see a growing field of commercial astronauts very soon. Future missions are going to be revolutionized by this process here. We're going to be able to get more people up on space station. We're going to get it to full capacity of personnel. And this will allow us to get more research done on the space station, getting more science, which will also help us here on Earth. With industry helping us get our astronauts to the International Space Station, NASA can focus on getting our first woman and the next man to the moon. We are absolutely using the commercial partners to be able to help us reach the moon. So they're going to be helping us with our human lander systems and being able to take cargo and supplies to the moon surface, and that'll be ready for our crews to be able to use. So the hardest part of going to space, there's several different sections of it. If you work ground systems, it's all about launching, right? But then you've got to be able to go through all the dynamic environments and being able to actually get into orbit. And then actually you got to go make it to your destination. So you've got to have all your guidance systems ready to take you where you want to go. And then you got to live in space, right? But then you've got to be able to return them safely, when they're ready to come back from being on station.
Do you have a question for NASA? Send your questions to our experts on Twitter using hashtag AskNASA.
Wherever, however, whenever. We're here, there. We're everywhere. NASA Space Communications and Navigation. Exploration enabled.
It was just 4 years after the Soviet Union had launched Sputnik.
Today, a new moon is in the sky, a 23-inch metal sphere placed in orbit by a Russian rocket.
And the space race was ramping up into full gear. The first weather satellite, launched on April 1st, 1960, Tyros 1, enabled us to see weather, at least in the form of cloud cover, across the globe. For the first time, we could see today's weather from space, which provided clues about what tomorrow had in store. With each passing year, we gained more confidence in our weather forecasts, compulsively checking out the hourly forecast before heading out the door, or scanning weather radar in real time, or eyeing the 10-day outlook for next weekend's plans. Our ability to predict the weather, though still imperfect, would astound our recent ancestors. But not that long ago, weather forecasts were much, much murkier, and recent improvements have made revolutionary contributions to not just picnics and daily commutes, but farming, worldwide economics, construction projects, military strategy, and travel by air and sea. We talked to pioneers in the field who in some cases have lived the lion's share of the history of modern weather forecasting. Out of that, we want to share 5 things, mostly from the U.S. satellite era, that changed forecasting forever. But first, we'll start a little further back into the past.
Throughout the history of what is now the National Weather Service, threats to life has been one of the main drivers for us to even exist. The initial organization that started weather services in the United States was the Signal Corps, which took on the responsibilities to observe weather and be able to provide indications of what could happen that afternoon or the next day.
After the Civil War, the Great Lakes were a main highway for commerce, and ships frequently sank in surprise storms.
Telegraph lines made it possible to get weather information in real time that could all be brought together to provide indications of squalls passing over the lakes. And so that's the creation of the Signal Corps. Then you move forward in time. In 1888, for example, there were 2 major blizzards that affected the United States.
These blizzards were barely forecast, and hundreds of people lost their lives.
There was a general push to get the weather services out of the military Signal Corps into a civilian agency, and that was probably the last straw for many of those who really wanted this to happen, and it became much more emphatic.
Then the weather disasters of the 1900s, like the surprise Long Island Express hurricane in 1938 and a major tornado outbreak in 1974, spurred interest in new technologies like Doppler radar that could give a local or regional view of developing weather. But it was really the view from on high that brought the world's weather forecasts together. Not many people know that during John F. Kennedy's famous speech to Congress in 1961, he not only set this audacious goal.
First, I believe that this nation should commit itself to achieving the goal, before this decade is out, of landing a man on the moon and returning him safely to the Earth.
He also called out for the development of a nuclear rocket and a worldwide system of communications satellites, and
fourth, an additional $75 million, of which $53 million is for the Weather Bureau, will help give us at the earliest possible time a satellite system for worldwide weather observation.
Tyros 1 and 2 had already launched before the Kennedy speech, but a long series of Tyros satellites followed after, which were then complemented by the Nimbus program, a set of satellites designed not just to take pictures, but to actually measure aspects of the atmosphere from hundreds of miles away, including temperature, wind speed, and water vapor. Scientific progress is often slow, building incrementally. But sometimes science makes giant leaps, literally overnight. For the field of weather forecasting, this happened one night in 1969, just 3 months before the first humans landed on the moon. It was the night the team behind the Nimbus 3 satellite received their first global set of data.
We stayed up all night and plotted these data on a map, hand plotted them. We got the computer, just reams of paper with numbers on them, latitude, longitude, temperature values, altitude and things. It was pretty exciting because it looked very real, just like a real weather map. But this just came from the satellite, nothing else, just the satellite data.
When morning came, they brought their weather map to the Director of Operations of the National Meteorological Center.
He says, "Oh my God, we've been taking flack from the airlines this morning because we misforecast where the jet stream was going to be, and our flights to Asia we're not making their destination because of strong headwinds and so on that we didn't forecast." And he says, "And your satellite data shows right where it is."
The Tyros and Nimbus satellites and other low-orbit satellites that followed circle round the Earth, getting different views all the time. But now let's talk about the view from 10 times higher up.
The geostationary program has primarily been a visual imagery program. It's basically flying above the equator at the same rate as the Earth spins, so to a person on the Earth it appears that it's stationary. And what that allows you to do is see the Earth from the same vantage points continuously. So you can basically take movies, so you can update the picture every 30 seconds if you want. When you loop those, you get a sense of the motion of the weather.
We forget the days where the TV folks who were talking about a storm being out in the Atlantic couldn't even show where it was, just that the Hurricane Center is tracking it. Papers have been written about how the geostationary satellite was probably the most important observing system with its ground processing in the history of advancing the Hurricane Center, because it gave them the situational awareness of where that storm was, where it was going, and the intensity changes as it was moving in real time. It was just an amazing, eye-opening experience for the Hurricane Center.
So, geostationary satellites give us, literally, the big picture. But from a data standpoint, it's usually been the low-orbit satellites, usually in a polar orbit, that are the workhorses of the weather fleet.
The polar orbiting satellites complement the geostationary, basically flying a little over 500 miles up. And when you're at that altitude, you can sense what's in the atmosphere to a lot higher resolution. And for weather forecasting, you really want to understand the state of the atmosphere, primarily temperature and water, vapor, and winds. Twice a day, each satellite is giving a really detailed measurement of the atmosphere and its state, which is the beginning then to understand what is the statement of the global atmosphere to then project it forward to produce a weather forecast.
The early Nimbus satellites began our legacy of low-orbit data collection, but one of the biggest leaps came from our ability to measure literally thousands of different frequencies of energy, representing an all-weather profile of the atmosphere. For NASA Goddard Space Flight Center's Ed Kim, that all-weather view is never far from his mind.
I have a vested interest in helping improve weather forecasts. The hobby of flying and the work of improving weather sensors is a nice combination. They really go hand in hand. When you're flying around and looking at clouds or looking at weather patterns as you're flying in an airplane, it's hard not to think about what a microwave sensor would see when it's trying to look through that cloud over there to the right. So everybody's probably familiar with radio transmissions. You have a transmitter, you have a receiver. Maybe when you were kids you played with walkie-talkies, or you listen to the radio in your car. There's a transmitter somewhere and the receiver's in your car. The microwave sounders are just the same thing, just different radio frequencies. So you might ask, well, what is the receiver receiving? It's actually receiving natural signals that are emitted by the gases in the atmosphere itself. All natural objects, everything emits very tiny amount of microwave energy. And those microwave frequencies happen to allow you to detect the condition of the atmosphere. And so then you can construct the vertical temperature, we call it a profile, a vertical temperature structure of the atmosphere. The primary reason that you have both the microwave and the infrared is that the microwave sensors in general, for the most part, can see through clouds. Just the fact that you could see through the clouds and still figure out the structure of the atmosphere was a gigantic leap forward. Combine the microwave data and the infrared data, provide that really critical vertical structure information of the atmosphere to the weather forecasters. Essentially the most critical information they need for weather forecasts.
So we have a non-stop visual recon of the planet from geostationary satellites and highly detailed atmospheric measurements from polar orbiters. But all that data coming down wouldn't mean much without the quantum leaps in computing power we've seen over this time period, and the massive amounts of work that have gone into creating computer models of weather and our atmosphere. One of the pioneers in this field is Eugenia Kalnay, who, after escaping a brutal crackdown on academia in Argentina, became the first woman to graduate from MIT in meteorology and has possibly the most often cited paper in all of the earth sciences. One of her major fields of study has been the ensemble forecast, basically comparing bits of forecast model information against each other to figure out what's working and what's not.
This method allows you to determine whether each observation is good or bad, if it helps the forecast or it makes it worse. And I realized that we could do that with every observation and determine whether it was beneficial or detrimental. We could take away the detrimental observations and only use the beneficial ones. And that has improved the forecast quite a lot, substantially. Not just a little bit that you cannot see, but for 8 days the forecast is better. So that I feel very happy about that result.
Before the ensemble, she says, the National Weather Service would calculate a forecast for 15 days, but only show 3 days to the public. But in the 1980s, we made a major leap.
That was the first time that the human forecasters there make a forecast for 5 days, and because they saw that all the ensemble forecasts were similar. The TV meteorologists immediately, the most advanced of them, immediately realized that they could give forecast much longer than 3 days.
So now we have the data, and we have the computers and the models to run on them. But that still doesn't do us any good if we can't get the data down from the satellites, processed, and then out to the people who need it.
We're sitting here at the NSOF building. It's really the operations center for all of our NOAA satellites. So behind me, you can see the floor where not only do we fly the geostationary satellites, the polar orbiting satellites, including JPSS-1, which is now called NOAA 20. The primary purpose of this building then is to fly the satellites and then take the data from those satellites and process it and be able to put out the products for the nation. The data that flows from all of the satellites produces a lot of the products that are used in the weather forecasting that everybody sort of uses every day and may not really understand where it's coming from, but this is the heart and soul of what the nation gets for weather forecasting. So the nice thing about working in this business is we know it's helping people all over the world, and all the countries of the world collaborate very well together in sharing this data because it's all of mutual benefit.
But getting those forecasts out is still not the end of the line. In emergency weather situations, the right people have to get the right information to make critical decisions.
Well, one of the new areas that the Weather Service is fully engaged in is the idea that making a forecast and a warning is not good enough. And there's a whole range of decision makers. There's organized decision makers, government agencies at the federal, state, and local levels all work together to save lives and property. And then you got individuals. Everybody with a cell phone now is a decision maker. They can download all this stuff and decide whether they're going to evacuate or not, right? So we're into human factors now. We're into social science. So this combination of physical and social science is really a big deal for us in how we meet the needs of the emergency management community. If we all want to get down to societal benefits, this is what we've got to do. We've embarked on this over the last 6, 7, 8 years, and it's starting to work. The part of the mission to protect life and property is really the driver, what brings people to work every day, and we certainly are dedicated to that mission.
Good at the vehicle. Good. 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 Good spark. Light showing green.
So Masson has been a part of the Flight Opportunities Program since its inception. We were one of its first customers.
Copy that in progress.
There's a lot of benefits. One, we get to fly our rocket. We're always testing our own hardware. Two, we get to interface with like-minded individuals who have, at the end of the day, the same goals, which is to go to the moon, go to Mars, go to these other bodies. And so we get to interact with them, we get to understand how they do things. There's a transfer of knowledge both ways, and we build these strategic partnerships that are only going to facilitate these broader and deeper areas of exploration that we ultimately want to do.
Confirming that test site's up, vehicle payload are good, and we're ready to start the checklist.
So Masson is the flight provider of these flights.
Ground crew in position for a quick check.
We fly the vehicle through a trajectory that mimics that target destination, whether it's the moon or Mars, and gives them the fidelity of data that, again, they're not going to get with conventional means, whether it's a balloon, a helicopter, or an airplane.
Here we go. Masson ops to all, 6-second count to engine start.
So the Safe, Precise Landing Integrated Capabilities Evolution Project, or SPLICE, is developing a family of sensors that are required to land safely and precisely on the moon, Mars, and any other destination. The testing on rockets gets us even closer to that lunar landing-like test, where we can get as close as we can to that actual lunar landing here on Earth, allowing us to have additional confidence that our systems are going to work when we actually go to the moon.
Terrain relative navigation is a form of navigation in which you are able to determine your state of the vehicle relative to the terrain itself. So we're able to identify features pre-launch based upon satellite maps, load them onto the vehicle, and then we fly a camera on board which takes images. We compare those images to the maps that we've loaded with the pre-identified features, and from that we identify the features in the images captured, map them to the satellite maps, and then from that we can tell relative where we are to the terrain, so we can get altitude and whatnot relative to the terrain that we're seeing. So I think it's going to be critical for future flights. Most of the future missions that we're looking at are going to be pretty much autonomous, try to keep as much human interaction to a minimum. So in order to be able to navigate at the moon where we don't have GPS and other very accurate state information, terrain relative navigation is kind of your next best. The vision navigation portion of it is kind of the next best thing that we can go with. So I think it's going to serve a critical part in the upcoming return to the moon.
Also, as we move towards a sustained presence on other bodies like the moon, we'll need these precision landing capabilities in order to deliver cargo nearby where we have our crewed outposts.
Wherever, however, whenever. We're here, there. We're everywhere. NASA Space Communications and Navigation. Exploration enabled.
I believe that this nation should commit itself to achieving the goal before this decade is out of landing a man on the moon and returning him safely to the earth.
Godspeed, John Glenn. All systems are go. Roger, 0G, and I feel fine.
We choose to go to the moon in this decade and do the other thing, not because they are easy, but because they are hard.
Tranquility Base here. The Eagle has landed. That's one small step for man, one giant leap for mankind. It came in peace for all mankind.
The focus of the entire project, landing successfully on Mars.
That will be put in an orbit and provide living space for astronauts and particularly astronaut sciences.
Contact. Soyuz and Apollo are shaking hands now. America's first space shuttle. And the shuttle has cleared the tower.
Nothing as beautiful as Chandra sailing off on its way to work.
We've had an excellent week on Mars.
Houston, Atlantis, we have capture.
After World War II in 1946, a group of 118 scientists from Peenemünde, Germany, came to America under Operation Paperclip to continue their work on rocket research. They were headed by Dr. Werner von Braun at White Sands Proving Grounds, New Mexico. Eventually, over 3,500 German scientists are brought to the United States. But at the same time, 6,000 German scientists, or specialists as they were called, are forcibly taken to Russia.
12 апреля 1961 года в Советском Союзе.
One of these groups is headed by Helmut Gertrub.
Damals auf dem Schießplatz Kummersdorf südlich von Berlin tätig. Und da waren 2 Schießbahnen und wir hatten eine kleine Versuchsanstalt zwischen den beiden Schießbahnen. Wir brauchten einfach mehr Platz. Zu derselben Zeit kam die Luftwaffe an und bezeugte auch ein gewisses Interesse an unseren Raketentriebwerken. Da suchten wir halt eine neue Lage. Und in Peenemünde hat mein Großvater mal früher Enten geschossen und meine Mutter sagte mir, fahr doch mal rauf und zieh dir das an. Wir brauchten einen Platz an der Ostsee, wo man die hinterpommersche Küste lang schießen konnte und da Vermessungsbasen aufbauen konnten. Und ich kann nur sagen, es war Liebe auf den ersten Blick. Die Sache war ein bisschen so wie in der Frühzeit der Fliegerei. Man wusste, dass hier eine neue Technik im Kommen war, die unendliche Möglichkeiten hatte, sowohl auf dem militärischen Gebiet als auch auf dem Gebiet des Verkehrs, also ein Transportmittel. Und der Plan hinter Peenemünde war so ähnlich wie hinter der Deutschen Versuchsanstalt für Luftfahrt. Es war halt eine Stelle nötig, die diese neue Technologie entwickelt. Ich glaube, es wäre lächerlich zu sagen, dass ich alle Entscheidungen genauso machen würde, wenn ich sie nochmal zu machen hätte. Jeder Mensch lernt von seinen Fehlern. Ich glaube, wenn wir aufhören, von unseren Fehlern zu lernen, dann sind wir am Ende unseres Lebens, zumindest unseres aktiven Lebens.
Their choice for construction site became Peenemünde, the fishing village on the Baltic coast. In 1936, had brought together most rocket specialists in this place. Now they could start their work in secret workshops. Those first specimens came back by parachute, to be carefully examined afterwards.
Success, everything failed. When we launched something, it failed, dropped down, and we didn't know the reasons. At that time, we didn't have any telemetering in it. No instruments to describe it, gave us status, what happened. We had to think about what could have happened. And the more people were, the more ideas what happened showed up. And it cost a lot of money. Peenemünde was one of the most expensive experimental stations in the world. We spent already to 1942 more than 300 million marks, gold marks, in that enterprise. And I got told an hour before this launching was dated on the 3rd of October 1940, if you don't succeed today, we have to cancel Peenemünde and get the people all drafted in the army. Now it was a question to live or to die. And we succeeded.
I was watching through a pair of binoculars, and I just kept my fingers crossed that I wouldn't all of a sudden see a fireball in the sky, and all I can see it is wind and wind and wind. It went and finally made it. This day will be remembered as the day when spaceflight was born. So there was even no reference at all about to any weapons development at the time. We all had the feeling that the barrier to outer space had been built.
In 1943, the V2 was more or less operational, although occasionally one of them got off its course. So one of them crashed in neutral Sweden, and another came down in Poland. That same night, the Polish resistance movement informed the British, who took the wreck to the Allied headquarters in London. From these pieces found in Sweden and Poland, the Allies reconstructed a complete V2. And it was only then that they realized what kind of weapon they were facing, and that they had no remedy whatever against it. In the summer of 1943, an RAF bomber photographed the fishing village of Peenemünde during a reconnaissance flight. In the intelligence department of the RAF in London, this picture was studied with great excitement on June 29, a dangerous trip far into Germany. One aircraft was shot down by the Germans. 200 British got killed. But on that early morning of August 18th, at 17 minutes past midnight, the first of about 1,500 tons highly explosive bombs fell on the V2. followed by thousands of other bombs, which killed 735 Germans and destroyed Peenemünde entirely. But the most eminent German rocket scientists escaped this destruction, which they had been fearing for a long time. After the air raid, the Germans were forced to move their production to Nordhausen, now situated in the German Democratic Republic. Their research went on in underground workshops.
The factory called Mittelwerk in the Hertz Mountains consisted of 2 large 1-mile-long tunnels connected by 62 smaller tunnels. Over 32,000 V1 buzz bombs and up to 900 V2s per month are produced here. On April 11, 1945, the 3rd U.S. Army Tank Division rattles toward Nordhausen.
The Allies advanced from the west to Nordhausen and Peenemünde in search of the brilliant minds behind the V2. In a battle with the Red Army, which claimed an important part of Germany.
Our intelligence sources had told us of the role Dr. von Braun and his Army Superior, General Dornberger, had played in the development of the V2 program. I believe that the brains of these men, if we could find them, must be put to work on behalf of the United States. After all, they were the world's only experienced missile team. I later cabled Washington and requested authorities to search for and bring 300 of the leading German rocket scientists to the United States. I found I was championing a very unpopular idea. So before long, I was in the Pentagon pleading the case in person. I finally succeeded in gaining approval, not for the 300 German scientists which I had requested, but for only 100. This was the beginning of Operation Paperclip. At the same time, I ordered my assistant, Colonel James P. Hamill, then a major, to get to Nordhausen as fast as he could and to move out enough V2 parts to assemble 100 missiles before the Russians took the area over. Somehow Hamill and his men found enough boxcars and quickly loaded them with the V2 component parts. When I returned to Germany, Hamill and his men had managed to get these boxcars and their precious cargo into the American zone 2 days before the Red Army moved in. In terms of the biggest prize, the brains who had built the V2, we had previously received bad news. Our agents had gotten into Peenemünde, found the place stripped and in ruins, and the Red Army in control. There was no sign whatsoever of Dornberger, von Braun, and the other scientists. Terribly disappointed, we presumed that they were all eastward bound. We intensified Operation Paperclip. In some unoccupied areas, we had to parachute our specially trained agents in on the chance that some of them might still be found. In other places, we set up key roadblocks. We found some important scientists, but it looked like the ones we really wanted had slipped through our net. What we didn't know was that as the Russian army approached Peenemünde, von Braun and their colleagues had rounded up a few battered trucks. They loaded these trucks with plans, blueprints, and choice equipment. They headed for a retreat in the mountains of southern Germany, where they hoped to continue their work.
Mr. von Braun, I would like to ask you, what happened after this?
What actually happened was that the entire team of some 300 men and their families were dispersed throughout southern Germany into small cadres specializing in the various fields. In other words, a powertrain group and an electronic group and so on and so forth. They were located in different parts of southern Germany, and 2 of the people specifically had been in charge of hiding in the Harz Mountains all of the V2 documents and some important hardware so that they could be retrieved if and when we wanted them retrieved. General Dornberger, my brother, 5 others, and myself ended up in a mountain resort hotel on a pass separating Austria and Bavaria. And we stayed there for several days until it became apparent that on one side of this pass, that was in Bavaria, the French had occupied the country. On the other side of the pass, in Austria, the Americans were in charge. So we were sitting on top of a line which separated French troops from American troops. The intent, obviously, was always to get in touch with the Americans rather than anyone else. But we waited until we hoped that Americans would come up there and find us. Not so. One fine day, posters on top of the pass indicated that this was French-occupied territory. And that triggered a decision, obviously, to get out of there and fast, because we didn't want to be overrun by the French. We wanted to make contact with the Americans. So this group of 7, headed by General Dornberger and my brother, decided that contact should be made with the Americans down in the valley, about maybe 4 or 5 kilometers down from the pass. And it was still snow-covered because it was in early May. I spoke the best English and I was the most expendable, and so I was sent down to establish contact with the American troops, and I rode a bicycle down the hill. As I reached this first village down in the valley, an American soldier stopped me. I now know that the man's name was Schweikert. I didn't know it then, and it was never revealed to me. But anyhow, he stopped me and took me to a lieutenant who was just shaving and really too busy to talk to anybody. But after a while, he got out, and I told him very briefly that my brother and a few others were sitting up on top of the mountain hoping to surrender to the American army. And he appeared very reluctant to continue the conversation because he thought that I was a traitor on my own brother. And that didn't impress him at all. It then took him about 10 minutes to establish contact with the CIC headquarters, the intelligence service headquarters, and all of a sudden he came back and offered me cigarettes. The name meant something to them, obviously, and within minutes the whole attitude changed. And they became most cooperative and most helpful and merely tried to find out what can we do, when can we do it, how can we do it. And I said, well, we're sitting up on top of this mountain there, can you get us down? And he said, no, because we don't want to send American troops into French-occupied territory. That'll cause a diplomatic problem, and we'd rather have you come down yourself, and the moment that you cross the line, we will escort you down. And that's exactly what happened the next morning. So we drove in our own German military vehicles down, were escorted by jeeps right and left, and went down to a town called Reutte, which was the headquarters of the local Army intelligence. And there, I must admit, we were received like royalty. The GIs cleared their beds for us, and they cooked breakfast and dinner and whatever we wanted. They were most accommodating and most helpful. And by that time, I guess they had gotten around to the fact that they'd caught a big fish in this transaction.
And they were always looking for the general in uniform, but this general wasn't there. The general was in civilian clothes, and they were surprised that the German general would show up in civilian clothes. I was at the end of the war almost every time. It was 45 April, beginning of April. Whenever Brown had to get something out of Berlin, I don't know what. And he drove to Berlin with the driver, And on his way back, he fell asleep. And the driver did the same. And with two persons sleeping in a car, that had to lead to an accident. And he dropped down from a bridge on a railroad track and broke his arm 6 times. And we had to wrap him in, but he wanted not to go to the French side. And therefore, when the Americans came close to my place where I was, I sent him some people down to pick him up and bring him up to my place, so that when we went in prison of war camp, we should go together.
Did you make the decision to go to the west?
The decision was made before we moved from Bad Sachsa and Gleicherode to the Alps. Hitler had the idea of the Fortress Alps, which was a dream. There was never a Fortress Alps. And at that time, we were already thinking what should happen with our rockets. We were convinced that we were at least 10 years ahead of other nations with our development. That was confirmed later on after the war by all other scientists. And we had something to give. And at that time we were convinced, we, the same as the leading people in Germany, that it wouldn't last long, that the Americans would have a war with Russia.
We made in fabrication in Eastern Germany about 30 V2s out of old parts which were left after the war. And half of this quantity went as whole rockets on their special cars to Russia. The other half went in pieces. That means the 3 or 4 big pieces from which you can construct a rocket. And later on, in shooting these rockets in Russia, the fully one, which were as a whole transported to Russia, were named the German, and the ones which were brought in pieces to Russia were named the Sovietics. And therefore, if in the time when we were on the shooting range in Kapustin Yar, all Russian officers were very happy if more Sovietsky rockets had a good range than the German one.
We were then loaded onto a converted passenger liner, converted to a troop transport, the SS Argentina, and sailed for Manhattan. which was a rough trip in November. You know, the weather is not always very inviting on the Atlantic. We arrived in Manhattan in the middle of the night and were, in a rather hush-hush fashion, bussed to Boston to spend some 4 weeks on an island in Boston Harbor, an island called Fort Strong, which was an old military establishment, abandoned and reactivated only for this purpose. And at Fort Strong, we went through physical exams and more interrogation. I think much of it was a time killing until the bureaucracy in Washington, paperwork, you know, had caught up with us. Early December, we boarded a train for El Paso, Texas, and that was a 3.5-day ride. In immediate post-war time, things weren't exactly all what they are today. So it was a slow and tedious ride, but we finally arrived in El Paso on the Mexican border, and then landed in a small set of barracks in Fort Bliss, a large army range just outside of El Paso, Texas. And then Fort Bliss and White Sands, which is about 50 miles north of El Paso, became our home for the next 4.5 years.
The Germans displayed an unheard of enthusiasm for their new tasks in Fort Bliss, although the adaptation in Texas was difficult. In the meantime, the parts for more than 100 V2s were transferred from Nordhausen to White Sands Fort Bliss. And after 8 months, the first V2 after the war was launched again. This German-American effort, which led to the perfection of the old V2, started in 1946 and lasted to 1952. From this research, a new version originated, which was called the WEC Corporal. The launching of the first Viking rocket next established the reputation of Wernher von Braun and his 118 colleagues in the United States. A year later, von Braun, under the leadership of the American General Bruce Medeiros, was to continue the work.
Well, of course, it came up so gradually because they first went out to White Sands, Fort Bliss, and were kept in very tight control until after the whole of the war was over. And it was not very much known around through the military generally that this was going on, that there was this sort of thing. I had had a hand in getting the first batch of V2s out of the tunnel over there and back to our country. And so I kept up with it. I knew what was going on, but generally throughout the Army, there was not much attention paid to it. And it was 1950, I believe, when they decided to move the whole thing to Huntsville and to reactivate this reservation that was there. And that was the first time that it became general knowledge or began to spread at all. But still at that time, the individuals were not well known. Werner was not a name to the American people yet at that time.
General Bruce Medeiros returned during his life to the source of all things, the faith in God. In the very neighborhood of Florida Space Center, he is now a minister of the parish of the Good Shepherd. At a few miles distance, in Cocoa Beach on the other side of the famous base, Dr. Kurt Diebus lives, co-designer, founder, and former director of Cape Kennedy. Diebus, also one of the 118 from Peenemünde, retired in 1974. In close cooperation with von Braun, he was involved with all NASA projects, Mercury, Gemini, and especially Apollo and Skylab. As the responsible man for the course of events at Cape Kennedy, with 26,000 employees in 1969, he still controlled his brainchild after the Apollo project had finished.
So we had to find a way to transport it vertically, and that is how we execute the total program.
But how can you compare it with the system the Soviet Union is doing it? Because they are still transporting their huge rockets by train.
Well, I
and
do
even
not
lifting
wish
it up.
to comment on how the rockets are working.
Okay.
How was it for you to come out of Germany and to start here in America? And
we were originally shipped over here for exploitation, but then it was recognized that our original intent to go to the west or not to support the east with what we had in our archive and in our heads was recognized, and then we were asked to do something to help the west in building up a new rocket. The Korean War came along about that time, and great hopes was put on the development of a 150-mile rocket, which later became the Redstone rocket.
I know, yeah.
And then we had full support with very minimal means. I mean, for several years we had $5 million or something.
I know.
Yes, it was a very small effort, but it worked out, and the group got busy and started to develop American engineers into our line of thinking.
Es war eine unvergessliche Angelegenheit für mich. Wir hatten Herrn McElroy den ganzen Tag hier rumgeführt, auf unserem Redstone Arsenal Einrichtungen, Prüfständen und so weiter. Und etwa nachmittags um 4:30 oder so zog er sich für eine Stunde auf sein Zimmer zurück, um sich zu waschen und umzuziehen. Und wir wollten uns dann zum Abendessen wieder treffen. Und ich ging während dieser einen Stunde in mein Büro rauf. Plötzlich klingelte das Telefon und da war ein Reporter von New York am Apparat und er fragte mich, was ich denn für einen Kommentar dazu hätte. Und ich fragte ihn, wozu? Ich hatte keine Ahnung. Und er sagte, ja, haben Sie denn nicht gehört, die Russen haben gerade eben einen Satelliten erfolgreich in den Orbit gebracht. Und Sie können sich vorstellen, dass das natürlich das Gespräch des Abends war. Und ich sagte dann dem neuen Verteidigungsminister, er hatte noch nicht sein Amt angetreten, er war noch auf einer Rundreise, um sich zu orientieren. Und ich glaube, er trat sein Amt erst 4 Wochen später an. Ich sagte ihm, wenn Sie nach Washington zurückkommen und Sie finden, dass da die Hölle los ist über diese russische Leistung, dann erinnern Sie sich bitte daran, dass wir binnen 60 Tagen das auch machen können, einen Satelliten in die Umlaufbahn zu bringen. Mein Boss damals, der General Bruce Maderas, der unterbrach mich dann und sagte, Werner, wollen wir es nicht lieber 90 Tage machen als 60?
Yeah, that's one of the best stories around, because it happened that the newly named Secretary of Defense, McElroy, who was taking Mr. Wilson's place as Secretary of Defense, was on a trip around to the various installations to get acquainted and was visiting us at Huntsville, the Missile Command, the night that we got word of the launching of the first Sputnik. The message was delivered to me and immediately to some other people there and began to be buzzed, and Werner and I, as if we had been galvanized by the same spring, we got a hold of McElroy. We practically almost got a hold of him physically. We both of us, I think, felt like shaking him. He was the upcoming Secretary of Defense. And all we could say was, see, this is what's happened. Now, we can put something around in orbit, and we can do it, and we know we can do it, but nobody will let us, and we were on him.
Well, the shock here was fantastic. A shockwave came, we had...
Where were you, Tony?
I was in Huntsville together with Werner von Braun, and the incoming Secretary of Defense, McElroy, was just visiting. And there was a general on my left, and Werner was called out and came back, red head, and he said, Mr. Secretary, the Russians just launched their first satellite. The star went up in the east. And the general on my side said, oh, that little bauble. But it
That
made...
was not General Medaris.
No, no, oh no, on the contrary, but I do not wish to say the name. That little bauble, and I think he would have liked to eat his words later on.
And I still remember that Werner said we could do it in 60 days, and I said, no, Werner, that's too fast. We can do it in 90 days, and we did in 90 days.
Good morning, gentlemen. Be seated, please. I have a very important announcement for you. We've been assigned the mission of launching a scientific Earth satellite. And we will use the Jupiter-C configuration as a carrier that we developed along with the Jet Propulsion Laboratory. I promised the Secretary of the Army that we would be ready in 90 days or less. Let's go, Werner.
Nahmen also die 90 Tage an und wir haben es nachher, glaube ich, nach 81 Tagen geschafft.
Sie haben es eingehalten?
Ja, wir bekamen das grüne Licht nicht gleich, weil Mr. McElroy ja natürlich das Amt noch nicht angetreten hatte. Aber 2 Tage nachdem er Verteidigungsminister wurde, bekamen wir ein Telegramm. Es hieß ganz einfach, go ahead, McElroy.
A moment of triumph for General Medaris and his staff. Werner von Braun and his technicians now try to reduce the Soviets' lead as much as possible. Elsewhere in the United States, people are working on the satellite, which has to be taken into space by the Jupiter of the Army. The leadership is in the hands of James Van Allen. But a very keen competition for the lead in space exploration arises between the Army, the Air Force, and the Navy. The consequences are disastrous. A premature dream of the Navy vanishes into thin air.
I put it this way, that we cannot and will not ever get into this race as we should, so long as all of our objectives are short-term objectives. We've got to have no finite end to our objectives. The end of our objectives should be as far as we can see at any given time. But right now, we need a 10 to 12-year program that has as its ultimate goal the manned domination of space. And if we don't, we're going to be in trouble.
Fuel loading. Okay. Check the utility room fuel vapors and notify the blockhouse when we're clear to start generators. Connect assembly to igniters. Okay, tie down the lead. Roger, install your protective tabs. AFMTC telemeter calibration tape on. Check all operating lights and meters for proper operation. Power panel check. Power panel okay. Control panel check. Control panel okay. Roger. Measuring panel check. Measuring panel okay. Power transfer test on. Observe and record all voltages. Power transfer test on.
What's the clear for launch? Clear to launch. Yeah. 021, deflection of jet main number 2. We've either got a relay kicking out or there's something dropping down on the jet main instantaneously here.
Hold. Telemeter indicates the jet vane 2 is deflected. What do you want to do?
Forget it.
Okay, resume count.
Okay, shall we go ahead, Jim? It looks like it. Roger. Instruct arm. Left complete. All right, give me range safety, stand safety. Stand safety, range safety. Right. Safe. JPL telemetry recording on. Telemetry recording on. JPL recording on? Yes. 20 seconds. Frequency 111, Terry. Right, there's 15 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Fire command. Fire command. Fuel tank pressurized. Block tank pressurized. Missile power. Ignition. Main tank. Lift off. Lift off.
The liftoff was a success, but it seemed an eternity before the first signals arrived from space that the satellite had reached its orbit.
Hello, Lem. You can send this off to the secretary. That our satellite is definitely on orbit.
The 31st of October 1957, there was an article in a Dutch newspaper that there were 6 satellites ready in the United States to be launched before Sputnik 1. Is that a true story?
No, that's a slight exaggeration. The fact is that the basic...
in Huntsville?
Yes,
in
the basic vehicles were there. We had 6 of the 3-stage vehicles. We had no completed 4th stage, which was the satellite itself, but was also the final accelerator. And so it would not be proper to say that there were 6 that were ready to launch, because even after we did get the word to go ahead, we were on about as fast a time scale as we could have made to do it in about 90 days. To get them ready, finish them off, get some experiment in the satellite itself,
testing
get a
facilities.
compatible beeper system in there to communicate with the ground, and test and be confident of the capability of the 4th stage. It took that long. So you couldn't say they were ready. We had the basic hardware, but not the satellites.
We had offered to launch the first satellite a long time, and we had one ready to go. We had a long-range missile based on the same principle, only no satellite in it, no solid rocket stage on that very last end. And I was inspected here whether we had or did not have a solid rocket on that payload. And because one was afraid we would put one in. So over a year we were capable of launching a satellite and were not permitted to. For reasons, General Eisenhower, the president at that time, did not wish to have a military rocket deliver a so-called peaceful satellite. It was the International Geophysical League, and he didn't want to do it. But he was influenced by groups of people, which is pretty well known today. And it was an inter-service fight. The various branches of the services were fighting each other, and so the poor army was standing by with a ready satellite and wasn't permitted to launch it. But I think it was all to the good of the country, because when Sputnik 1 came up and came over the horizon with this beep, which is beeping today in Russia, if you visit Russia, I'm told, the remote villages, every radio announcer, whenever there's a break, what we have as signs here, that is a beep, 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 reminding how great they are.
I think we had an impressive number of successful satellite and deep space flights during the past year. And I think in the area of scientific achievement, in the field of space exploration, we probably have caught up very well. In fact, many people believe that we have produced more scientific knowledge with our smaller vehicles than the Russians have with their much larger ones.
Do you share that opinion?
In the scientific field, yes, sir. But I believe the Russians still have an edge on us in the payload capability, and it is for this reason that it is felt that the Saturn booster is so vitally necessary. The Saturn booster will be at least twice as powerful as the most powerful rocket, Russian rocket, demonstrated so far. And if we continue working on the Saturn on an accelerated rate, we feel we have a very good chance of catching up with the present Russian payload capabilities.
Do you feel better now that the president has asked for more money for Saturn?
Oh, yes, definitely.
More secure? I mean...
Well, it's just, it used to be a shoestring program, and now we can really develop a sound program with emphasis on reliability and component testing and all the other things we couldn't afford so far.
Dr. von Braun, how would you say we stand in relation to the Russians, and do you think we can ever catch up?
I'm convinced that in the space field, the Russians are ahead of us, particularly in large weightlifting capability, and that at the moment the problem is not so much to catch up, but first build up the working speed that they have already demonstrated. After we are running as fast as they do, there's still a considerable gap to close, and only the future will tell whether we'll manage to close that gap.
I believe that this nation should commit itself to achieving the goal before this decade is out of landing a man on the moon and returning him safely to the earth.
A gigantic launching site was built on Cape Canaveral. More than $1 billion were appropriated by the American Congress to adapt this out-of-the-way corner of Florida to the building and launching of Saturn rockets. A huge assembling building, large control rooms, 2 launching pads, press sites, and working and eating facilities for 50,000 people were built. In contrast to President Eisenhower, President Kennedy made this development possible. At regular intervals, he showed his personal interest.
On the next flight, we have no useful payload at all. The problem here is nobody wants to entrust a multi-million-dollar payload to a completely unproven launch vehicle. For that reason, we fly the next test, lavishly instrumented for launch vehicle development, but with no useful payload whatsoever. We just have a water tank in the nose.
But there was also great disaster in this tumultuous period in development of the American space program. During a launching tryout on the Cape, the first Apollo capsule was burned out completely. 3 astronauts got killed. The historic Christmas Eve of 1968. Apollo 8. 3 men on their way to another planet. The moon described from very near. A Christmas message to all people on Earth.
And the earth was without form and void, and darkness was upon the face of the deep. And the Spirit of God moved upon the face of the waters. And God said, "Let there be light." And there was light. And God saw the light, Day was good, and God divided the light from the darkness.
And then, July 20, 1969, Apollo 11, 2 people set foot on the moon. From Peenemünde to Apollo's Eagle, the dream of the 118 from Germany has become reality. John F. Kennedy's promise of May 25, 1961, redeemed. The end of an era.
30 seconds. Contact light. Okay, engine stop. ACA at a descent. Mode control both auto, descent engine command override off. Engine arm off. 113 is in. We copy you down, Eagle. Listen, Tranquility Base here. The Eagle has landed. Roger, Tranquility. We copy you on the ground. You got a bunch of guys about to turn blue. We're breathing again. Thanks a lot. Thank you. That's one small step for man, one giant leap for mankind. As the
In his hometown of Huntsville, Alabama, all admiration of the excited spectators fell to Werner von Braun, who has been the drive behind his American space success.
When I was 17 and started all this, the moon looked a lot closer to me than it did for a long, long time in between. Today it looks again very close, but in the meantime, of course, we've learned a few things. Among others, I've learned, for example, what $1 billion is, something I had no conception for in the early days.
You know, these brainy people I had to work with, they had all kinds of ideas. And when you work with rockets and see this tremendous power set free in a test stand, you think, for what can we use this power? And our idea was to use the power to get up out of the atmosphere in space. We were space fanatics. We wanted to go to the stars. We wanted to go first to the moon. And we talked about it. It's a casino. It's a bowling alley. At families. We talked about it. But we worked on a weapon. And somebody in the German hierarchy decided we should be supervised. And they sent some spies in our private discussions, and they listened to our boasting of our people. They want to go to the moon. And then Hitler said, in a war, talking about going to the moon, they should make the rocket ready for operation at the front and not going to the moon. They did sabotage. They didn't spend their energy for the weapons. They spent their energy for dreams. And therefore Braun and 3 of his boys were arrested and put in jail. It took me I went there to Hitler's headquarters and told him how the situation is. And he said, okay, if you guarantee and vote, give me your oath, that without these people the weapon cannot be finished, you get them free. I did, and I got them free.
Well, I think it does matter a great deal. I remember I was a very young man in Germany, and I was so busy with my rockets that maybe in retrospect I sometimes wonder whether I shouldn't have worried a little more about some of these aspects. And as I grew older, of course, and saw the ramifications, of course, also the suffering that's involved, you rethink some of these things. On the other hand, I do not believe that I'm all alone in this respect, because I think, as I see, the early pioneers in aviation probably went through exactly the same thing. They wanted to fly, and they tried to find the money wherever they could get it to do these things.
Still, many people wonder whether the technical developments, which were originated by space travel, have contributed to a peaceful society on Earth.
glaube, dass sowohl in der Wissenschaft als auch in der Technologie es absolut notwendig ist, dass ein Stimulus vorhanden ist, der die Wissenschaften und die Technologien zu Höchstleistungen anspornt. Die Raumfahrt hat sich hier, als in den Vereinigten Staaten zumindest, und ich glaube in Russland auch, als bei weitem der effektivste Stimulus erwiesen, einfach weil sie in praktisch alle Gebiete der Naturwissenschaften und der Technologie hereingreift. Sie verlangt von den Medizinern Sachen, die Mediziner nicht können, und von den Materialleuten Sachen, die Materialleute nicht können, von den Elektronikern Schaltungen, die nicht konnten und so weiter. So geht das im ganzen Gebiet. Ja. Selbst die Kernphysik ist drin mit elektrischer Stromerzeugung im Weltraum. Und ich glaube, wenn man heute der amerikanischen Industrie und der amerikanischen Wissenschaft diesen Stimulus wegnehmen würde, dann würde das zu ganz katastrophalen Folgen führen. Und ich habe auch das Gefühl, dass in der Sowjetunion genau dasselbe gilt und dass dies einer der Hauptgründe ist, warum die beiden größten Länder der Welt so viel Geld für diese Sache ausgeben.
The more deeply you go into science, the more you're compelled to know that the universe is no accident. And if it's no accident, then somebody planned it. And the existence of a supreme God, to me, is absolutely an inevitable conclusion of a person who really goes objectively into the depths of science.
Yeah, Werner von Braun turned into a religious man too. May I remind you, I tell you the story about the question, what should be the answer to the problems in the world? There was one day a representative, a reporter from the Christian Science Monitor, who came to von Braun and talked for days in his house with him about these problems in the world, what the answers were. And they didn't come up with one clear answer. And finally the reporter asked him, but I had to write in my paper that you have an answer. What is your answer to all the problems in the world? And Braun told him, you should go more to church and pray more. That will help.
How would you rate his contribution, in fact, to
his contribution
space?
Is enormous. It's very difficult even to limit. His, the push he gave his total cause and the ideas he put to work in building these large boosters and in use of space, the satellites, the space stations that he proposed, all of that had a tremendous influence on the development of this, the rocketry and space use.
Throughout that whole command, von Braun with the scientists and the people of technology in the laboratories, and then with the military that had been handpicked to support the other parts of the operation and bring industry in with it. See, we depended a lot on industry. We had a communication net that was superb with the industries that were supporting us. The whole thing was just a smooth, very smooth, well-oiled machine.
He was certainly the most challenging boss to work for and to work with. He is an extremely unusual man in every respect, very outstanding in his talent, in his brilliance, in his flow of ideas, in his capability to be a leader, to produce not only new ideas but solutions to problems which seem insoluble at first. And besides that, he's an extremely pleasant man. I recall that I was sitting with him in hundreds of meetings, and many of the meetings on very serious and difficult and problematic subjects. But I do not believe that there was any 15-minute period in which not all of us laughed heartily from the bottom of our hearts because he had made such a good joke.